No worries. Come back anytime. In the meantime, we have some non-legit flat earthers here, like Lipsical. He's like a baby. He doesn't know what's going on. You debate him.
Don't debate me. I don't debate through the spoken word.
He debates through the art of interpretive dance.
Exactly.
Well, I wouldn't like to have to debate against something like water's level. Gas pressure requires a container. I feel like those would be hard things to debate against.
You also have to realize that none of this is in contention.
Well, it is if you believe reversible.
Is it that you believe that the Earth is flat, or that you deny that the Earth is a globe? Like, which one is it?
Neither.
Yeah, I mean, flat Earth is quite a loaded term, right? Because obviously it's not perfectly flat. It's got hills and valleys. It's topographical. But yeah, the position would be that the surface is not curving down and away from us into a ball. It's just a level, topographical, motionless plane, as far as can be observed and measured.
Yeah, that's what I meant when I suggested flat Earth. Okay.
Yeah, but it's also not a belief.
What?
It's not a belief either. Belief is not required.
It is.
I mean, it's a,
No,
you can
it's
call
not.
it a belief or an opinion. It doesn't matter. It's not a fact.
Yeah, the distinguishment that we would make there would be with regards to direct observation and experience, right? Yeah. So this is what we actually experience the world to be. That's what we are accepting. We don't experience any curvature or motion of the surface. We only observe and can measure to whatever extent that it's flat and motionless, level and motionless, like large bodies of water. They're not curving down away from us.
Yeah, you never present any of those measurements.
Yeah, we don't have a Discord Globy religion like AK.
Oh no, I don't have a religion either. I officially don't have a religion, actually.
AK's part of that 3959 denier.
I wanted to ask if you guys have any, if you guys have any model that I could look at.
Hell no! Don't even ask such a thing.
No, we wouldn't really create a model. We would just go with what can be observed and understood about.
Well, it depends
the
on what
nature of the Earth.
What aspect are you looking to have modeled?
Like seasons, for example, night and day.
Okay, can you show the current model you're using for that? Let's look at that.
Like the globe model, it's already out there.
What for seasons? What's your model for seasons? Let's see what that looks like.
Well, you can basically just Google it anywhere. That's not hard to find.
No, your model. Do you have a model for seasons, or you don't?
It's not my model. It's the globe model.
Well, what model would you use if you were to model seasons?
The globe model.
Okay, can you show that?
But you disagree with that opinion, so I want to see.
No, let's see your model, so we know, everyone here knows exactly what you're talking about when you say the word model.
First, bro, he asked for a flat Earth model first, and he didn't get it.
Yeah, what does he mean by a model?
A model, anything.
All glory. You don't need to be jumping in, bro. He can talk for himself.
What? 2v1, 3.
Wow. Why are these guys coming in already pressed?
Just to be clear, I'm not trying to be
okay, because I'll tell you what's going on here. Okay, my epistemology is a model is a reification fallacy. Even more so if you call it this is reality. So I purposely only use models for specific values or conditions. Like I would model out the sun, the movement of the sun, or I would model out the surface of the Earth. I wouldn't do. Okay, so what do you have where you would show your model? What do you use So I know what you're talking. I know what I'm talking about when I say model. What do you mean?
Is basically a construct of which you can predict certain aspects and patterns that we witness throughout a year.
Okay, how about in your globe model, do you factor in Mars as part of the reason for why there's seasons?
No, I do not.
Okay, well here, let me show you then. You have a different model than is currently being presented.
I'm talking about the accepted globe model that everyone uses and knows, like the simple.
Here's accepted. The accepted globe model just dropped a week ago, so they have a brand new model. Their model is now only 1 week old. Okay, this dropped. Every 2.4 million years, Mars' orbit comes close enough to Earth that its gravity can affect it, tilting Earth's usual path and orientation. This orbital shift causes the Earth to be exposed to more sunlight, warming the climate. In turn, stirs up ocean currents and makes them stronger. Did your model account for Mars' gravity for seasons?
For seasons, not necessarily. No.
Okay, so your model has now been debunked because the current model, the current globe model,
not necessarily debunked. It could be brought in to strengthen certain aspects that we didn't see earlier. Maybe just make them more, explain them in more detail as to why exactly it behaves in a certain way. Doesn't necessarily debunk it. Doesn't mean that all of the globe model is now out the window, or you can.
Yeah, this is a brand new model. The old model is in the dumpster. No, it's completely different. It's completely.
But let's look at the basic fundamental model. Like you have the globe Earth, obviously tilting on its axis, heliocentric sun, which we revolve around, and then we have the other planets around us.
Yeah, and Mars. Now Mars affects Earth every 2.4 million years.
Let's exclude Mars for the.
Why would you exclude Mars? This is part of the model.
Just for the sake of the conversation. For
the sake of the conversation, Mars now has a deep, profound impact on the Earth's climate.
Deep, profound impact. Wait a second. What is the magnitude of the impact, Kurt?
Yeah, the record-setting temperatures. All year, there's been breaking the mold, That's why they had
due to Mars. Is that claimed to be due to Mars?
Due to Mars, yeah.
Well, hold on. Let's keep it with Jeff here.
Can you please provide some evidence for that? Because all you've established so far is that Mars every 2.72.
We're going to keep it with Jeff here. But Jeff, let me just quickly say, I would say the issue with talking about models is that you end up assuming a bunch of things that you don't know, right? So I would say you're better thinking about observation and measurement of what you can verify. Because if you're assuming that it's working over a curved surface, that's an assumption.
But when he brings up Mars and starts talking about ocean currents, that's you're over complicating things. I'm talking about simple things like basic fundamentals, like seasons.
Right, but he's talking about what the mainstream guys that you're in essence trying to support, because you're going for the globe model. Well, this is what they're currently speaking about with regards to the globe model. Now, you might have an idea in your head, like a simplified version. But I mean, he's showing you what they're actually saying,
if you want to
including variables that you can't really speak to. But.
See, what I'm showing you is that you're in heresy right now. You are direct contra. You don't believe the current model either. Same with me.
I didn't say I didn't believe it. First of all, I said
their current model said Mars affects Earth's weather patterns.
Well, it may very well be. I'm not saying that it's not the case. I'm saying that I did not look into this specific study, and it requires understanding of how cosmology and stuff that are kind of complicated to understand the exact patterns that are changing due to the effect of Mars. It doesn't mean it's not true. I'm just saying it's kind of complicated to just dive into it out of nowhere.
What?
What do you mean, what?
Right. Well, before we get into the weeds on the models, if you're kind of asking generally, well, how would seasons and day and night work?
I can look at because I want to know, your perspective, what does.
Well, I would say I would say that would be caused due to the sun's motion over the Earth's surface, right?
Can you explain then how the sun, like for example, we know for fact that during like in the northern hemisphere during the summers we have very long days, often not with the sun not even setting. So that's
Mm.
easy to explain in a flat Earth model. But once you go down to the south and you have winter in the northern hemisphere, how is it that the do you actually have like Antarctica on the flat Earth model? Is it like
Well, I
the
don't have a flat Earth model. I just have what we can observe
well?
directly
Do you
in
have a
reality.
map? Do you have a map with like scale
No,
or
no, I wouldn't. I wouldn't. I mean, you can't
why?
map the entirety of the Earth. Certainly, I couldn't.
I mean,
You could.
we can map
You
certain
could.
places that we know exist, right? Like we know how to fly
You
to
could maybe
certain.
lack. You could maybe map your local area. Yeah,
No,
but
no,
the
no. But,
Earth,
but we have
no.
flights. We can fly internationally. We know exactly where the
Yeah, yeah,
islands
yeah.
are.
You can get in a plane and you can fly from one port to another. Yeah, over a level, motionless Earth. You can do that. Yeah.
You can do that even in a rotating sphere, but that's besides the point.
Well,
I'm just
no,
saying,
because
like,
the planes don't treat the Earth as a rotating sphere. Treat it as a level, motionless surface.
well, they kind of do, but they don't have to really take into account the Earth's curvature because they're just talking about like 1 degree towards the
Or
ground.
because it doesn't exist.
Or that could be the case. I'm not gonna deny what you're saying. I just want to legit
Yeah, yeah.
understand your viewpoint.
Yeah, yeah. So
Like,
my viewpoint is that whatever the sun is doing, it's moving in its repeated cycles above the surface of the Earth as we see it. We see it move through the sky every single day, and it
so
has different. It
how
has
do
a
you
pattern
explain?
over the course of a year, and it
Yeah.
goes where it goes. And I
So
mean,
how
I'm
do you
not going to
explain?
claim to know its exact pattern or its exact position all over
Okay,
the Earth because I can't verify that.
okay, so here's the thing. Two things. First of all, we know that Antarctica has basically steady sunlight throughout the winter. That's like impossible to have in a flat Earth model.
Well, I've
The
not
second
I've not stayed in Antarctica through a winter or a summer, so I wouldn't know.
well, we have cameras. We have people who live in
Mm.
Antarctica. It's not like some
But
magical place that
we also have people who have claimed to have taken video of a 24-hour sun in Antarctica, and when you analyze the video, they looped it to
well, you
mislead
can do it
people.
yourself. You don't need
So
it
we
to
have
rely on
people
you.
faking footage of the sun's behavior in Antarctica, which then makes you have to say, okay, I can look at videos which claim to be showing certain things about Antarctica, but I can't verify them. And I know that other people have tried to fake these for some reason. So how do I know if it's true or not?
Are you will you be willing to fly to Antarctica to verify this?
Ooh, you gonna fly me to Antarctica?
I mean, if the thing about like
Hook me up,
the
bro.
flat earthers that I find hard to understand is you could easily prove that globers are wrong if you just did some of the things that you actually claim are false. Like you could
It's
basically just
already
fly
been proven. And you don't need
what's
to
been
fly to Antarctica. You just need to observe line of sight. Shoot a laser
okay,
over a lake.
we'll get to line of
These have
sight, but
already been done, and they already debunk the globe. So no, we don't need to go to Antarctica. You can just measure a 10-mile lake and see if it curves. Can you not?
no, because that's not how it works. It doesn't curve every 10 miles.
Oh,
And even if it does
oh wait.
curve,
So
the
there's
curve
no curve over
is
10
so minuscule
miles.
that you won't notice it.
So there's no curve over
You
10
won't be able
miles.
to notice curvature of the Earth with your bare eyes. Never.
Well, how much curvature do they claim should exist over 10 miles?
Well, there's a certain formula that you can apply, which
Hmm.
is
And what does it say for 10 miles?
I think it's like 10 miles is like 6 inches or something like that. I don't really remember the
6
numbers, but
inches. What if I told you it's over 60 feet?
that sounds exaggerated and sounds wrong. Can you show me
Sounds
the
wrong.
formula?
Yeah.
Can you show me the formula you
Well,
use?
if you go on Google and you type in curve calculator, click on any of them, there's a bunch of them, and then you can type in your distance, your observer height, and it will tell you, according to Earth being a sphere with a 3,959-mile radius, what the curvature should be over the distance that you're observing, right? And it will tell you where the horizon should be, how much hidden height there should be based on what you're trying to look at. So you can look it up. So over 10 miles, the geometric curvature they claim is 66.6 feet. So that's like a 3-story building, 4-story building maybe. So that would be quite apparent if you were to try and shoot a laser or see to the other side of that lake. So yeah, these tests have already been done, which is why it's kind of like unnecessary to talk about going to Antarctica and all this kind of thing. You can just go to a local lake, prove it doesn't curve. Job done.
A lake is not far enough to prove that there's no curvature, though. You have to.
Well, if it's like 10 miles, yeah, there's supposed to be curvature there between A and B.
The curvature is
One side to the
minuscule. You
other.
won't even notice it. It's so
No, I
small.
told you, over 66 feet, they say.
I don't know where you read 66 feet from. That doesn't sound connected to reality at all.
Well, that's what they tell you is the globe model reality. So, hey, if you're already realizing that's not reality, good for you.
True, then you wouldn't be able to see anything. Like what you're saying is basically true. Then you wouldn't be able to see if there's no curvature.
All right, well,
which is what
if that's
basically-
untrue, go onto a curve calculator and tell me what it tells you.
Let's see. Distance to object. Let's say you said 10 miles, right?
Yeah.
Eyesight level. Let's just say 0. Ground level. Oh, let's say 1 point. Well, how am I supposed to calculate the distance to the horizon?
Well, it can tell you that if the horizon is the curve of the ball based on your observer height, it will just be the tangent line from your eye to that point of the ball that you can no longer see around. Like the limit of your view, that would be your geometric globe horizon. And for a 6-foot observer, they'll tell you that should be about, 3 miles?
I'm getting like for a 1.8. Well, I don't use like I use a different metric system, so I apologize. I use meters and kilometers. So
yeah, so about 1.8 meters, that's about 6 feet, right?
Yeah, 1.8 meters, and I'm looking at distance to horizon. Let's say how many kilometers?
I think it's 5 kilometers, would it be? But that should calculate that for you. They should be telling you what the distance to the horizon should
5 kilometers. We're talking like 9 meters over 10 miles. Sorry.
9 meters.
9 meters over 10 miles. Yeah, if you're 1.8 meters.
Okay, so what would the hidden height of that be?
You're right. It actually does calculate the distance to the horizon by itself. Okay, so that's 10 miles, 1.8 meters, and I'm getting 10 meters of obscured object part.
Right. So if there was another person on the other side of that lake, he's supposed to be hidden beneath the curvature, right?
If he's on the same ground, if you're both
on the same ground. If you're like at the same level,
yes,
you're just standing at the side of the lake, right? So this is what people are doing. They're going down to the lakes and they're seeing if they can see each other and shine lasers to each other and all kinds of things on the other side of the lake, and they can. There's no 10 meters of curved water.
I saw
yeah. You saw the Netflix one, which was a failed attempt to do something like that. They had a laser, so they used a flashlight, and the results were agreed by all sides, according to the people who were there, as inconclusive. So they were going to go and do it again. But the makers of the documentary instead decided to edit it in a way that looks like they're going, "Oh, Earth must be a globe." So now people go around saying the flat earthers proved the globe, which is hilarious. But no, those kind of experiments have been done plenty of times, and there's no curve. So if you want to see some of those, I would suggest you go onto our server, which is 24/7 Flat Earth Discord, discord.gg/Flat Earth. There's an additional information section, and it's all alphabetized. And under L, there's long distance observations and laser tests. And you can see a whole heap of these things. It's very easy to do. Now you have the calculators, you can go and do it yourself wherever you live. Horizon distance doesn't work either.
Curvature thing, but if we put curvature aside, what would you say?
Well, this is the thing. You can't really put the curvature aside, because anytime that we hear the argument of something like, well, gravity, or what about this occurring, the seasons, then it would be the case of, well, whatever that's doing, it's doing it above a non-curved surface because we measured the curved bit and it's not there. So your story about the curved surface, that can't possibly be true. Not to say that we're necessarily going to have answers for every question, but we certainly know that the answer cannot be, well, the Earth's surface is curved and then this is happening.
Curvature, how far, what's limiting us from seeing like into infinity, basically from here to Australia, for example?
Yeah. So there's still, I mean, you can see further than you should do on a globe, but that doesn't mean that you can see forever. I mean, there's always limits. And the optic itself, like your eye has an optical limit, an angular resolution limit. You're also looking through a medium, air, which is not transparent and builds up over a distance. Same way, if you were to go underwater diving or something, you can see, say, 10, 15 feet in front of you maybe, but then the water over a distance builds up to the point that you can't penetrate it. The light doesn't get through. The same thing happens with air, but over a much greater distance, because air is like imagine like a very thin water. Right? So over a distance, it still obstructs light. The light doesn't travel infinitely. Also, the closer to the surface you're looking, that's like the thicker concentration of the atmo. So because there's a lot of things that play into, I mean, as well, perspective. So there's a lot of things that play into why we see the way we see. And when you're looking into this subject, it's a good idea to look into things like optics, perspective, because you really need to think about why you see the world the way you see it. Because they've hijacked certain elements of our perspective in order to convince us that the Earth is a ball. For example, the argument that ships disappear bottom up on the horizon due to curvature. This is actually a function of perspective and one that you can demonstrate yourself. If you go into a long corridor or have a long table and you put your eye down to the level of the surface and you pull an object away from you over that distance, you will see that the bottom of it starts to disappear first, right? And that's a function of perspective.
Earth's curvature is not something you can witness with your bare eyes, with like the naked eye. It's not something you can see from.
Actually, you can if you go far enough.
But have you never heard them say boats disappear?
I mean, just like we hear the telescope and see other planets, you know, we can have.
Hold on, Scott, I was speaking to Jeff here.
I'm saying, like,
so Jeff, you've heard them say boats go over the horizon, right?
Yes. Obviously, they disappear.
So that's them saying. That's them saying that we are seeing the effects of this curvature. Not necessarily that you'd see the curve itself, but we're seeing things go over it. That's their claim. But again, this is a function of perspective, not a curved surface. So.
But we can still argue for the shape without even looking at curvature. Like, there's plenty of other evidence I can bring.
Well, you can't, though. You'd have to ignore the fact that the lakes are not curved.
Well, I mean...
And that the oceans aren't curved and the water's flat. You can't ignore that and just say, well, let's just assume that the Earth's a ball even though there's no curve. It doesn't.
No,
that is nonsensical.
But I can bring other statements and other proof of evidence that the Earth is curved without using the curvature of the Earth.
No, you would have to directly evidence that there is curvature of the surface. Otherwise, it's an assumption. And when that assumption is checked and it's found not to be there, you're ignoring the fact that there's no curvature there. It cannot be ignored. This is the one thing that you have to really at least start with, right? If you wanted to prove the Earth is a ball, you would have to, first, prove that the surface is curved. If you wanted to prove that the Earth is a spinning ball, you would have to, after verifying that there's curve, prove that it's in motion. If you wanted to prove that it's a spinning ball in a vacuum of space, you would then have to, after proving curvature and motion, prove that you can have gas pressure existing without a container next to a vacuum. So curvature is number one of the spinning ball story. If you don't have curvature, you've just got stories.
If you stood on a flat Earth and you just walked in a certain direction, right? You would basically, because I don't know how your model works, but basically on a globe model, you walk in a certain direction, you're going to be ending up, if you continue to keep the same direction, like an angle using a compass, you would walk and you would eventually end up, as all flights do, on the same place you started.
in both ideas, it would be a circle.
How? If you're keeping the same.
That's why it's called circumnavigation. That's why it's called circumnavigation, because it's a circle, right? So in a globe, you're going in a circle around the globe. On a level surface, you're going in a circle on the level surface.
But then you're changing angle to create a circle. You're not doing that in.
Well, you're always navigating in reference to north. This is how people navigate.
Yeah, but
correcting for north.
North in a globe is towards the top of the globe, basically, or towards like true north.
Well, east to west though is a circle in reference to that north.
So what's south in a flat Earth model, for example?
I would say it's any direction away from north. The direction.
Okay. So if we're all looking south, and let's say I'm on a globe model, okay? I'm looking towards south, right? So I should be seeing. How do you explain, for example, when we all look south on a globe model, we all see the same constellation of stars. How is it if we're standing on a flat Earth and we're all looking south, which could be in any direction, how is it that we see the same constellations and we're all looking in different directions? How can you explain that?
Well, I mean, there's no real reason that I need to explain what we're observing in the sky with regards to the stars. I wouldn't claim to have a full understanding of what we're observing and why we're observing it. But you would need to specify exactly what locations you're talking about, exactly what stars you're observing, what the local times are for those observations.
We're both standing in the southern hemisphere, okay? We're both looking south, but we see the same thing. That does not correlate.
Well, I don't know that. That's what I'm saying you would have to evidence. And from where, exactly?
That's what we have.
So simultaneous observations in the south.
And angles.
Is this something that someone's saying?
Sorry, I didn't hear what you said.
So you're talking about simultaneous observations of the stars in the south, basically.
True. But not just the south.
So which example?
The north hemisphere sees other stars that the south can't see, even though they'll look in the same direction. So, like if people on the southern hemisphere look towards the north, it won't be able to see the north stars or the constellations in the north hemisphere because they can't see through basically the globe.
Okay, so you're asking why do you see different ones in the north than in the south?
If you can let me finish my point, please. So I'm just saying, like, on a flat Earth, we should all be able to observe the same stars or the same constellations. There should be no limit to what we should be able to see in the sky.
Well, no, that's your claim. That's not something I would assume. Why would you assume that?
Well, why is it not true then? Like,
because you cannot see infinitely. We all have limitations to our view. So any argument that begins with we should be able to see all of this at the same time, no matter where we are, doesn't even align with our basic understanding of perspective and optical limitations. Of course not. So if you're under a different part of the sky, you're going to see a different part of the sky. Pretty simple to me.
All the people on the southern hemisphere see the same sky. Like if you're looking.
Well, that's what you're claiming. I don't know what you mean by that.
I mean that if
they all see the same sky.
If it's nighttime on the southern hemisphere, and we're all looking towards the stars, we can theoretically see all the same stars.
Can you theoretically or in reality?
In reality.
Okay, show me the observation that you're talking about.
Sure. I mean, we can all test this. It's not something that I'm just throwing out in the air. Like this is like so we're talking stars. We're talking that was one of the points. There's also like eclipses. Eclipses also when you see the shape of the Earth basically on the moon, it's always curved in a certain shape, which can only be explained, like the only geometric shape that can show a curved shape on the moon from any angle to the sun is a sphere.
Why are you assuming it's a shadow cast by Earth?
Well, then what's casting the shadow on the moon?
See, what else could it be is not proof of what you've been told it is.
I mean, what else is standing between the moon and Earth that could cast the shadow?
You don't know that it is a function of something standing between something and something else. The moon could be its own light, doing its own thing.
The moon could be its own light?
Yeah, so you've got the assumption that the moon is reflecting sunlight, and that's why it appears to be a light in the sky.
Just like Earth or all the other constellations, and the only thing that's actually
so that's your assumption based on what you've been told. But what I'm telling you is that is not proof. That is you being told a story and then saying, what else could it be? That is not an elimination of all other possibilities. It's simply you accepting the one story you've been told.
Okay, what about tides then?
What about them?
Like, how do you explain tides on a flat Earth? Why would the tides go up and down according to certain positions?
I wouldn't really need to. Why would I need to explain tides?
I mean, you have to explain like how your model works.
Do I?
You can't just say I don't understand.
Do I need to explain tides to know that my friend on a lake 10 miles away from me is still visible, thus no curvature?
You keep bringing up the lake example, but again,
because it debunks the globe. That's the whole point.
It doesn't
right?
debunk
And
the globe.
it's yes, it does, because that curvature isn't there that you need for the globe.
I mean,
so it does.
I don't know how to engage with a certain viewpoint. I can like research it more and come back with an answer.
It's like Pandora's box, right? You open Pandora's box, i.e., you measure the surface and find that there's no curvature. How then do you go about proving that the Earth is a ball, having already demonstrated that there is no curvature?
Well, I'm going to have to look at all of the certain aspects of how this experiment was conducted and what were the results.
You should do it yourself.
I agree. I totally agree with you. I'm not trying to be controversial. I'm actually saying
I agree. I appreciate it. You're chill. I appreciate it.
Yeah, so like
But I'm just trying to explain to you that things like I don't claim to have all the answers, right? I don't claim to know on the macro level how things that we cannot test and demonstrate, quote unquote, work, right? So I'm not going to make a claim as to the mechanisms that are causing things like tides. I'm not going to claim what the moon is or what it's made of or how far away it is. Things that can't be tested, I'm not going to make any hard and fast claims to. But at the same time, I'm not required to make claims or prove anything about things like tides, things like eclipses, in order to demonstrate that the surface is not conforming to the shape of a ball as they tell us it is.
I mean, but okay.
Those are separate things.
But if I say the Earth is round and I bring like 10 different evidence, different set of evidence for proving that it's round, and you say, well, this A is wrong, but B, C, D, E, F, G, and all the others do actually prove a round Earth, so therefore the Earth isn't round. That's not compelling evidence.
Well, whatever you would bring, I could say, well, it can't prove a globe Earth because the surface that you would need in order for it to be a globe Earth doesn't exist. But that's not to say that some of like the phenomena or whatever you're looking at don't exist. They can exist, just not over a curved surface that's a ball. So it would be different things because it's like, I mean, it's not like.
It's a fair point, but what I'm saying is the globe model has more compelling evidence as regard to what you said, phenomena, and how we experience the.
But it doesn't have the fundamental assumptions that it requires. That's the problem. It doesn't have, no matter how good the story sounds, if you don't have curvature, you don't have a globe.
Just to be sure, you're saying that if some scientist came along and explained to you in detail why the experiment was conducted wrong and how you can actually prove that there is curvature, will you then be willing to concede and say that you were wrong about the Earth being flat?
Well, if you're asking if you could verifiably measure the Earth to have curvature, would
Yes.
you accept that the Earth is a globe? Then yes, of course. Why? What do you think we're doing when we were trying to go out and do this? We were trying to verify the Earth's curvature. If it could be detected reliably and measured, we wouldn't be here. The reason we are here is because that's not the case. The opposite is what's occurring. That's like when people ask us, oh, but if someone took you into space and you could see the globe, then yeah, obviously I'd have seen the globe. But to turn it back on you, if you now go and research these yourself, you find that, okay, the lake isn't curving. And you then go out yourself and you confirm, right, the lake isn't curving. Would you accept that the Earth is not a globe curving at the rate that they've claimed it should?
If I did if I conducted an experiment using all the parametrics of what curvature should look like, and I found it to be wrong, I would then ask people who are experts in science to explain
To make
why
excuses for why it's not there.
I mean, you could say excuses, but I'm not saying.
Yeah, that's what it would be. That's what it would be. Because you're saying, I go to the lake and I don't observe any curvature. I'm then going to go to a stranger and have him explain why there is no curvature observed, but it's still there.
Like there are people who are experts in certain professions, right? Like you go to a doctor when you're not feeling well, right? You're not going to go some random person.
Who would you go to for the globe curvature? Who's the expert?
A scientist who study this, cosmologists.
Okay, do you know of one?
Well, there are renowned people who who work in either astronauts or just basically physicists.
Did any of them measure the curvature?
Astronomers who work who are renowned, who have and basically any scientist should be able to explain this.
Right. Well, did any of them measure the curvature?
I'm sure they did. I mean, the Earth's curvature was calculated thousands of years ago already.
Calculated, but has anyone measured it? Without just assuming it. Yeah. You know that 60, that 10 meters that you told us the calculator was telling you over the 10 miles? Has anyone ever measured that?
I don't see how the formula works here. I don't even see what it's calculating. I just put in random numbers and it tells me this is the obscured objects part.
So you don't once you understand what the curvature is or claim to be, then go and find someone who's actually measured it and come and share that with us.
I'm willing to do that. Absolutely.
Please do, because that's what we're looking for. That's what is needed. Step one for us to even entertain the notion that things like seasons, eclipses, gravity, the satellites, NASA, for us to even entertain that those are possibilities, you first need surface curvature. Then we'd get on to, okay, now we need the spin. Now we need the gas pressure next to a vacuum with no physical separation. Now we need the motion around the sun and all these other claims. But for step one, for any of these phenomena to be happening above a curved surface, we need curvature. That's fair. That's not unfair.
I agree with you completely.
Yeah, cool. So have you joined our Discord server yet? If not, let me send you the link.
You can send me the link. I didn't see any invitation.
Okay, 2 seconds. My
understanding and knowledge, like Earth's curvature, is something that you not be able to measure like with the naked eye or at all. It's something that is so massive that the Earth's curvature is like so negligible over 10 miles that you wouldn't even notice it. Because the Earth is actually that big.
Well, 10 meters or 66 feet, however you're wanting to say it, I wouldn't say that's immeasurable.
Yeah, but we're going to this website with some formula that's being calculated. I don't know how.
Okay, yeah. So you need to look into that then. If you don't believe the curve calculators, I mean they're going by a ball with a radius of 3959 miles. If you don't believe that, or if you don't think that's true or whatever, I mean that you need to work that out, because that's what NASA is saying in terms of it being a ball with a certain radius. So
how was this experiment? They took some lake that was 10 miles across. They shot a laser across and it hit exactly where they were aiming it, or something like that.
So there's loads of different ones. Folk have done it with line of sight, just seeing if they can see another person or like a a flashlight or a mirror flash from the sun, things like that. Some people have done lasers shot over distances even greater than 10 miles to a target on the other side, and they just compare what the globe model obstruction claims, how far the laser should go, versus what they can actually hit in terms of a target.
Well, we have to, in order to do that, you have, first of all, the laser has to be ground level and has to be completely perpendicular.
Yeah. So you have to level the laser. You have to know the height above the level of the water that you're shooting, and this is what people are doing. Yeah.
You have to make sure
So in the link that I sent you, oh, you should, if you've joined it, if you scroll about 3/4 of the way down the server list, you'll see there's an additional information section. It's all alphabetized. Starts with Antarctica. It has things like gravity. Right? Not a model, right? But this can give you something to chew over mentally and just think about the concept, right?
Yeah, but
without necessarily saying this is a hard and fast claim as to the size and distance and locations of continents or all these other things. Whereas some people, but some people will just say, nope, we don't look at any concepts. We're only going by what we can observe from our reality and what that tells us. So it's different on a case-by-case basis. But yeah, I would say primarily we are not claiming a shape of the Earth. We are not replacing stories about things that can't be proven, such as the nature, composition, and surrounding medium of the sun, moon, and stars. We're not making any hard and fast claims to those things. What we are claiming is what we can test and observe and measure, which is the nature of the surface that we're standing on. Is it curved? Is it spinning? These kind of things, right?
I'm pretty sure that to actually notice curvature of the Earth, you're gonna have to take way more than 10 miles. The Earth should not be able to. You shouldn't be able to notice any curvature across 10 miles. But that's just my
Well,
that's just my knowledge. I can verify that and check it out and definitely come back with a more founded answer.
mhm.
But I'm saying
But
like
as well,
all these.
just to qualify that point very quickly, when you're saying notice curve, I mean, if you're talking like a left to right curved horizon, yeah, but when you're talking about the obstruction that is predicted by the curvature, they say that's pretty close, right? If you're 6 foot on the beach, they're saying that obstruction should be at around 3 miles. That's where your horizon should be that boats will start going over. So, I mean, that's not too difficult to test. And that's another thing that's being tested.
I can definitely look into that more.
Yeah.
Sure. But yeah, but as what you said about the other concepts that you presented, as for explanations for other phenomena, those are things that have been easily disproven just by what you. I mean, you said yourself that you. I mean, what are the measures that you would qualify these certain claims? If not basically looking into at reality as we know it, and at daily behavior that we know that already behaves in a certain way. Like we know there's a certain predictability to how things happen, and like we can predict when we're going to see a full moon or when there's going to be an eclipse. All these
Yeah,
things
but
are.
this has nothing to do with the globe Earth, though.
I mean, it kind of does because all these calculations are
No,
done. All these
no. See,
calculations
that's
are
where
done.
you're mistaken. See, that's where you're mistaken.
Wait. I'm saying all these calculations as to when we can predict certain things happening in the sky or around us are done on the basic premise that we're sitting on a globe Earth.
Well, you can model them to be above anything, but no, these observations and these occurrences were predicted, quote unquote, and known thousands of years before anyone even suggested that there was a globe, because the luminaries, the sun, moon, and stars, operate in repeated cycles. So you don't need to know any shape of the ground to observe the sky and know by tracking the cycles when these things are going to occur. For example, the eclipses have been tracked using the Saros cycle, which goes back to Babylon, right? And these people weren't talking about a globe Earth, but they've been able to predict eclipses for thousands of years using that cycle, made by people who were flat earthers. So, no, there's no globe model that's predicting things that have never been seen before. And it's like, wow, we knew that was going to happen because we assumed the Earth is a globe. No, all the observations of everything in the sky were already known. They have just since been reverse engineered and plotted on a heliocentric globe model. So it's reverse of what you're saying.
Just to put that aside for a moment, I'm not trying to escape what you said or ignore it. I'm just asking as a general, like, I legit want to know what's the incentive for like stirring up this whole conspiracy of like ground, like you're saying it was all like made to believe that it's because that everything we see is due to a round Earth. What was the incentive on making people to believe that the Earth is round?
It's a good question.
I got this one, if I may.
I was going to say, I've been speaking for a while, so let's see if someone else wants to jump in.
Well, no, I'm just, if you want to keep going, I'm good with that too.
No, please.
Okay, I love feeling this question because Voltaire said it much better than anyone else could say today. If they can make you believe in absurdity, you'll commit atrocity.
Sorry, I don't understand what that, like, what's the implication here towards, like, if we make people believe that the Earth is round, then we can make them do atrocities?
Yeah. Yeah, can you think of any atrocities going on right now?
Related to round Earth?
Yeah, or just related to human activity, the conduct towards one another.
I mean, there's always been atrocities because human beings are basically animals, so we're gonna certain atrocities are gonna be committed regardless of the shape of the Earth, because that's the nature of
hold
human
on.
beings.
Yeah, hold on. So, what would change that? Do you think? Is there anything that would change that nature of humanity? Like, say, a paradigm shift or a consciousness shift,
I don't think so.
awareness. There's nothing that would do it.
No, it's basically human nature. I mean, some people strive for power, and they're going to try to inflict that power on other people, and try to, that's not something that's determined on consciousness. It's
Okay,
just
well, check this right here. The
basically
overview effect is a cognitive change of consciousness, reported by some astronauts and cosmonauts during spaceflight. After observing our planet from the universe, they feel an obligation and responsibility to take care of that fragile blue dot forever, coined by Frank White, who interviewed Edgar Mitchell, Apollo 14.
Well, why did it have to be then round? It could have been just any shape. It could have been, I don't know, triangular for that sake. It still doesn't contradict
Yeah, because it's the absurdity part. You live in a flat stationary world. All your senses, all your tests, all your evidence supports a flat stationary world. So they tell you the exact opposite of that.
But yeah, but you're assuming that all my tests and all of my could you repeat that last sentence? All your tests, all your
Everything, anything at a human level, and that you will, from the day you were born to the day that you die, and that dash mark in between, will be on a flat stationary world.
For me, it's not like that. Like, it makes way more sense to me if like.
Okay, what sense? What sense did you use?
So, like, I was discussing this earlier with I don't know his name because I didn't look in the channel, but whoever was talking to me, sorry, I apologize, I don't remember his name. I think the evidence is way more compelling on the round Earth.
Which evidence? Yeah, let's go through it.
Well,
What evidence are you
I
looking
was
at?
discussing and I was going through some of them, but we for some reason were fixated on which I understand his point, his viewpoint, which is if you can't prove curvature, you can't prove any. There's no use in continuing into any other claims. But if we're gonna put that aside and ignore that premise, then you can look at any other phenomena that we witness on our planet, which is basically what I said before. It's seasons, night and day. You're looking at the directions of the storms. You're looking at a
Okay, hold on. Let's go one topic at a time to a full logical conclusion.
It's gonna take a long time.
No, it won't. It won't. Instead of gish galloping or just throwing just throwing a bunch of shit out there, trying to see what sticks. Which one do you want to talk about? Seasons, storms? What are you looking at?
We could talk about seasons and probably, I don't know, like gravity and stuff like that, which would be the most compelling evidence, I guess.
Okay, so which one? Seasons or gravity?
We can start with gravity.
What is that? What is gravity?
Gravity is a force.
Okay, see, now you're in heresy again. And what you should look that up.
Well, there's certain explanations for gravity, but basically you have the gravity as people teach it in like physics 101, which is a force. But if you're looking at like Einstein's general like relativity and stuff like that, then you're looking at the curvature of like space-time, which basically causes all objects to gravitate towards the center of the mass.
Did you take the lighter?
So
well, quickly to you, at least you understood that. Most Glovers don't really get there's a difference.
Sorry, what did you say?
If you want to tap back in.
No, Crit,
Elijah's trying to talk, I think, too. Are you there, Elijah? You're a little quiet.
Oh, sorry, no. I was just saying that, like, objectively, something can't be one thing and another thing simultaneously.
Well, it's not both things. It's just better explanations of how it
Well, no,
works.
it's either a force or it's not. It can't be a force, but not really when we think of it some other way. That doesn't make sense.
I mean, it's still a force, but it's the explanation as to how exactly it works is just explained among different. Right now, if we're looking at like today's time, then I guess Einstein was like had the most his theory of general relativity is the most common accepted explanation for gravity today. So it's like the consensus amongst all like scientists as to what gravity actually is and how it works.
Okay, Crit can pick up on that. So we're going with Einsteinian gravity.
I assume, yeah, or just you can talk gravity in general. I'm not going to oppose that either. Like we can talk about the concept of what gravity actually is, or like why do all things gravitate towards towards the ground on a flat stationary Earth.
Okay, Crit, you still here? Maybe Crit's had to jump. Anyone else want to take gravity? Don't all jump in at once.
I think a lot of people are just AFK, so they're probably not like in the channel.
Yeah.
What does things falling down have to do with the ground being a ball?
Well, basically, globe earthers believe that the center of mass of planet Earth is in the center. So that's where you're gonna have all the objects basically stick to the globe. They fall down from different altitudes towards the ground because that's where the most gravity is being. That's where the center of the Earth is basically pulling all these things towards its core, towards its center. And that's why all things, no matter where you're standing, everything basically falls towards the ground, as opposed to I let go of this object now and it will fly towards the sky. Like why do all things gravitate towards the ground in a flat Earth, as opposed to any other direction?
Do you think that
fundamentally,
if the
what
mass
does it
was
have
flat,
to do with
do you think that
what
if the
shape
mass
you
was
imagine
flat,
the Earth is?
You're both
do you
talking
think
at
that
the same time.
if the mass was flat and we have the same laws of gravity, that it would go towards the sky?
Hold on. Jerry was speaking to Jeff.
Sorry?
Don't want anyone else jumping in. Jeff and Jerry. Jerry was speaking to Jeff. Let's let them talk. Or we have someone else jump in.
Yeah, Dante, he's been triggered for a while about this. But yeah, what does things falling down have to do with the ground being a ball? I mean, I imagine like the ground being a ball came first, right? So of course, this theory of things falling down means they're falling towards the center of it. But how did you get the ball first? Right? Like the theory about why things fall came afterwards, right?
Well, the ball just explains why everything gravitates towards the center, which is Earth.
Yeah, but that's because the ball came first.
Well,
and the same thing happens if it's flat. Like it's really simple.
Well, no, because then you'd have to explain. First of all, if you're going to say that everything gravitates towards the ground on a flat Earth as well, then you're basically not disproving gravity.
Well, no, I just don't see what it has to do with what shape you imagine the ground is.
And again, it kind of depends how you're defining it, because you're talking about observing something go towards the ground, right? We don't necessarily dispute that. It's the construct that you then build around that, which is the globe Earth and everything going into the center of it. But really what you're looking at is just something falling to the ground, which I think is what Jerry's getting at.
Yeah, all you have is this thing falls down. Now, how do you connect that to the entire Earth being a ball?
is that no matter where we're standing relative to the Earth, it all gravitates towards the same area.
Yeah, down, right?
Well, it's a different area depending on where you are. Because
Vertical?
down for me is different from down.
Perpendicular to the horizon?
Yeah, that's exactly what I'm saying. So
All right.
just to be clear, you're not disproving the idea of gravity, right? You agree with it, but you're
No,
saying
I don't
that
even know what it is.
Well, again, this is the issue with how it's being defined. Because if you're defining gravity as just we observe some things to fall down to the ground, then fine. But if you're talking about the bending and warping of space-time and a massive ball Earth in a vacuum, that's a different thing. Which is why we need to be very clear on how we're defining what gravity is. If we're just talking about things falling down, things can fall down on a flat surface
gravity, right?
or a curved surface.
Yeah.
That's true. Why specifically a globe is because when we're looking at the how do you say forgot the word for it. Search it 1 second.
Gravitas.
No, that's a different word. 1 second.
Gravity.
Yeah, gravity. That's my word. I like to say. It grabs things and pulls it down.
Yeah. I mean, a flat mass does the same. I don't know why. There's like, this precludes any possibility of a flat surface.
Because someone told them that. That's why, and they believed it. They said somehow if the Earth is flat, you'd fly away in outer space.
Yeah.
And they just accepted it.
So
Wait,
what force
wait.
would pull you away?
Why do we have different weights on certain places of Earth? Like, for example,
Again, what does that have to do with the ground being a ball, though?
It's also a contradiction in the globe model.
So, like,
why would things weigh differently if the Earth is a globe? Wouldn't it be a uniform attraction to the center?
Because you're getting further away from the Earth's core.
If that's definitely the case as well, wouldn't all gold miners sell their gold in one location where it's heaviest?
No, because that doesn't make sense.
That'd be a crafty business move.
If you're standing on the equator, you're gonna weigh less than when you stand on any other position, with regards to the latitude of the Earth. So, like, when you're standing on, we know that the further you get away from the Earth's core, the less the gravitational pull is going to be, right? So, assuming.
Okay. So you're saying the equator is further from the Earth's core than other places?
True, and that's why.
Well, that means it's not round. Because, like, like a globe is, like a sphere is literally equidistant from the center.
God damn, Dante, what's going on with you? You're like,
but the radius.
Well, I can look. I mean, I can play this too, crit. Like, this is easy.
No, I'm saying,
like, an easy dub.
Is this like a brand new like pathway or something?
I haven't seen you guys in a while. I missed you. I thought I'd take your side for a little bit.
All right.
I still know how the universe operates around me. I mean, I have a working model that's served me well. But no, I mean, it's more like I'm literally just pointing out, like, like, even if the Earth is flat, like, things aren't going to just start going up to the sky, my friend. The mass is still beneath your feet, right? So that's where it's going to go.
But that wouldn't explain why you weigh certain, like the weight differences in certain locations.
Well, I mean, that could be explained just by the variation of mass density underneath your feet. So.
Well,
I'm not seeing how any of this means the ground is a ball. Like, I'm just not seeing it. Like, where's the geometry in this? Like, you have a straight line down, right? And you have perpendicular, the horizon, right? Where does the ball come from in your imagination?
I have a question.
When I had debates with other flat earthers, they would dispute the fact that gravity even exists, or they would say that they don't accept the premise of gravity. So at least I can see that you're conceding to the fact that gravity does exist. So that's why.
Well, I don't even know what it is. Right? Nobody
the
does.
tendency.
We don't know
Well, I just clarified for you. It
Does
depends how
April
you're
8th
defining
make the
it.
Earth round on April 8th when that solar eclipse comes through? Is the Earth a globe then?
I can't
No.
hear your question.
No. So again, we already discussed it, how you're defining gravity. I mean, we're not disputing that things rise and fall, but that's not what the globe side typically mean when they say gravity. They're talking about the bending and warping of space-time around this ball Earth. I mean, which, as we've discussed with the lake, isn't true. So
Yeah, the whole lake thing. I said I'm willing to look into that. That's a valid point.
yeah. I'm
Um,
just saying.
we can look at the okay. So I think the most compelling evidence that I read about, at least, was the rotation of the stars, and you have people on the north hemisphere having the clocks, the clocks, the stars rotating clockwise, counterclockwise, sorry, as opposed to the southern hemisphere where you can see the stars are rotating in a clockwise position. So how are people standing on the same plane but seeing stars rotate in different directions? If anybody has an answer, I'm willing
How
to.
does that connect to the ground being a ball?
Yeah,
Because
on the flat Earth, everything rotates east to west. So on the globe Earth, if you suddenly switch west to east,
but you're looking
that
at the
would
same
be a
data.
problem, wouldn't it?
Yeah, but that's the thing. We're all looking towards the same direction, but we're looking at the stars rotating in different directions. One is seeing the stars rotate clockwise, while the other one, who is standing on the southern hemisphere, looking towards the same direction as the guy on the north hemisphere, seeing the stars rotate in completely the opposite direction. The only shape.
Yeah, that's a problem for the globe. That would be like you got two different hemispheres rotating different directions. Because on the flat Earth, everything rotates east to west, rises in the east, sets in the west. Globe Earth, as soon as you pass the equator, it switches and goes west to east.
But we know that stars rotate in different directions, right? They don't always rotate in the same.
It's all east to west.
No, it's not. It's not.
Yes, it is.
It's either counter. Are you talking about like the sunrise and sunset, or are you talking about the rotation of the stars regarding to the Earth?
Anything in the sky, except clouds
So
and
yeah,
birds
same
and
things
shit.
that you can look at pictures on any website of like the rotation of the stars and how they, like, if you film the stars and their position every couple of minutes and see their motion, you can see that on one side of the hemisphere they rotate clockwise, and on the other hemisphere they rotate counterclockwise. How is that possible on Earth?
They're all still going east to west.
There's no east to west and clockwise and counterclockwise. They're all going different directions.
They're going the same direction.
But they're not going the same direction. One is going
Yes,
clockwise
they
and
are.
counterclockwise has nothing to do with east to west. I can't hear what he's saying. You're robotic interference.
Are you going against your heliocentric model?
Why is it going against the heliocentric model?
No, not it. You. Why are you going against the heliocentric model? Because right now, what I think you're doing is talking, but you're not understanding the words coming from your mouth.
Explain instead of going ad hominem. Just explain why what I said is not valid.
Ad hominem. Okay, I can give you a description, but what you're saying is that the stars are going east to west in the northern hemisphere, and they're opposite in the southern. And then they say it's always going east to west, and then you say no, it's the opposite. So how is it that in the southern region, the stars are not traveling east to west?
Well, what do you mean east to west? I said clockwise and counterclockwise. I didn't say east to west.
They've been bringing up east to west, and you tell them no, meaning you're not hearing what they say and what they mean and thinking about it.
But
you're just being contradictory.
No, stars don't go east to west, though. Stars don't go east to west. We observe the stars in the sky. They rotate. They don't go east to west. You either see them during the nighttime, or you don't see them during the daytime. but they don't go east.
Why
It's
are
not
the
like the
stars
sun
moving
doesn't rise.
east to west on a globe?
Why does what?
Why do the stars move east to west on a globe?
I didn't say they move east to west though.
Does the sun rise in the east and set in the west? Yes or no?
The sun does, but the constellation of the stars is not something that rises from
So
the
they're
east and sets
opposite
in
of
the
what the
west.
sun is doing.
Sorry?
So they are doing the opposite of what the sun is doing.
The stars are not located in the same place as the sun. We don't
In the
see them
sky, right?
they're
They're
in
in
the
the
sky all
sky.
around.
You're looking up.
Right, and
The
the
sun
Earth is
moves
rotating.
east to west. We agree on that. But suddenly the stars are not moving east to west. Why?
But I'm not, again, I'm saying Earth rotates, right? We know the Earth, we're going to assume that Earth rotates. We don't all believe that, but let's assume that Earth rotates, right? During the nighttime, you're going to be able to see certain stars who are in a fixed position. And because you're rotating, you'll see them rotate well, you can film their location at a certain time and then film the same a few moments later, take another picture and then another picture and then another picture, and put the pictures together, and you can see in which direction the stars are rotating, right?
Correct.
So the
now, if you're at
rotation.
the equator, what is it that you're observing? You got your rotation in the northern direction, and you have the stars above your head going straight, right?
Well, you're not looking at the same set of stars then, maybe.
Mylanta, follow along. I am assuming that the Earth is a ball right now, okay? You're at the equator. You're looking in the stars. You got your rotation that you're fixated on in the north, right? The stars above your head, since you're at the equator, are just going to travel straight across the sky, right? Because the Earth is spinning, right? And if you look to the south, you're going to see another rotation of stars, right? If you look at the rotation of the stars, they're coming from the east and they're going to the west. Then once you reach the rotation and then you look beyond the rotation, it's going to go east to west. You're looking at a pair of gears, right? You cannot make gears go opposite of each other and have them connected at the same time. You'll grind out the gears.
Let me show you what I'm talking. Post a picture. Works more maybe in detail.
Compare the stars.
Well, here
and
I
their
got
to
something better for you right here from an observatory, the Griffin Observatory. It demonstrates how you're in heresy right now. Right there. Every day, the sun, moon, planets, and stars appear to rise in the east and set in the west. Do you see the citation there?
Yeah. I'm looking at this right now. 1 second. Polaris. That's what I was looking at. I have the summer solstice, the spring equinox, the winter solstice, and the autumn equinox.
See, they've got you confused right now. This is going back to what I said earlier. If they can make you believe in absurdity, you'll commit atrocity. Inside your worldview, you're seeing the stars changing direction as soon as you pass the equator.
Well, it's not something that's debatable. It's basic fact. If you're looking,
yeah, it's east to west. This is a fact. It doesn't matter where you are on Earth. East to west.
If it's going east to west, then it should rotate in the same direction, according to what you're saying.
Yeah, and it does. Same direction, east to west. It doesn't matter where you are on Earth. It will all the stars, the moon, the planets, the sun, everything rises from the east and sets in the west. Everywhere.
But the rotation of the stars is not the same on both hemispheres.
Yes, it is. It's exactly the same. East to west.
Star.
I mean, how many different citations do you need here? Like, here's another one. UNL Astronomy Education. Because the Earth is rotating, the sky appears to rotate. Viewed from the North Pole, Earth is rotating counterclockwise. The observer on Earth and all objects from east to west. This is true in both northern and southern hemispheres. Here, let me post this citation.
I also posted a GIF of 2 gears.
Read this one right here, Jeff. Read all the words. Change no word. Add no word. Remove no words. Read the words in the correct order. You cannot tell what hemisphere you're in on the globe model just by looking at the sky. It's exactly the same. The sky.
The gear photo that you posted is not how it works. It's not stars going against each other. It's on different sides of the globe.
Look what I just posted right here. Do stars rise in the east and set in the west in both hemispheres? This is where you're confused on. They got you to accept a contradiction. So now it's going to take a lot of deprogramming to get you all of this cult hive mind groupthink.
Let me see. Stars in the northern hemisphere do indeed appear to rotate counterclockwise around the north pole of the sky. However, if you look towards the equator, stars appear to rotate clockwise. The Earth rotates from west to east, so that it appears to move across the sky from east to west like the sun. What was I saying?
Yeah. So now you understand, right? Or are you still confused?
I'm still confused as to how it's possible if you're looking from in the same directions on the same set of stars.
I'm not sure how I can help this guy. Does anyone else have some ideas, or?
I think it's just confusion on how to work this out in his mind. It's going to keep him on lock. I think our better option would be to find a different topic to talk about, because we're just going to go around in circles.
Yeah, this is tough, man. The scientific communicators tried to explain this exact concept to him, but somehow he heard a YouTuber say this debunks flat Earth, and he's stuck there. He can't move. He can't go past that. You were talking to someone who is scientifically illiterate. They do not understand the globe. They do not understand flat Earth, and someone told them that there's different rotations of the stars, but not the sun and the moon. When the sun, the moon, and the stars rotate in lockstep all day, all night, east to west, wherever you are.
So
maybe we could try something here.
So
Jeff,
so you just said.
Hold on a second. I want you to try something here, right? Okay, so stick out both of your arms straight out to your side. Okay? And rotate them forward in circles, okay? Are you doing that?
Yeah.
Now look to your right arm. It's going counterclockwise, right?
Yeah.
And look at your left arm. It's going clockwise, right? But they're still going the same direction.
Yeah, but you're looking in different directions with your head as regard to your hands.
There you go.
That's good. Yeah, good job.
But
I never thought of it that way. So you changed the direction you were looking. You didn't change the rotation of the. So did you just prove that your body's a globe?
No, I'm not. That's not what I'm saying. I'm saying that's not what I'm saying. But I'm okay. I'm willing to put this whole star rotation thing. I'll probably look into it more. But there were other things that I actually wanted to look out besides this one. That was the gravity. It was the rotations, and the seasons. Probably was the one I wanted to delve into the most. If you can explain the. I was talking this earlier with what's his name, the guy who was talking before you. And then what did you?
Yeah, Wolfgang Cyclone.
Hmm?
Yeah, so the seasons on the flat Earth, Mars does not affect the seasons.
Well, let's put Mars aside for a second. How does it work, like with regards to the position of the sun? Like what?
I got an answer for that, man.
What
So
determines winter and what determines summer?
a second.
And
So all models, it's just elevation angle to the sun, right? And throughout the year, the sun rises at a different location on the horizon or the azimuth. So the sun's like right now it's the equinox, right? So from now on, the sun is going to rise in a shallower angle
What do you mean? What do you mean by
until
rise?
the solstice.
On a flat Earth, like the sun constantly rotates like above the flat Earth.
Well, they have to admit that it's an elevation angle difference, and it's closer or further away from the
You're
Earth
saying it's
throughout the
going
year.
like further up into space and then down to Earth in different cycles?
That's the only explanation on a flat Earth, yeah.
How does it light up the southern hemisphere during the winter to the point where there's day all day?
I hope you're not trying to confuse what we're saying with the model that you went to look for and try to debunk. We are not on a disk flying through outer space in a heliocentric model. Okay? The Earth is the ground, the thing under your feet. The lights in the sky are in the sky above your head. There is no outer space. And whenever I got into this conversation earlier, Cyclone had already addressed that you needed to have an example of gas pressure without a container to prove your outer space vacuum.
I don't know what that means, a gas pressure container. What do you mean? To prove that what? To the vacuum exists, that there's nothing in space?
The closed or isolated system.
I can't get what you're saying, bro. You have interference with your mic or something. You're breaking out every time.
Okay.
Or is it me? I don't know. Is it me breaking out or is it him? I don't know.
No, it's me because I travel.
Oh, sorry. I just can't get what you're saying here because it keeps breaking out all the time. Continue.
Do you know what an open, closed, and isolated system is? Do you know what they are?
Explain.
A closed system is not able to transfer matter in and out of the system, but it can transfer energy in and out of the system. An isolated system cannot transfer matter nor energy in and out of the system. The open system can transfer matter and energy in and out of the system freely.
Okay.
Is the Earth an open, closed, or isolated system?
I'd say it's an open close because you can transfer matter and energy through the Earth's atmosphere towards outer space.
So is it open or closed?
If open would be what you said about the energy traveling from within outer space from outer space to inside the globe, then I'd say yes, because we have energy transfer from the sun, the light that penetrates the atmosphere and into our globe. So I'd say
Okay,
it's an
so
open.
you have an open system. Now, can you create a system with a vacuum without a container? Or if you try to create a vacuum, the air around that vacuum is just going to fill in the space that's trying to be made empty. Can you make a vacuum chamber without a container?
Make a vacuum container without a. Can I make a vacuum without a container?
Right.
Well,
Can you do that?
I mean, well, you can with certain. I assume with certain. When you have an atmosphere protecting that specific place, as opposed to in space where you have complete vacuum, which is absence of matter.
Now, I'm asking you to give an example in your own experience of life, right? Were you ever able to create a vacuum without a container? Were you ever able to contain high pressure in a location without a container?
Well, you have particles everywhere in the atmosphere of the Earth, so that's not going to be possible. You can't demonstrate certain phenomena that happen in space and say, well, you're going to have to prove that in Earth's ecosystem. It doesn't work like that.
So you recognize that anytime you try to have a high pressure next to a low pressure, the air is going to flow. Or if you try to make a hydraulic system, the liquid in that hydraulic system is going to try and flow to make the pressure equal, right?
No, not necessarily. It depends on how it exactly how it works. I'm not literate enough in science to explain the phenomenon on how it happens, but I'm saying it's not that you can prove every certain thing that we experience in space and say we can do this in a lab. It's not how it works. It's like why flat earthers ask us to prove that you can have water stick to a tennis ball that is rotating. If you can't prove that, then the Earth is definitely not a globe because the oceans don't stick. Well, I'd say that's a fallacy because in order to create the same phenomena, you need enough gravity, which would not be feasible in any way, to create enough traction to the ball via gravity to pull the water towards the rotating tennis ball. You can't create those conditions in a lab, so it's going to be hard for me to prove. You're saying you can't prove because you're going to have a container. You don't have in your lab. You can't create vacuum without a container. It's not the same thing about space. Some experiments you can't prove on
All right,
Earth.
so you admit you cannot create a vacuum without a container, right?
In Earth, no, you can't.
Okay, so then outer space is your only example of a vacuum adjacent to liquid and air pressure without it escaping. And your answer for this example is gravity, which is something you cannot manipulate yourself.
True.
It is unfalsifiable. Right?
The reason why the air doesn't escape the atmosphere is due to gravity. True.
Right. So you're begging the question that outer space exists because you can't create another example like it. Now, if you wanted to say that, well, we have a pressure gradients, right? It's higher pressure down here on the ground, but as you get higher in altitude, it's a lower pressure. Well, we can create a smaller example of that by manipulating temperature in a closed system. We can have a pressure gradients inside of a closed system. But like you said, we cannot create a vacuum without a container because every time we do have that, the air flows to fill the space that's being made void. Or if you have a high pressure next to a low pressure, like a hurricane, for example, you have a high pressure system and it's surrounded by a low pressure system, and your air begins to flow out towards the low pressure. So, in your experience, anytime you have high pressure next to low pressure, the medium will flow to the low pressure. If you was to take a container,
if you have gravity, though, pulling all the matter towards the center of it.
Right, but then you also agreed that you can't manipulate gravity to create another example.
True, because you need a big enough mass to create the amount of gravity that would create this vacuum. True.
Yeah. So again, we're going to have to beg the question that outer space is real in order for your idea of how space works to work.
So why isn't our atmosphere filling the container?
The proof is on me to actually show that that space exists within the confinements of our atmosphere, with Earth not having any, with space being basically a vacuum and Earth containing all the air that we have and it not escaping. You're saying.
Yeah, but you have a word in your model, right? You don't have one, but you have one. In the heliocentric paradigm, you have a contradiction, right? It's an open system, but it acts like a closed system. But it's an open system, but it's a closed system.
I mean, it's not I don't see how it's contradictory. I mean, like, why is it not? If we're assuming, if you take the premise that gravity exists and that Earth has a gravitational pull that will pull all the air to it, and you know, to an extent, to a limit where it creates um where the mass pulls, you know, if within certain distance to the core, um, all the elements to it, and then you have a vacuum existing outside of this ecosystem. Why is it not? Why is it contradictory?
Can something be open and closed at the same time?
You have to affirm the consequence that you can't conclude to be true. Whereas a flat earther is going to claim that they live in a contained environment. It is a closed system, and everything you experience is inside this closed, contained system. Whereas you have an open system, gas pressure and liquids existing on a rock in a vacuum. Whereas you create a vacuum and you try to put water in that vacuum and it disappears. It evaporates, it boils. But Earth doesn't have a boiling ocean. The water hasn't disappeared into the vacuum of outer space. This goes against everything you experience.
But why? But if
what you have is a philosophical claim. You don't
guys
have
would
a
have
scientific.
a fair point if air pressure was the same at every single altitude, but it's not.
Right. And I gave in my examples earlier how you can have a contained system, have a pressure gradients in it. And what was the way to manipulate the pressure gradients inside that closed container? What did I give as an example?
I'm kind of confused as what you're trying to say, but if I understood correctly, you're expecting like you're saying that if the Earth did work like any other observance we see in our daily lives, then you would expect basically all the water and all the air from Earth to just flow out into outer space.
Yes.
Yeah, he's saying if we go by what we can observe, measure, and test about gas, in reality, it tells us that gas pressure requires a container, and gas pressure cannot exist adjacent to a low pressure space without filling that space. That's reality. Whereas when you go, right, but if we assume that the Earth is a ball, and we assume we are in a vacuum, and we assume that we have a thing called gravity, and we assume that that thing called gravity is holding the air down, and we assume all this is occurring even though we can never demonstrate it in reality, then it's valid to believe the story. Well, that's not what we're talking about here. We're talking about reality. Let's just go with what can be observed in reality. And if you claim there's something else beyond what can be observed in reality, then that's just a belief.
Well, then,
And the reason we had got into this topic specifically was because earlier we were talking about how the sun's location in the sky causes seasons and time to change, right? And you had got confused on what he said whenever he said that the sun increases in altitude. And you had brought up how the sun goes farther away into space. And I wanted to make clear that we do not think that outer space exists, right? We just think that the sun, moon, and stars are in the sky inside of a contained system.
Yeah, but as I said before, you're excluding the whole part where gravity takes its course and actually pulls it causes it to be possible. You're saying we can't demonstrate this because we don't have the tools to create enough gravity to actually prove this. Well, that's not disproving.
No, that's your side's argument, not ours. You guys make the claim to that which you cannot evidence, and then tell us you would need something the size of the planet to be able to demonstrate it, which is just saying we can't demonstrate this idea. So that's
The
a
only
deficiency
thing I
on the
wanted,
globe side, not ours.
I understand your claim.
the thing I just wanted to point out was that you have to understand where we're coming from when we make the claims that we do. And you cannot marry my claims with your claims. They don't go together, they're contradictory. That's it. That's the only reason we had to walk
So
through this.
you're fixating on the fact that I said space, but it can go. It could go anywhere. You're saying further away from Earth. Okay, it doesn't have to necessarily be
Higher in
space.
altitude. That's what he said.
Yeah, so higher in altitude, exactly. So I agree. I agree with higher in altitude, but that doesn't. You can take space out of it. It doesn't really matter. But I'm saying if that's what happens, it doesn't reflect what we actually see in reality.
Have you experienced the travel of the sun without United States has the spring forward, fall back, daylight savings? Have you ever experienced the sky without daylight savings?
I don't know what that means.
Have you always lived in a? I assume you're American because of your accent.
No,
It sounds
I'm not.
close enough.
I have American citizenship. I was born there, but I'm not. I don't live there currently. So English is like my secondary language.
Cool. Do y'all have daylight savings time where in the spring they turn the clocks forward, and in winter you bring the clocks back 1 hour?
Oh yeah, we do have that. Sure, yeah.
Okay, so then have you ever experienced living in an area where daylight savings time, the changing the clocks by an hour, was
Yes.
not a thing? Do you remember? Did you ever wake up early in the mornings? Right, like I lived in Afghanistan for almost 2 years. Okay, and there were times of the year where you could wake up at 4 o'clock and the sun is in the sky.
Yeah.
Right,
In the
and
winter,
then
you wake up early and it's dark outside. True.
yeah. Okay, so you've experienced that, right?
Yes.
Okay, so all that's happening is the sun's changing its location overhead.
Sun's changing its location overhead.
Right. The sun, the time, the way you experience time, you have a clock telling you, here's my 24 hours for one day, right? And the sun itself is going to travel overhead. Now, there's going to be times where at 4 in the morning, the sun is close to you. It's within your view. You can see it in the sky. And then there's going to be other times where the sun is not in the sky, but it's still 4 o'clock in the morning. You get what I'm saying?
Yes.
I think the idea is it's more like a spiral and less of just a perfect circle, or like elliptical, as it's been told. And throughout the year, it varies between the angles, essentially.
So do you have something that shows like how that works? Like, because we know we can predict where the sun is going to be and how much daylight you're going to have every year. We know exactly where the sun is related to the stationary flat Earth or whatever. How high do you assume that the sun is from the Earth, and how is it actually lighting up all these different locations at the same time, even though they're not in your flat Earth map, even remotely close?
So this is what I was kind of talking about before. So, like for example, at noon, solar noon, for example, the sun will be at its highest, or in the most southern part of the sky, right?
Yeah.
And if you were to say, look at that azimuth equidistant map, for example, because that's a time calculator, not exactly the flat earthers wouldn't really seem to attach themselves onto that only to signify where the solar noon is, right, on these latitude points. And the 24-hour, essentially like a 24-hour clock. And where the solar noon happens is a division of that 360 every 15 degrees. The way I look at it is, anyway, it's like a mechanism, whatever model you're living on, right?
Yeah, but it's really hard to explain how, like for example, when I brought the example of Antarctica before, where you have certain times like during when it's winter in the northern hemisphere, and you have parts on the southern hemisphere that have daylight all day.
Right. Oh, okay, let me explain. So there's like an angle to Polaris, for example, and then it kind of like there's no longer visible the further you go below the equator, essentially, like because of angles and the way that the globe is supposed to be, and it's 90 degrees to it, and essentially, so like, the further away from the pole you are.
Are you explaining it to me in like global, on like the globe model, or?
Yeah, to begin with, because that's kind of what you're used to, right? So like when you reach the horizon, when you reach the equator, the pole star would be at the horizon on 90 degrees. Okay. When same as the sun would be in the southern hemisphere in the winter time, it's almost like concentric circles. How they'd model it or whatever on the flat Earth, essentially, or they'll conceptualize it as like concentric circles, and it's on like a larger circle when it's the summertime in the south, and therefore the angle to the sun in the north is shallower. Therefore, the sun rises and everything's affected like the winter in the north. Essentially, like it's the only way to really explain it.
But like then you'd have to explain how big the sun is and how far it is related.
Right. That's the problem with it. Yeah, and it'll come up with the mathematics of it. It'll come up to like 3,000, 4,000 miles away.
So you're assuming Earth is 4,000 miles away
from the sun.
From the sun.
No, what he's saying is you have to calculate the distance between you and the sun. You wouldn't be able to get an accurate measurement.
Why not? If it's in the same system as we are, we should be able to calculate how far it is. If there's nothing existing outside of Earth, basically. Like, why are we not able to fly up and like see the sun? If it's only 4,000 miles away, like if that's your estimate, why can't we just get like a rocket to fly up 4,000 miles? That shouldn't be too hard.
No, that's not a claim we're making.
I thought you said it was 4,000 miles above.
No, that's me. That's me. I'm not speaking for them essentially, but I'm speaking for geometry and maths. So, like for example, if you have like a light in your room, right, like a lampshade, and you step away from it, you can kind of work out the distance to it. If you know the known distance on the surface, and then you know the angle, you can do Pythagorean theorem, right, and work out the hypotenuse of the triangle and figure out the distance to it, right?
Yeah, so if you were to ignore all other variables and assume that that's like for like with looking at the sun in the sky, you might be able to make a claim of that nature, but we wouldn't do that because that would be fallacious. So let's not confuse the guy.
I'm just saying that's where. No, that's where that number comes from, essentially.
Let's not confuse the guy with speculation about the distance to the sun. You can't measure the distance to the sun. I recommend you read The Tale of Icarus. This has been known for a long time.
Icarus is the guy
Can I just jump on? Yeah, exactly. I mean, I don't want to get biblical, but even the story of the Tower of Babel seems to believe that we're a small and local system that's accessible, within 4,000
stuff like that.
Well, what was it accessible though? They didn't access it, did they?
No,
I think it was destroyed. I think it was destroyed before.
Yeah, exactly. So. But if you want to be the first to go and travel to the sun, let us know how it goes.
Yeah, they're just going to say apparent, like almost like a rainbow would be like. There's no distance to it; it's just apparent to the observer, essentially.
What about like the flight paths as well? Because like on a flat Earth map, from what I witnessed, I'm not sure. Maybe I have the wrong map, but from what I looked at, if you're looking like at the distance between like certain places on Southern America to like Australia, it'd be completely like impossible to make that flight path in the time that we're doing it today, if you're taking scale into equation.
Yeah, you also have to ignore how efficient planes can be. Okay, here's a handful of things that you know for a fact. The destinations, right? The takeoff point and the landing point, and the times that they take off and the times that they arrive, right? Everything else is a variable. You can change one variable and get and help it adjust to account for um, making it make sense, right? You could say the plane is moving faster in order to cross these great grand distances, or you can say that the distances aren't that far away and the plane is not having to travel as fast or as far and still
But
get there at the same time.
usually
But what you also
planes
what
when
you
they
also
fly,
take
they
into
usually fly
account
at a
is the destinations. They're all the flights are tracked so that they don't clog the airports. The planes have to fly in a manner that would keep them out of the local airspace of the airport in order not to create a hazard. If they have to take longer to get to a destination, then they'll just slow down. If they're running late, they'll speed up the plane. Okay, and they also have to travel in a path, a
that's only
predetermined path.
Yeah, but that's only when they're flying. Like the only time they would fly slower, or they would actually when they get on a flight path, they just put it on autopilot and it flies in a constant velocity. They don't change the velocity of the flight according to the path. What they do is they usually avoid certain, like what you said, they avoid certain like spaces where they're not allowed to like have the permission into like certain countries or whatever. But when they fly in a constant speed. And like in the flight path that you see between like southern America to Australia, there shouldn't be any countries in the um in the in between the route that should deny it from flying its full velocity. There's no reason for the plane to fly slower if it's going further, is what I'm saying.
So just on the airspeed of a plane, the airspeed, the velocity, if you want, it's actually not relative to the ground. It's usually relative to the air. So you could have a so it's constant in relation to the air. So it could potentially go faster than the ground speed. So for example, if it's like in the air. If it's like say I don't know what's typical speeds, like 600, I don't know, 600 kilometers per hour. Well, I know that you can't break like a speed of sound, but anyways, let's just say like 500 miles per hour.
On commercial
And
flights, it's usually you're talking about like like 300 kilometers per mile or something, like maybe even less. But
Yeah, hey Felix, just so you know, right? If you're part of GF6, you're given 0 level of charity communication. Number 2, you're no longer considered a new person, and new people have priority. So go ahead, Jeff.
sorry.
Yeah, you got the floor again.
I was listening to what he was saying. I just wanted to correct him and say that commercial flights usually fly between like 480 to 575 miles per hour. That's the approximate speed.
Do you know those pilots all treat the Earth that they're flying over as flat and motionless?
Because the angle they have to correct the aircraft in is like minuscule. It's like 1% per.
Yeah, it's as if there's no curvature or motion, right?
No, they do take curvature into account. They do tilt the
Oh.
axis of the plane, but just by a little every couple of. And there's some flights wouldn't require that at all, but some further flights would have to take that into account.
Like they dip the nose downwards for the curve.
Yeah, but it's so minuscule that you wouldn't even notice it.
So they don't do it.
No, they do, but it's.
Oh, okay. Who told you that they do?
Well, you can check it out in any other. You can ask a pilot.
Yeah, we've asked pilots. They say they don't.
They don't take what Earth curvature into account when they're.
Yeah, or motion. They're trained to treat it as flat and motionless.
If they say when they say they're treating it as flat and motionless, it doesn't mean that there isn't curve. They're just treating it as if there was not curve because it's so negligible. Like
yeah, so they're acting as if there's no curve or motion.
Well, that may very well be. If you're flying across a distance where the Earth curvature is like 2%, you have to take into account like
No, they don't say
2%.
there's any distance that you would account for curve or motion.
I would argue then I'd have to actually, understand what they mean when they're saying that you don't have to take that into account. Because
Yeah,
I know
you
that
should look into that.
the plane always flies like perpendicular, like level to the ground. So it has to, if you're assuming that the Earth is a globe,
Right,
then
and to maintain level with the ground, they're not dipping their nose to go over a curve.
I'd say that I'd have to talk to an actual pilot to verify this, but
Yeah, you should.
but that's that if it's true, then then that'd be a good claim in Flat Earth's favor. But I'd like to hear what actual professional pilots have to say about this.
Yeah, you should research.
Yeah, definitely, I agree.
Also, there's a channel in our server under F called Flight Paths, which might interest you if you're interested in that.
Sure.
What's interesting is you got to this conclusion before speaking to a pilot, but now you need to get to a different conclusion because speaking to a pilot. It's quite the dichotomy, like the duality there, that you've got one set of evidence, a bar, if you will, for one idea, but a different bar for different ideas.
I mean, I would trust a guy who flies the plane more than someone who says, no, it's just not like that. Would you agree with me? Like, if you wanted to know how, like what calculations pilots are taking into account, I wouldn't trust some random guy from YouTube. I would trust
What's interesting about that is there was a pilot who went on one of these anti-flat Earth shows called the McLooney Tune, and he broke it down, Big Bird and Barney style, explained the whole. He's a flight instructor, mind you, and broke it down to their education level. Busted out the crayons in the chalkboard, broke it down in high detail, and all that happened was they found out what airport he works at, did a letter writing campaign, called them up, said, "Hey, you got flat earther there. You guys is teaching people," and they're offended and outraged by that. That's why you don't get pilots who are going to come forward and say something, because you'll get a bunch of freaks on the internet completely triggered that there's a flat earth who is a pilot. Like somehow in their worldview, that is so incensing. That is such an insult to their sensibilities. They refuse to even listen. And all they'll do is start caring. They want to talk to the manager. That's all that's going to happen. So when you talk about, number one, you got to find a pilot who doesn't give a shit if some random people call up his manager. That's the first hurdle. Are you able to do that? Most people, it doesn't matter what job they have. They don't want to be hounded by a bunch of freaks online. Then number two, they got to break it down to you so in a form that you'll understand. That might be difficult because they don't know who you are.
Is your claim that pilots are not actually saying that pilots believe secretly that the Earth is flat, but they're afraid?
Secretly, who says he was out and open? He said, "I am a pilot. I'm a pilot instructor. Here's my name. Here's where I work. Here's the airport I instruct at. I'm gonna go on your anti-flat Earth podcast and discuss how the Earth is treated as flat and stationary while flying any plane he knows how to fly." And the only outcome that came from that was they called the manager. They went full Karen. None of them even give a shit what he had to say. All they knew, here's a person who says they're a flat earther and they're a pilot, and they were just incensed by that. They were outraged. They were maddened and incensed, and they called the manager. That was it. That was a full outcome. No one even can tell you. Like, people who watched the episode can't even tell you what he was even talking about, or what evidence he presented, or what facts or figures or data. All they know is that this guy, how dare he be a pilot in a flat earther? That is an insult.
I don't know about the specific incident, but I'd say if the majority of pilots knew that the Earth was flat, or they would take that into their calculations or whatever, you would probably hear some people talking against it, not just one random guy. But what I'm saying is,
Hey,
like,
well, just quickly on this one, Jeff, I just posted a quick clip in the chat, which is a compilation of people who've gone up to pilots and asked this kind of question: "Are you dipping over the curve?" type of thing.
yeah,
So you might find that interesting. I don't know. Just putting it out there for you.
literally just checked that out, and what I find interesting is, like, it's true that they don't actually tilt the plane to take into account, like, the Earth curvature, but it's not the plane when it descends, it's always perpendicular to the ground, because when you're looking at a globe and you're flying perpendicular to the ground,
You're
the
just
Earth
stuck to the globe properly. You don't need to do anything. You just automatically go over the curve.
No, you keep a straight line, and when you're flying in a straight line, you're flying towards the same position because Earth is pulling you towards the ground.
Yeah. So the gravity is doing all that work. So you can just pretend that the Earth is the opposite of what it actually is. You can pretend it's flat and motionless when it's actually a spinning ball, because gravity, which we remember we were struggling even to get a cogent definition of earlier, takes care of it all.
I mean, if you're keeping the same altitude and you're not using any thrust, then yes. It's not the same case for, like, rockets or whatever.
I mean, because you just said before, if that's true, what I was saying, that they don't account for the curvature, then that would be a good argument for flat Earth. But now you're saying, right, that is true, but gravity just does it.
Yes, that is what I'm claiming. That
See, that's quite a reversal. So is it no longer a good argument?
No, I'm saying I'm saying if they didn't have to take it into account at all, like
Yeah, they don't. They've just told you that.
But
That's
it's
what
not
they're
that they
saying.
don't have to take it because it doesn't exist. It's because that the gravity is already creating that effect that
No, but that wasn't the argument. The argument was they are not accounting for it at all. And you said, well, if that's true, that's a pretty good argument for flat Earth.
Yeah, I know.
And it is true.
But then when I look into it and I see that the
When you look into it and they say, don't worry about it, gravity, one word, you're like, works for me. Nothing to see here.
No, because it makes more sense if gravity is pulling the plane
It
towards the
makes
ground.
more sense than that they're flying flat and motionless, as they're treating the Earth as flat and motionless because that's what it actually is. But it makes more sense that it's actually a spinning ball if you just say the word gravity, which half the people can't even define. That's what makes sense.
I mean, if you're looking at as far as how much the plane is when you're lifting from the ground, you're flying in a straight line, and gravity, you're not pulling, you're not
Yeah, so
using.
not round the ball then, if we're in a straight line.
You can fly in a straight line on a ball as well.
Can you?
Straight. Yes.
You're gonna go in a straight line.
Yes.
All right, so let's put a ruler, a straight line on a basketball. Where does that straight line go?
Well, if you don't take gravity into account, then obviously it would fly into space. But if you're getting pulled, imagine you have in the middle. Imagine if you have in the middle of
that
the
would be a straight line.
Like take a basketball, just like you said, tie a string from the middle of the basketball, like from the center of it.
That's not a straight line then. If you're going around the curve of a ball, that's not a straight line.
Listen to what I'm saying. You take a basketball, you tie a string from the middle, the core of the basketball, and you stretch it out towards the surface, right? And then you tie to that string, you tie like a toy plane or whatever, and it's just long enough to hold the plane on the surface, right? And you push
that in a circle.
Well, a straight. When I meant straight, I meant the direction. Like you're going straight in.
You mean a circle?
You're not going right. You're not going. Yes, you're going in a circle around the globe. Exactly.
Right, but the plane he's not flying in a circle. He's just flying level.
Yeah, but that's what level means when you're on a globe.
What do you mean? Level means
When you're on a
not
globe
having
and
one
flying
side higher than the other. You know what level means, right?
level means as like perpendicular to the ground, like you're both like you're fly. I can't really show it with my hands, but I'm you know if you're if
Well, it's
if this
defined as not having one side higher or lower than the other.
exactly both straight lines in front of another.
So a straight line.
Yes.
So not a circle.
If it's flying straight, then eventually it would be creating a circle. But if you're looking at it in a
Well, that's not
two-dimensional,
straight then.
no, if you're looking at it two-dimensionally, then it's straight. If you're looking about it in 3D, then it looks like it's creating a circle, but it's still flying in the same direction.
Right, so you understand it's really not a good argument for the globe just to say, well, yeah, they treat it as flat and motionless, but we can just say the word gravity and imagine that some
But I just
unquantifiable force is holding them to a ball and they don't have to make any adjustment whatsoever, and we
I
can just
just
believe it's a
explained how
ball.
it works. If you can literally do the same thing yourself, take a basketball, tie a string to the middle, pull out a plane, and just take the plane and push it in a straight line. It will fly around the globe in a circle, and you won't have to take into account any angles because the gravity, the string, in our case, is pulling you towards the ground. You're always flying perpendicular to the ground. You don't have to bend the plane towards the
No,
ground.
don't get me wrong. I understand the argument that they make. It's just a shit argument.
That's a valid claim. You can say it's a shit argument. I
Yeah, it's a shit argument because you have to assume the ball, you have to assume the gravity, you have to assume that the plane is sticking to the earth because of the assumption of gravity. It's terrible. All you have with a plane is an object flying level over a surface that they treat as flat and motionless. That's all it tells us, which supports our side, not the globe side.
The reason they treat it as flat and motionless, they're not saying the Earth is flat and therefore we treat it as flat and motionless. They're saying
No, they're saying we treat it as flat and motionless as a simplification, quote unquote, or because we don't need to account for the assumptions that we're making existing. But they've got no proof for those assumptions existing in real life. So it would be more logical just to say, well, they treat it as flat and motionless because that's what it is.
because then they'll have to just prove gravity to you. This
What,
basically
the bending and warping of space-time?
No, but what I'm saying is to prove that they're not taking into account because the gravity already accounts for that. They have to prove the concept of gravity to you. Then I'm assuming.
Well, they would have to prove the curvature, the spin, gravity. They would have to prove all those things. Yeah.
Why would they use the terminology we treat it as a flat Earth instead of like on the other hand saying it's a flat Earth and therefore we don't take into account? If they're saying we
Because
treat
it's
it
correct.
as such,
It's correct to say we treat it as a
no, but you
flat,
don't say
motionless
we
Earth.
treat it as such on something that usually that implies like a contradiction. It's like this water is wet, but I'm gonna treat it as if it's dry.
Yeah,
You
because
don't say,
they might
you
believe
can
that it
just say
is
the water is
actually
wet.
a spinning ball. They might believe that it is the spinning ball. But it doesn't matter. They still treat it practically as flat and motionless, which has more weight than belief.
I mean, yeah, I guess. I mean, belief is not. Yeah, if we're talking about the specific subject, then yeah, then you have to believe, quote unquote, that it's gravity that's accounting for the trajectory of the aircraft.
Yeah, and you have to believe that the Earth is a ball and that it's spinning. You have to believe all of that because the plane itself is not telling you any of that. It's telling you the
Well, I guess
opposite, actually.
you start from proving the curvature, and then we can
Yeah.
prove gravity, right? Would you at least agree that gravity is a concept you're willing to accept, and that we have enough experiments and
not if you're talking about the bending and warping of space-time. I'm afraid I would not.
well, I'm not going to go into that concept because it really is really hard to comprehend and debate around because none of us are like renowned scientists that can actually delve into that.
You don't need to be a renowned scientist to recognize a mental concept. But yeah, I agree with you. It's not really worth because it's not going to tell us what the Earth actually is.
Yeah, it's
But we
irrelevant to
can
the But we
Yeah,
do
I
agree
mean,
that gravity. So if we can substantiate that the Earth has curvature and that gravity does exist, and we have evidence of gravity, and we have enough experience to prove how gravity works and that it exists, then we can therefore jump to the conclusion later on that the Earth is maybe a sphere.
if you could verify curvature, motion, then you could say that the Earth is a sphere that's in motion. Yeah.
Motion, I mean, it's going to be like motion is you can. This is the thing that always like I don't feel like I'm moving is what is a claim I hear a lot from like the flat Earth communities. Like we don't feel like we're moving. How come the air is not slapping my
Well, that's
face?
not really a claim. That's an observation.
Well, yeah,
You
but
don't feel like you're
standing
moving.
if you're standing on a train that's moving at a constant speed, you don't feel like you're in motion either, right?
Right, but then see, you have the same issue as with the plane. You then have to just assume the opposite of what's being actually experienced and demonstrated, again, with no evidence of these fundamental assumptions. So again, saying that we don't feel it and then telling a story about why we don't feel it is not evidence that it's occurring. It's an excuse as to why you can't prove that it is occurring.
Wait. But it's also evidence that it can very well be the case, right? Because we do experience this happening in
No,
our.
no,
What do you
it's
mean?
not though. It's not.
You
It's not
just said you
evidence of
recognize
anything.
it.
To say we wouldn't feel it is not evidence in any way that it is that thing
No. That's
occurring.
not what I said. That's not what I said. I'm saying that we do know from our life experience that we can stand on moving objects but feel like they're not moving, right? That's a fact.
Well, I wouldn't say that you would be able to give me any example of a time that you've been on something that's been moving at 1,000 miles an hour that you haven't been able to tell.
The velocity of the object is not what matters. If you're moving on it, then you have the conservation of the velocity.
Yeah, but this is the other part that the globe side get wrong, is that they say, oh, well, you can't feel it if it's constant motion, but the globe's motions aren't claimed to be constant, so that doesn't work either.
It is constant to the amount where you would feel it or not. That's
Well, see, this is when you get into the quantities that no one is actually quantifying, right? So you're saying the speed variation caused by its elliptical orbit or whatever else resulting in a decrease or an increase of the motion, you are claiming that amount is indetectable.
Wait. We're talking about the Earth revolving around itself, not around the sun. That's the speed.
Well, no,
of
that's
velocity.
just one motion. That's just one motion of the claimed motions. You've got like 5 different vectors going on at variously mind-boggling speeds. This is another thing you need to wrestle with. When you're talking about the motion of the Earth, you're not just talking about axial rotation. You're talking about a whole plethora of vectors and incomprehensible speeds.
Angular speed, linear speed, and of course you have the rotation of the Earth.
And no one's ever measured any of it.
Well, what do you mean no one's ever measured any of it? We know how fast the Earth rotates. We know how fast we're moving through space.
No. They claim to have a speed. They claim a speed that Earth rotates. You don't know the Earth is rotating at all, let alone at any speed. You don't know that it's rotating on its axis, let alone that it's flying around the sun, chasing the sun, going around a great attractor at the center of a galaxy. You don't know any of that. No one's ever measured any of it. It is a religious belief.
I mean, it's not religious. We have scientists conducting experiments on this all the time. You have astronauts
No,
in
you don't.
space.
You don't have a single scientist measuring any motion of the Earth.
Of course you do. What are you talking about?
Okay,
Measuring
which one?
the velocity of the Earth?
Okay, which one?
All the time. We know if you can.
Okay. Tell me the scientist.
You can quick search through Google to see exactly how fast.
I bet you can. Let's do it. Tell me what you got. You think we didn't Google this, bro? You think we've been on this for however many years? We didn't think to Google it? Come on, go through the exercise. Tell me who measured the motion of the Earth.
What do you mean? Tell me.
Wait, who measured it? Who measured the motion? Let's start with the axial rotation. 1,000 miles an hour at the equator. Who measured that?
What do you mean who measured it? Multiple scientists measured it. It's not one guy who's like, guys, I calculated the
Well, who was the first one to measure it? How did he measure it?
I don't know who the first one was. I just know that,
Okay.
that obviously scientists. This is the
So
whole thing about
name
science.
one.
It's
Name
not.
one.
It's not some guy. Science is not one guy saying something and everyone
Okay.
being like, you know what? I
So
agree
you
with that.
don't know of one guy that's measured it, though.
No, but I know that if it's
Right.
consensus
So you
in
don't know it's
science,
been measured. If you don't know of one guy, you don't know that it's ever been measured.
I know
Just to
that if there's
appeal to some
consensus
vague
in
science is not sufficient. You understand
well,
this?
everything in life that we do is determined by science. All the technology you have today is determined by
No, see,
science.
you're not thinking about this critically enough. You've been presented with a claim. You've been presented with the claim, even though you detect no motion on the Earth is spinning at 1,000 miles an hour, doing this, doing that. And instead of asking for the proof of that, you've just said, well, science has said that, so I'm going to go and argue it to other people.
I'm not saying that science has said that. I assume that if I go through the steps of how you can calculate it, then I could easily be
I'm not
proven
talking
by.
about an assumption and a calculation. I'm talking about who's measured any motion.
Well, you can measure the motion by the. Well, that's the whole point of the globe model. You know exactly when there's night and day, and you know how fast Earth is rotating to produce the exact numbers of
Right, but
hours of daylight.
that's an assumption based on a globe. We're asking who's measured these things, or is it just a belief?
I assumed that it was measured by multiple
Okay.
ways.
Well, let me update your assumption. No one's ever measured it.
I don't know if it's even possible to measure something on that scale.
Yeah, it's
Like they
not.
can
That's why
measure
no one's
things,
ever measured it.
but yeah, but
No
that's
one's
not to say
detected
that it's
any motion
wrong.
of the Earth,
But it's not to say
other
that
than
it's wrong.
earthquakes.
It's like saying I can't lift this mountain with my hands
Well, if
to
you're going to
measure.
say we can't experience it, we can't detect it, and we can't measure it, why should we believe it?
No, but that's okay. So I'll give you an example. Like let's say if I say Mount Everest weighs X kilograms. Well, you didn't lift Mount Everest and put it on a scale to know how much it weighs, but that doesn't mean you
Yeah, I'm
can't
going to
know.
understand that whoever's claiming that doesn't actually know it.
So you're
It's a
saying you never
calculation
measured
based on an
Mount
assumption.
Everest. You never measured Mount Everest on a scale, so you don't know how much it weighs. But I know
Yeah, so I
how to
wouldn't go
make
claiming
calculations.
no. I wouldn't go claiming to know how much Mount Everest weighs.
Yeah, but you can know how much Mount Everest weighs for fact, right?
Can you?
I mean, yes, you know how much
How much does it
rock.
weigh?
I didn't check it, but if someone's
See, bro,
theoretically
you're
wanted,
making claims for things you think you can know when you don't actually know them.
but I'm saying science can easily. I mean, we can check these things by like measures that are easily proven. You don't have to do something and in order to know exactly you like the way science is conducted is not like, okay, I can't lift this thing, so therefore I can't determine
Well,
its
it's the
weight.
wrong category anyway, right? Because science is dealing with cause and effect relationships using experimentation. I mean, if you're talking about measuring the motion of the Earth, you should be talking about some kind of measurement of the motion of the Earth, which no one has done. And if you think that's sufficient, that you can't experience it, can't detect it, and no one can measure it, if you think that's perfectly fine, then good for you, I guess. For
I mean,
me, that's not perfectly
you
fine.
have satellites and you have multiple ways in technology where scientists.
Nah, but see, they would have needed all of this before satellites because they had to know it all before they could launch things into space, into orbit. They had to have these numbers. They had to know all this.
Calculations, how much daytime, well, if you have to
No, and if you're
provide.
looking at daytime and nighttime, that's just looking at the motion of the sun, not the Earth.
Yeah, but like if you're looking at the axial rotation, and you know how fast Earth is spinning with regard to the sun, then you can
But you don't,
therefore.
because you don't know that the Earth is spinning, because you've got no detection of the Earth spinning.
Well, then it's what I initially said is that it's building blocks. You have to you build one premise on the other. If you can show
You don't
curvature.
just stack claims that you have no evidence for, and then come out with a thing that you say is true. That's not
No,
how
I
it
didn't say
works.
it was true. I didn't say it was true. I said if I could prove that curvature exists and therefore gravity, we can.
Right, but this is the point. No one has.
Building blocks.
This is why
I'm
we're
saying-
here.
Yeah, I understand what you're saying, but like I'm just saying, like in science, they don't necessarily have to, um, uh, um, do a certain thing in a certain way to prove to come to the conclusions that they came to. You can
Well,
get
you can
empirical.
conclude whatever you want, but if there's no existence of it, then you're just in fantasy land. And if there is existence of it, you have to be able to detect or measure it in some way. The fact that they can't tells you that it's not real.
You're saying they can't, but I'm not sure why you would
Well,
say
this
that.
is it. I mean, you're saying they can, but when I ask you who did, you don't know. So you don't know that they have.
Well, if they know, if they're sending out satellites into outer space to revolve around Earth, right? And they're
So if we
they know
assume that that's true,
so you're saying there's no satellites?
well, in like a vacuum of space, as they tell you, yeah, no, there's not.
So how does your whole global GPS system work if there's no satellites?
Well, navigation and GPS and things like that have been using ground-based technology for many years, towers for the most part. So again, I mean, you really need to be digging into the fundamentals. Who measured curve? Who measured motion? You're saying you don't know of anyone, but you're sure someone has.
Anybody specifically, it's not.
Yeah, but that's what you should then be. That should spark your interest to go, I actually don't know that. I need to go and find that out to know if what I'm saying is actually true. Like, that should have been the first thing you did. If I'm telling you no one's measured it, you should say, yes, they have. I'm going to find out exactly who.
Saying I don't know who measured it does not mean I don't know how it's measured. That's what I'm trying to say. I can calculate I can do calculations on certain things without knowing who invented the formula for whatever.
Right, but if a calculation is based on assumption that you don't verify, that doesn't mean it's true.
That I agree with. If it's based on an assumption that you don't agree with, then there's nothing to talk about.
Right, so looking at the sun and saying, I assume that I'm spinning, is not evidence that you're spinning.
That's correct. I agree with that assumption.
Yeah, so no one's actually measured that the Earth is the thing moving. That's just a philosophy. Heliocentrism. Which has been admitted for many years by people, very famous astronomers. They agree it's a philosophical preference, not a scientific one.
Well, science is not well. The problem is when you're trying to say science, like you have to understand that nothing is 100% fact in science. They always base their theories on what is the most plausible explanation to whatever phenomena is happening. So you're saying no one can prove, I don't know, that the Earth is spinning in this because we don't have a giant that can hold the actual size of the Earth, and therefore check the.
No, I didn't say anything about that. I just said no one can detect or measure any of it. So why would you believe it?
I'm sure they can, but to tell you who invented the actual the actual how do you say the way of how you calculate it is what's relevant. Like
Right, but we're talking about measurement, not theoretical calculations.
Yeah, measurement is done through the calculations, though.
No, you need the measurements, and then you can maybe do some calculations with those measurements. So you don't do it the other way around.
What do you mean? I mean, if
you're going to claim that the Earth's spinning at this speed, you need to be measuring something. Like, you need to be measuring something moving at that speed. And all they're doing is looking at the sun moving and saying, let's just assume that we're the ones moving instead.
Well, these are all things that are substantiated through other.
What do you mean? What's substantiated?
I'm saying they build it on one. It's like not. It's not that scientists go, I see the sun. I see we have night and day. That I assume the sun is. We're rotating around the sun. It's not.
Yeah, that is exactly what they're doing, bro.
I think you're kind of.
That's what they've done since the creation of the heliocentric model by Copernicus hundreds of years ago.
You're kind of not giving credit where credit is due towards scientists on how they conduct science and how it works.
Unless you can give me a specific example, I'm going to dismiss that as vagary.
Well,
what science was done to prove heliocentric globe Earth?
Well, there's tons of scientific evidence for this stuff. Just because I don't know of it all doesn't mean it doesn't exist. And saying that scientists just assume things is the complete opposite from what science actually is. Science is never
I agree. It's not real science, it's pseudoscience that's being done
science.
for the
Science is
globe.
never assuming something happens. Science is proving cause and effect throughout.
Yeah, the astronomers readily admit that they're not following the scientific method, right? They admit it's not based on the scientific method. Therefore, it's pseudoscience by definition.
I'm not sure about what astronomers actually believe.
Well, I'm quoting Michio. Sorry, I'm quoting Michio Kaku there actually, who said in his line of work they're not using the scientific method. It's a lot of guesswork and leaps of logic, and they're off by a factor of like 10 to the 120 or something like that. Basically saying the whole model is shit and we're way off.
So you're going to believe one scientist as opposed to every other scientist on the planet?
Well, no, I'm not saying that, but there's no scientist, quote unquote, on the planet that I've seen that's doing any experiments to prove or measurements to prove that the Earth is spinning ball.
You know what I find kind of strange? This is way out of context, but during the corona, when the whole conspiracy about the shots and the corona or whatever, you'd have doctors on both sides arguing with or with pro or against shots or whatever or the effects of corona. And that kind of gave me reassurance that maybe I'm not completely aware of how things work and how what
well,
we
can't
know
really
about.
discuss medical on this channel because it's TOS. But
Yeah. Why I didn't bring it to delve into that subject. Obviously, what I'm saying is I haven't found one scientist till today that claims the Earth is flat and can prove it through scientific evidence. If you can,
well, it's a category error. It's a category error because science isn't the tool you would use.
What tool will you use if not science? YouTube?
Well, long distance observations, laser tests, testing the geometry that's claimed.
But in order to do these things, you have to understand how the physics of everything works. Who knows it better than people who work in science?
Right, but you're just getting a little bit confused on the terminology because science is the scientific method, right? Which is cause and effect relationships in the natural world, experimentation, independent, dependent variables, manipulating a variable to see if it gets your assumed cause. So determining whether the surface is behaving in a certain way, it's not in that category. But I get what you're saying colloquially. You're meaning stringent testing from people who are taking the work seriously type of thing. I get you.
Yeah. Yes, and I have yet to see any compelling evidence on the other side by renowned scientists who are actually you know what, guys, we got this wrong, and because science is known for being critical against its, science is always trying to disprove. If in science they actually they incentivize you to find
within a certain paradigm, sure, to a degree, but no, not generally. In academia, there's very much still political and philosophical bias in academia. There's still very much political and philosophical bias, right?
I mean, probably, but it still doesn't. But there's still a lot of critical thinking, and that's what science is all about. You can win Nobel prizes for disproving a certain theoretical.
Well, this is the beautiful thing, right? You do not need a PhD to understand what the globe model claims about its geometry and go and test that in the natural world. You do not need to be a genius to go and test your line of sight.
So if you have the average Joe, right, who knows how to calculate those things and reaches certain conclusions, how come all of the scientists that know more about any other ordinary person has never came to the conclusion of flat earthers? That's what I'm saying. It's like saying,
well, there's a few problems there because you're making assumptions. You don't know what every quote unquote scientist thinks, right?
Do you know
that's an assumption on your part. You're just going by what the mainstream narrative essentially is.
I'm asking you. I don't know. Do you know of any flat Earth scientists?
I mean, it depends. I mean, again, I feel like it's a misuse of the term. There are people who have PhDs in various fields that have conducted long-distance observations tests and come to the conclusion that the Earth is not a globe.
Do you understand what's to you? Is science a verb or a noun?
It doesn't matter. Like,
is it something you do, or is it a person, place, or thing?
Well, you have something. We have people who act in the doing of science, and you have which are scientists, and you have science in general, which is a concept. I don't get what you're trying to
So when I say to you, when the flat earther says that science is a method, a practice, something you do, something you do,
what other method would you use?
You can do logic or reason.
But you don't determine technology by logic or reason, right?
Yeah, you can do that. You can see what works and what doesn't work.
Well, that's not how you do it. You conduct
It's practical,
science.
like practical use. You're not determined. Science determines cause and effect. It's a method by manipulating variables to determine cause and effect. But what you did is you took the science out of the science, then just said this dude over here is the science, and that's basically what some scientific people were a couple years ago. Just went on national television and told the world, "I am the science." And you don't see a problem with that at all.
No,
that people say that science doesn't speak for science anymore. They speak for science. They tell you. They're like a major league umpire. They call the balls and strikes. You are just a layperson who will never be close to science. Science is not for you. They use science as a weapon to get you to comply with their worldview. Where if if it really was about science, they could present the science and let it speak for itself.
But that's exactly what they do.
That's not what they do.
No one has a ban on science and says you can't conduct science because
just type this quote in. Don't come back and say what it is, okay? Because it's a TOS problem. Type in who's quoted with declaring themselves "I am the science," and just go down that rabbit hole and come back. You're like, holy shit.
Just because one person said something doesn't mean that it disproves.
Yeah, then compare it with the world events that were happening at that time.
So, are you also critical about doctors? Are you going to say doctors are making tons of shit up, and then I can probably determine?
Yeah, I get a second opinion. If a doctor tells me a bunch of crazy shit, I'll get a second opinion. Yes, definitely. And even better, I can say no, thank you. I'll just do my own remedy. I'll come up with. I know my body better than you. You came up with some crazy shit like cat scratch fever, or some of the lunacy. You used to call
Yeah, this one is. I can take it.
Yeah, Felix, you're hot micing, dude.
Okay.
Felix, you're hot micing.
Okay. Okay.
Can someone mute them? Thanks. I was tabbed out. So what you're looking at here is if you go to a doctor and you come in and you went to a doctor because your tooth hurts, and he tells you to take these anger management classes that his nephew's instructing. It's going to cost $100 a class, and by the end of that, you'll feel better and you won't be grinding your teeth at night. Would you be like, what the fuck?
Yeah, of course I would be like, but what would you do then? Would you go to your friend
Get a
and ask
second
him,
opinion?
But let me finish my sentence. Will you then go to your friend or some other source and be like, I don't know, your mother or your brother or your girlfriend, and be like, look, my tooth hurts, my doctor said this and that, what should I do? No, you would go to another doctor to get a second opinion, right?
Or you could just find a home remedy or something like that.
Well, you're not going to determine through logic and reason what medicine you actually need, because you know nothing about the field of medicine, unless you're willing to take risks.
Yeah, you got first aid and old wise tales and different things that can work.
But what I'm saying is it's not consistent with how you actually work in the real world. It's like when you have a problem with your car, you go to a mechanic. You don't go to a YouTube.
Yeah, and the mechanic tells you that your blinker fluid is low. It's going to cost $3,000 to fix it.
Obviously, it could be either unprofessional or lying to you, and then you need another opinion of another mechanic.
Yeah, but in your worldview, you would just have to trust him, them, or
Yeah, but you wouldn't go to a veterinarian then and be like, look, my mechanic told me that I have, I don't know, fluid running through my whatever, right? You would trust another mechanic's opinion. That's what I'm trying to say.
Or just check it out yourself.
But you're not knowledgeable enough to understand how your motor in your car works.
Because
work in the profession and do it for years.
Because they don't print out Haynes manuals that you can buy that break the car down.
Study it for years.
See, you're the reason why back in the days of yore, when you bought a car, they gave you basically the manual for the whole vehicle, like the owner's manual, broke down how to do virtually everything, how to repair the car, and you could decide if the repair was too complex or not, or if you had the appropriate tool. Now, because of people like you, the owner's manual says don't drink the breaker fluid. The brake fluid.
See, just quickly, this line of argumentation, this must have been what it was like back in the day when the people who were breaking off from the Catholic Church were asking questions and challenging the idea, and they're being told, well, listen, you guys can't figure it out, listen to the priest. They understand it better than you do.
I understand your attempt of equivocating that with the priests of the church back in the days, but I'm not saying don't take anything don't question anything scientists are telling you. Like, scientists are not some elitist group that are disconnected from the people. Like, you can know scientists who live across your
So stop talking about them like they are. Like they're the guys who can measure curvature. They're the guys who can measure spin. They're not doing any of that. This class of people that you are appealing to do not exist.
What do you mean they don't exist? Scientists don't
There
exist.
is not a group of people who have, quote unquote, scientifically proven that the Earth is a spinning ball. That does not exist.
Science has proven throughout the years. It's not just a single individual scientist being like, I prove that the Earth is round.
Okay, well now you're back to a verb. See, look how you keep switching that word. In one context you use it as a verb, the next context you use it as a noun. You are unable, like you're squirming. You're like this worm where
acknowledging the differences between science and
science. But think about it, Jeff. Think about it, Jeff. You've been here for hours now, and you haven't provided one example of some scientific proof of a ball Earth. So if that existed, you would have had it by now.
I didn't come here to prove my point. I came here to listen to
Okay, fine. That's fine. That's fair. But at the same time, you can't keep saying, but they have proven it without providing any of this apparent evidence, without even being able to name what they did or who was involved. That's not fair, right? You need to actually evidence your claim.
But I'm saying you're selectively choosing when to trust science and when not, because when you're looking at technology, you're like, okay, yeah, this cell phone works, everything's in place. When I drive my car, I trust that the brakes are going to work because
but we're not challenging those things. We're not challenging the things that we can all know and experience.
But then when it comes, let me finish my sentence, please. And then when it comes to the shape of the Earth, you're suddenly like, no, I don't trust what scientists say about the shape of the Earth, but I do trust them to build my car. And so that it doesn't fall apart.
Not analogous.
Like, why would they lie about this? One second. Why would they lie about this specific subject that is a whole, like, is a small part of what like science actually is?
Right, bro. I get what you're saying. I get what you're saying, but it's not analogous. It's not analogous. Things that you can deal with, observe, manipulate, test in reality are in a separate category from the Earth being a spinning ball, which is not something you can observe, measure, test, or verify. So those are separate things. So to say, because I use an iPhone, I can assume that the Earth is a ball is a massive fallacious leap. Right?
Well,
you having an iPhone, and we're not disagreeing with iPhones. We're not disagreeing with cars. We're disagreeing with the thing that isn't experienced, observed, measured, or tested or detected, which is the globe.
But the methods of how these cars and cell phones were built were the same methods that were used to discover.
No, they weren't. That's crazy. What are you talking about?
You're saying it's a different thing.
What method used to detect the globe was later then used to make cars?
Physics, basically. You're talking physics. You're talking mathematics.
Yeah, none of that is to do with a globe. What do you mean?
Well, how else would you? What other metrics would you use to determine these things if not physics and mathematics?
What do you mean? Physics doesn't tell you anything about the Earth being a spinning ball.
Well, if you say that, then and you don't take into account any of what science is like, the ground, the bricks and the fundamentals of how they got to this conclusion, and you disregard it completely, then maybe, yeah. But it's been substantiated
Oh, bro, to be
across.
honest, it sounds like you don't know how they came to this conclusion.
Well, we can see throughout the years how they established their experiments, and what they laid the ground rules for, like how they, what, like, basic fundamentals they and principles they
Okay,
founded.
what scientific principles was Copernicus employing when he came up with the heliocentric model?
I'm not knowledgeable enough in science to know how he came to those conclusions, but obviously.
So you don't know that then? What you just said, you don't know. You don't know about the building blocks, quote unquote. You don't know how they came to this idea.
I don't know about all the building blocks, but when you look at the model.
So you don't know that it's science, my friend.
Because I'm not a scientist, but I'm saying, as a whole, when you look at the model of the globe model, everything seems to fall into place and make sense. And I find no better explanation. If you came out of the blue and said, I can explain to you in better terms how the Earth operates, like, say, flat earthers.
You can only explain to us that the Earth is observed and measured flat, which we agree with, and then you'll come up with a bunch of stories that you've heard about how, even though that's the case, it's actually still a spinning ball because of X, Y, and Z unverifiable claims that you have.
Well, if you're looking at only an observation, then I'd have to argue that there are some things that you can't observe, but that doesn't mean that they're not.
Yeah, you just have to imagine based on stories from the authority. That's it.
But, like, if I'm going to go back to the explanation about gravity, we can't see gravity with our own eyes, we can't grasp it with our hands, but it exists nonetheless.
Yeah, you can know things fall to the floor. You cannot know that the Earth is curved or spinning or in a vacuum.
You know things fall to the floor, but you don't see the gravity pulling it. So what's pulling it to the ground? Magic?
Well, it has nothing to do with the Earth being a spinning ball in a vacuum.
I'm putting that aside for a moment. I'm saying you can
Well,
base
that's the
your
point.
observations. No, I'm putting aside the shape of the Earth for a second. I'm saying you can reach certain conclusions without being able to.
No, you can't put it aside and then use it as your evidence for the assumption that you're putting aside. That doesn't work. Either it proves that the Earth is a spinning ball, or it does not. And everything in reality does not.
Well, then you're gonna have to explain to me how gravity works according to the.
No, I'm not going to have to do that. I don't know why you think I would have to do that.
Because we can't see gravity with our own eyes, so how does it work?
Again,
I'm going through the same
nothing
logic.
to do with the Earth being a spinning ball.
I
mean, if this is what you have to fall back on when someone asks you what's the scientific proof that the Earth is a spinning ball, you start asking them why things fall to the ground. You understand that is not scientific evidence of the Earth being a spinning ball.
I didn't claim it was scientific evidence. I'm saying if I apply the same logic that you apply with, which is we can only trust or conclude things based on what I observe and only upon what I observe, then you'd have to explain other phenomena that you do come into.
No, I don't have to explain why things fall to know that the Earth isn't a spinning ball.
Explain, but you at least have to. You'd have to tell me.
I can acknowledge that things. I would have to acknowledge that some things fall. Yes.
Yes, exactly. That's what I'm saying. You have to acknowledge the same way you'd have
I
to
acknowledge that some things fall on this observably, measurably flat, motionless surface. I agree.
Okay. And you don't have an explanation for that. That's what you're saying.
Well, they appear to order themselves based on their density relative to the density of the medium that they're in, but beyond that, I wouldn't really make any other claims.
So, okay, so you're saying
Which is essentially the same side that the Globers are in if you actually listen to these scientists, quote unquote, some of them, like Neil deGrasse and that, they'll tell you they don't know what gravity is.
He's not saying that we don't know what gravity is in the sense that we don't know what it is. He's saying that it's a concept that's very hard to grasp, but we have a very small understanding.
No, he said, I don't know when he was asked what's gravity. He said, I don't know, next question.
Gravity is a wave. We all know that gravity is and exists, right? Or we're going to deny that as well.
Well, I don't know. Can you define it yet?
Well, I kind of did before, but it's not going to be, fulfilling.
Well, this is it. If the first port of call on the globe-proof Tor is a word that you can barely define, that doesn't bode well for the argument generally, does it?
There's a lot of things that I can't define or explain because I'm not a scientist. I don't know how exactly these things come down and work to the T, but I do understand the concepts of how it works. And then if I have to make a decision based on what gives me a better answer to how things operate and work, I'm gonna have to go with what's more logical and what appears to be more convincing, right? So on one hand,
well, if that were true, does that mean that you don't find observable reality convincing? Because you only observe a flat motionless Earth.
So I have two options. I did study a little bit of physics, and I know that through physics I can throw a ball in the air and I can determine exactly where it's going to land depending on the velocity that I threw it in the air and the direction, right? So I know.
Do you have to take into account the motion of the Earth or the curvature of the Earth or anything to do that?
That has nothing to do with what I just.
Right. Okay. So things rising or falling, nothing to do with Earth being a ball.
But I didn't finish what I was saying. I'm saying I can't prove to you in certainty all the things that scientists probably could. But what I'm saying is I have two options. I have things that I can measure, and I know that are used to measure other things that I know that how they work and how they operate. And they're giving sufficient evidence to how they conducted the experiments, and they gave me a model which explains how seasons, how tides, how night and day, everything operates and works together.
Nice. What model is that? You still on this one, Cyclone?
Well, it's I think he came in a bit later, but yeah, he's went full circle back to the model. So.
And all of these things just mesh in together perfectly. Then I would say maybe I don't understand exactly how everything works to the ground level, but it's definitely a convincing explanation. So I'd have to go with that.
I don't know, bro. It sounds like you've just been told a story and you said that's a convincing explanation.
There's no proof, and I don't know how to prove. Wait. Let me finish. Opposed to flat earthers saying that doesn't prove anything, and then I asked them, "What's your explanations for these things?" I don't have to provide an explanation, and I don't have any idea how these things work. But I just don't.
Yo, Jeff. Yeah, you're real excited. That's cool, man. I've heard you on for hours, right? But what model are you talking about specifically?
I explained before, if you were here, the globe model.
Okay, the globe model. What does that look like to you? Did you have a depiction of it?
If you randomly write globe model into YouTube or Google,
I don't want to randomly write anything. I want you to tell me because it's convinced you. Whatever it is that you're talking about, it's convinced you, right?
It's the Earth rotating on its axis with a slight tilt around the sun.
Okay, so what does that tell you in regards to like anything that you're describing right now?
What do you mean?
So you're talking about something. But in what way is that a scientific model? Because a scientific model has an explanation of things, how it works.
It does have explanations on how it works, though.
Okay, like what?
I just went through multiple. I don't know if you
pick one. Let's pick one first. Let's take it slow. Pick one thing at a time.
I can throw out multiple things, but again,
I don't care about multiple, Jeff. I just want you to pick one. Pick one.
Okay. I don't know.
Just one.
9 day and seasons.
Oh, one thing. Not 9 day and seasons. That's multiple, sir. Relax. Just pick one. Season. Okay. What about the Earth as a globe? Explain season, sir.
That's what I tried to say. It's not. You can't detach one thing and
sir,
explain.
Relax. I'm only asking you a question. Just respond to the one question. Don't get excited.
I'm not excited.
What about seasons? What about seasons tells you that the Earth is a globe? Because we're talking about geometry. We're talking about geometry. Geometry, right? The Earth is an oblate spheroid. Okay, what about the seasons tells you that the Earth is an oblate spheroid?
Well, we know that the seasons are basically cycles, and we know exactly which places are hotter or colder during the year, and we know that there are places on the if we're gonna argue it's a globe on the globe that have more light during the day, like more day.
Right. So you're just telling me that geographically, some locations get more sunlight, and the other location doesn't get as much, right? Is that
And
correct?
that some places are colder than other places and hotter than other
Okay, great. So now, how does that tell you that the geometry of the Earth is what it is? How do you know? It's just cycles. You're just talking about something that has cycles. That's it,
Well,
right?
if you take what I'm trying to say is, if you take apart every piece of evidence and then just try on its
That's what
face
we're
to
doing right
explain,
now, sir. That's what we're
but
doing right now.
everything has to work in correlation. Like I can
Okay,
invent a model.
stop, Jeff. Relax. We don't need correlation. We want you to tell us how directly cycles tell you that there's geometry. We're gonna connect them right now. If you
listen to what I'm saying, that's not what I'm claiming.
I
I'm not
am
claiming-
listening to you, sir, but you're not connecting geometry with the cycle. So I need you to do that.
I'm not connecting geometry with the cycle. When you're basically tilted away from the sun, when you're on what we said before, the Earth is tilted on an axis. When you're tilted further away from the sun,
Stop.
and
That's that's a logical leap. We're not tilting anything on any axis. I need you to tell me directly how cycles tell you the geometry of the Earth. How does cycles give you radius, diameter, and circumference, sir?
But you're going the opposite way around things.
No,
What
I'm
trying
not.
to
Because you're thinking that you're standing on top of something that's a geometric shape. So if you're on the geometric shape, you're going to have to tell me exactly how you're getting a geometric shape from the thing that you said gives you a geometric shape. You said season.
What I'm claiming
Remember?
is seasons part. Yeah, but seasons is only one part of the puzzle. You can't
I
take
know.
one
Well,
part.
we need to stop.
paint
We
a
need to
picture of
stop. Because you're excited. You want to say that this thing
Why do you
shows
keep
you that
saying I'm excited? I'm not excited.
very excited. You are. I've heard you for like hours already. You need to relax and you need to talk about the one thing that tells you that leads to another. So if seasons gives you the answer for geometric shape, then we need to examine how that's telling you that it's a geometric shape, Jeff.
I'm gonna answer and say it again, and maybe this time you'll get it because I'm not conveying myself correctly. I'm not saying that seasons or night and day or any other evidence I brought before was a clear path to prove that is sufficient evidence to prove that the Earth is a sphere. That's not what I'm claiming.
Okay, so let's get to the bit how we understand that, right? If none of those things, right, Jeff, if none of those things give us a geometric shape, let's go to the thing that does, right? Let's figure out what, if those things don't give us geometric shape, let's figure out what does. Okay?
That's not what I said either. You're not listening.
Yes,
Please let
it
me
is.
finish.
Those things don't tell us that it's a geometric shape. That's great. I'll let
Listen,
you
if you're
explain.
you're not gonna let me finish my point. Then
You
there's no
just
point.
told me that's not giving us a geometric shape, Jeff. So let's go to the bit
not
that
what I
gives us a geometric shape.
All right. Yeah. Let's let him conclude his. So you said none of those things actually prove that it's a
Yeah,
ball.
let me-
Then what?
Yeah, I would just want to drive. Let me drive this.
We have observations, and we have certain things that we know that are happening, right? We have phenomena that we can witness every year that are happening in a certain way. Now, if we take, let's say we put it on to we know X, Y, and Z.
Yeah, you've
Okay.
been explaining it for like 2 hours. I understand it.
If we look at X and then we say, let
Jeff,
me
relax, bro. No, you've been finishing for 2 hours, sir. You've been telling us about the phenomena. I don't care about the phenomena. What I need you to describe to me is how any of this tells us that the Earth is a geometric shape. I don't need you to finish anymore. You've already said enough. Okay, you've explained enough for 2 hours. I've heard you.
What I'm saying, if you take all these things into consideration, the only shape that can satisfy all of these phenomena at the same time is a sphere. That is what I'm claiming. I'm not saying I can fly to outer space, take a picture, and give you a sphere picture and say, here you go. Look, I took a picture from outer space. I'm saying that all of these explanations, all of these phenomena can only make sense on a spherical model.
You're way too excited. You've already explained that. I understand that you said that is your assumption. Because you just said it yourself right now. The only thing that can work on is a globe, a sphere, right?
True.
Okay, that's your assumption. That means that you're assuming that everything can work on a sphere. But if something can work outside of a sphere, you haven't looked at anything. You haven't even said.
What you're saying is absolutely true, and I agree with you. Can you provide me any other geometrical shape that could provide answers to how all of these phenomena work together? I'm willing to listen. I'm all ears.
All right, so you don't need a geometric shape for any of this phenomena to take place. It's not all those things that you're really excited to talk about. They don't have to have a geometric shape to precede the things that you're saying happen on the Earth.
Okay, then
This is
explain
the
to me how. So explain to me
okay.
how night and day seasons work on a
So
flat Earth model.
yeah, night and day only depicts the fact that the sun is in a geometric location wherever it's located. Think about it like this, right? If we're saying that the Earth basically is the floor, right? We're talking about in your mind, you have to discard what you've learned. I'm going to give you kind of a cosmology aspect so that you can understand where we're coming from. If that's okay, just don't get too excited and interrupt. That's all I'm asking.
You're gonna say that
So
I'm
first-
excited again. I'm not gonna continue the debate because I'm not excited. I'm
Well,
literally engaged
just
in good
relax,
faith. I
bro.
want to hear what you have to
I
say.
know that you're in good. Listen, I know that you're in good faith, but you do sound excited. Okay, you're really excited. You want to explain how everything works because of
I
your
don't know.
assumption that the Earth is a geometric shape. That's all I'm
No,
hearing you do.
no. The
All
reason
right.
you think
So
I'm getting excited is because you keep cutting me off in the middle and you're not letting me finish my
you've
sentences.
been
Maybe
explaining
that.
about why you listen, Jeff. You've been explaining why you assume that the Earth is a globe because of all these phenomena that you just told me, and you said to me that is true. You're assuming. So that's all we know right now, that you're assuming that the Earth is a globe because you believe all this phenomena is taking place over a geometric shape. That's what we understand right now. All right.
Yes.
So if I
Yes.
give you another thing to think about, at least you have something, right? Other than the
True.
globe.
Yes. And I'm willing
Right.
to listen. Of course.
All right. So when we go from the aspect of the Earth being a flat and stationary plane, the horizontal plane of reference that we're talking about right now is the floor of the universe. So from a cosmological aspect, we're saying, okay, the ground that you and I are standing on is a horizontal plane. The horizontal plane that we're referencing is the Earth. So we're saying that in a grand scale, the Earth itself is a horizontal plane. So if I'm standing upright in North America and you're in Europe, you're upright as well. We're standing horizontally to each other. We're not antipodal. We're not on the side of a ball, and so forth. So what we
How
were
far?
saying with
Can you tell me how far apart are we? Like a
okay.
scale.
Remember you said you were gonna let me explain? Remember you said that?
Sure.
Okay. So when the sun is moving above your head, it's moving horizontally across the plane, the horizontal plane that we're saying. So the sun would be the thing that's in motion, not the earth. The earth is still, it does not move. In that way, the sun would be the thing that's moving above your head. So if you see the sun moving from the horizon east to west, it would be the thing that's moving and not the earth. So when the moon is moving above your head, same goes for the moon. It is moving, not the earth. When you see the stars are moving, not the earth. From a cosmological aspect, we're only saying what we see as far as what we're saying we see. We only see the things.
You can't see the sun and the moon at the same time, right?
Yes, you can. At some days you can.
But like no, I'm saying like they're always opposite to each other in your model,
No,
right?
they're
They
not.
can't be.
No, they're not.
So you're saying, so you can have eclipses in your flat Earth model.
Yes, you can.
Okay, so how would you? So what's casting a shadow on the moon during an eclipse?
Unknown. And I would say that because the phenomena that takes place with
Unknown.
eclipses.
Wait.
Yeah.
We'll go back.
Sure.
If there's nothing existing in outer space and it's just us, the moon, and the sun, and a giant ass object is reflecting its shadow on the moon, and you just say we don't know, that's not evidence. That's a bigger leap of faith than the
No,
globe
it's
model.
not. The leap of faith happens when you start to assume what it is. We don't assume what it is. There's no need to assume. When you start assuming, like, listen, Jeff. When you say it's the Earth and the Moon and the Sun, right? Because if you're saying that each one of these bodies has a syzygy in regards to any natural phenomena, like an eclipse, right? If you say a lunar eclipse happens because the Moon is getting in the way of the Sun's light, right? Let's just take that for example. How can you provide evidence that that's the case?
Again, what do you mean when you mean evidence? Is this like empirical, 100%?
Evidence, yes, empirical. That means that how can you know exactly that these things are objects in free space causing the effect that you see? How do you know that?
Because obviously experiments have been conducted about how exactly
Okay, so which one? Which one is conducted that they know exactly that's the case?
Again, I don't claim to be a scientist and know all of these methods and know
Okay,
exactly.
so then you don't listen. Jeff, then that shows us that you don't know what it's if it's empirical or not. You don't have that empirical information. There's nothing that except for an explanation, you don't know how that's the case. You're assuming that they have the idea of the information that supports it. You don't know.
Yeah, well, nobody knows. There's no way of actually knowing anything.
There you go, sir. That's the part. That's the part that you need to understand.
You don't know either, and we're both on the same level of understanding. But I'm left with two models. One makes more sense than the other.
Yeah, but it doesn't make sense in regard to them telling you a story that's only an assumption.
But that's like me saying you don't know you're on a plane. How do you know you're on a plane?
Relax, Jeff. We're talking about the natural phenomena that's occurring over the earth. They're giving you a story, and you're believing it because, just like think about it like this: when you're young, you get told stories about Santa Claus, right? You don't know if Santa Claus is real because you're a young person. So, as a young person, Jeff, I'm giving you an analogy. That's all. So, if the analogy is they're telling you about something that does not exist, but they're convincing you because they're telling you that this big chubby guy in a red suit gives presents to little kids, and if you're a good little kid, you're going to get a present, right? So they're telling you this story about something that doesn't exist, and everybody on the earth, usually celebrates Christmas, and they have this celebration and so forth, right? So it looks convincing to you. As you get older, you start to realize. I'm giving you the analogy. Just let me finish. So just when they're convincing you about this tradition, right? They're telling you that all these things are true. Later on in life, you find out it is not true, right? That Santa Claus doesn't exist. It's just a fictional character that they're telling you flies around in reindeer and all that. Once you realize that
conclusions of yourself, you don't need people to tell you that.
Yeah, but once you realize that that's true as you get older, then you realize that it wasn't true, that the parents only carried that as a tradition to give you a happy childhood or whatever, right? That's the only thing that you realize. It's the truth. So the truth about the globe is that you're going to realize that it's not true. Just like Santa Claus, it's a tradition that's been given to you as a story. And it doesn't mean it's true, but you're saying that, yes, my tradition is true because it makes sense. So does Santa Claus. When your milk and cookies are gone, when you wake up in the morning, that doesn't mean that a big jolly red guy in a red suit comes by and eats your cookies. That just means that the tradition that you thought existed, right, like the globe, it doesn't exist. It's a fictitious story that you've been told.
What I'm saying is what can't be proven through direct evidence, meaning we can prove Santa Claus doesn't exist. I just put a camera on my chimney and I can show you that no one is going through the chimney putting in presents by the Christmas tree. On the contrary to that, like when you're talking about stuff that include proving the shape of the earth, whatever, no one can actually know. So what we do have is we use methods of science to come to the closest plausible explanation to what something is, which is a theory.
Yeah, we don't directly. No, it's not a scientific theory, sir. I'm sorry. I can't even give you that. A scientific theory has been proven. So this hasn't been proven. All these assumptions, they paint a picture about a story that they told you about a spinning globe that they don't have any evidence directly to give you, right? Because I'm asking you, everything that you're telling me is
science. Do you know what everything is?
Listen, dude, everything that you're talking about is your assumption. You even agreed with me. You're assuming because all the phenomena that's taking place that they told you is assuming that the earth is a geometric shape. That's what you said, and you agreed with me. So now we know, and you went to listen, the reason why,
bro, you're over speaking and let him respond to you. You keep saying a statement, you ask right, and you don't let him respond if it's right or not. He doesn't agree with you.
Relax, All Glory. He's been on here for a long time. He's been on here for at least now going on 2.5.
I'm not trying to hog the conversation. You have to let me answer your questions. You can't just say stuff.
But you're just saying that because he's saying that. Just relax. All right. So we're talking about eclipses, and the only reason why you brought that up is because I mentioned the cosmological aspect of what we're saying from the standpoint of the Earth being a flat stationary plane. So what we're talking about basically with eclipses is an unknown phenomena is occurring, and it's attributed to the Earth being a globe. And you're assuming that the information that they're giving you that the Earth is a globe and the eclipses are happening because it's a geometric shape is the reason why it's a geometric shape. It doesn't give it credence, sir. It only tells you that the story. Yes, I'm telling you, it's an assumption because I told you. How directly do you know that it's exactly the case that the Earth, Sun, and Moon are actually causing the phenomena of eclipses? I'm asking you now. If you say that you know directly that that is true, how do you know that those are objects in free space causing a syzygy that causes the natural phenomena that we see of an eclipse? Tell me how you know directly.
Well, if you're gonna ask me if I know directly, like 100% no, because I've
Yes.
seen it and witnessed it firsthand, I'm not gonna claim that I'm God and I know how things work in the universe, and therefore
But
I
we're
can
not
tell you.
asking that. We're not asking that if you're God, sir. We're only asking that the information is supported, direct evidence
By
that it is the
substantial
case.
evidence, then yes, the claims that scientists are saying and the evidence they're providing and how everything works in sync and in synergy and works together in the globe model, it's the most plausible explanation, in my opinion. I'm not saying it should be your opinion too. You can believe whatever you want. I'm saying, in my opinion, it's the most compelling evidence that we have today of how things work, and that's how we usually run the world.
Yes,
Is on
which
the most
yeah,
plausible.
fine. That's fine. Which means what you just said, which means because you believe it's the plausible explanation, doesn't give it direct empirical evidence that it is the case. So what you have to understand in this regards, and
Science
this
can
Jeff, Jeff,
Let me finish.
Jeff, no,
Science
I was
can be
talking,
wrong all
dude.
the
I was
time.
talking. Relax. I
They
was
find
talking.
different
Relax.
plausible
Bro,
explanations.
I
that
was
could
talking.
be
I'm not gonna
described.
allow you to talk if you're gonna continue to overtalk me, bro. I'm not.
Well, you
So
can't talk
basically,
non-stop and then
yeah,
expect
because
me
you're
to
interrupting me, dude. You're too excited. Like I told you,
You're not
relax.
finishing your sit. Your
Relax, Jeff.
your side.
Jeff. All right. So the fact that we're telling you from the cosmological aspect that the Earth is a flat and stationary plane, and I was just talking about the phenomena of the sun moving across the horizontal plane of reference, and then you started to talk about eclipses. You didn't let me finish telling you all the ways that you can understand the Earth is flat and stationary. You're jumping to how the explanation of the eclipses are happening then on the Earth that's a flat and stationary plane. And I told you in reference to that, it's unknown phenomena that nobody can describe in a way that we know exactly what causes the phenomena, the cause of the effect of an eclipse. And you jump to talking about how the Earth is a globe, and I said directly, how do you know that that's the case? And you said, well, I'm not God. I didn't ask if you were God. The only thing I wanted to know was that are you knowing empirically that that's the case for the Earth causing this syzygy? And you don't know that because it's only something that you're using as an inference. As an inference doesn't give you an indication that you know directly. It's not empirical, sir.
No one knows directly anything.
I know that's well. Herein lies the problem. You can assume that the Earth is anything that you want in this case, right? But if you don't know, you're not going to be able to tell them directly. However, right? However, people can make you believe anything that they want by inferring that this thing is happening based on an idea or a story that they've given you. And it's up to you whether you're going to use your critical thinking mind, whether that's the case or not. If you believe it because they told you, that's on you. It's not on anyone else. The only thing that people are going to be able to do is give you some information that you can look at, right? So if I tell you that it's unknown and you say they gave me an explanation, well, good for them. And if you believe it, that's even more so your problem, not ours. So what we're going to tell you, though, from a cosmological aspect, the Earth being a horizontal plane of reference, we're going to tell you that everything that you see in the sky is happening due to the fact that those things are moving, and there's no other reason why you should think that the Earth is the one in motion. So the Earth doesn't need to be moving for everything in the sky to be moving. The only thing that you see is that the objects that, well, I call them objects, but you can say that we wouldn't know that either. But those are moving. The lights in the sky are moving, and you are stationary. If you're going to say that you are moving in any way, you're going to have to directly tell us how you've seen the natural phenomenon of the Earth in motion. Directly.
That's not how science
What?
is conveyed. Nothing is worth.
So your idea of science probably is not science, because science has to deal with the inquiry of a cause and effect relationship. You want to know what's causing the effect of what you're seeing. In any case, sir, in any case, what's causing the effect? So when I ask you what's causing the effect, and you say, well, science doesn't deal with that. Science deals with just inferences. No, it doesn't. It deals with understanding the physical and natural world that you're looking at, sir. That's what science is, the understanding of the physical and natural world.
You're putting words in my mouth that I never said. I never said that.
You said that's how science works. It doesn't deal with empirical. It deals with just making inferences. No, it doesn't. It deals with cause and effect relationships.
Exactly, and then they come to conclusions
natural world.
of the most plausible explanation. That's exactly.
No, it's not a possible explanation, sir. It tells us how things happen because we're investigating with tangible evidence. We start learning why things happen.
Okay, so according to what you're saying, science can never be wrong.
No, you have an idea of what you think science is, and that's considered scientism. It's a religion. Scientism tells you information about ideas. Things happen a certain way because, dude,
Let me say
things happen a certain way because it's a believable story. We don't care about that. We want to know how it's happening directly. So if we're telling you, listen, if we're talking about science in a real physical way, that we're interacting with the things that they're like, whatever it is that you're discussing, it doesn't matter what it is. Whatever natural phenomena that you see happening, how can you directly know that that effect is being caused by the thing that they're saying it is? And if you can't answer that in a way that we can understand that the physical and natural world are being understood by us, the people, then there's no way that we're going to agree with you, that we're going to go along with your story of the Earth being a globe just because you believe it to be so.
You don't have to go along with anything I'm saying. I'm not trying to convince anyone. I'm not like a priest here.
Well, you're convincing yourself, sir. Jeff, you're convincing yourself.
I'm not convincing myself of anything. Let me finish.
Yes, you are.
My problem is what you're doing is you're drawing conclusions, right? You're not taking the evidence and then drawing conclusions. You're drawing a conclusion and then drawing your own evidence. You're saying, well, the Earth is flat. Let's start from that premise. And now, why we see objects in the sky casting a shadow on the moon, we don't know. You can't do that. You can't derive certain certain facts and then
What facts, sir? You haven't given me any.
Let me finish, and then try and cherry pick what's convenient to you according to science.
It's not convenient. According to science, you haven't given me any facts, sir. We're looking at the physical and natural world as for what it is. Now, when you say that it's something that it's not, the burden of proof rests on your shoulders. I'm telling you, the Earth is observed as a flat and stationary plane. It's measured as such. Hold on, Jeff. It's observed as a flat and stationary plane. It's navigated across as a flat and stationary plane, and it's measured as a flat and stationary plane. Now, the burden of proof begins on those who say that it's otherwise, because our observations don't. When you look upon the Earth, you don't see it. You don't see it as a globe, sir. Jeff, you don't see it as a globe. You don't observe it in any way as a globe. Now, if you tell me you observe the Earth as a globe, I need you to tell me how you've observed the Earth as a globe, Jeff.
Okay. Do you see me as a cluster of cells?
You're not answering my question.
I'm answering you with an answer. Do you see me as a cluster of cells?
I'm not going to answer your question until you answer mine.
Well, then you're not engaging in the argument.
You're not engaged in good faith, sir.
I'm allowed to ask you
where have you observed the Earth as a globe, Jeff?
Just have a conversation,
When
guys.
have you observed human beings as clusters of cells?
All glory, have a seat. When have you observed the Earth as a globe, Jeff?
I just answered your question. When did you observe human beings as clusters of cells?
You're not going to answer You're not the one that's a good faith interlocutor if you're not going to answer my question, Jeff.
I just did.
When have you observed the Earth as a globe? I'm going to keep asking until you give me the answer.
When have I observed the Earth as a globe? If you're asking me if I saw with my own eyes, did I fly the outer space and see it as a globe?
No, I didn't say all that. I didn't say all that. I just asked you a simple question. When have you observed the Earth as a globe?
When did you observe the Earth as a flat Earth?
Every day. When did you observe the Earth as a globe?
You see the whole Earth with your eyes?
When have you observed the Earth as a globe?
I never saw the Earth as a globe. Now I'm going to ask you a question. When did you see the Earth as a flat Earth?
Yes, every day.
Well, did you see the whole Earth in your eyes at the same time?
What I said. Yeah, flat Earth isn't a description of the entire Earth, sir.
So you don't know what the whole Earth looks like. You only know what it looks like in your narrow vision.
Narrow vision? No, sir. Everywhere humans are, the Earth is flat and stationary.
In the context of the scale that they're looking at, in small locations.
Yeah.
But if you're looking at
everywhere you travel, the Earth is flat and stationary. Doesn't matter where you go. The Earth is flat and stationary everywhere you go.
Yeah, well, it's flat and stationary on a globe as well if you're looking at scale, but you're not willing to understand.
How is it flat and stationary? That's a paradox. How is the Earth observed as flat? Listen, this is important. You just made a paradox. How is the Earth observed flat and stationary on a globe?
If the Earth is big enough and you're really, 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 really small, it will appear to you as if you're standing on a flat object, when in fact it's actually round.
Okay. How did the observation? So far, you're agreeing with me that the Earth looks as if it's flat and it feels like it's.
I never disagreed with that, but that doesn't mean that it's evidence for the flat Earth.
Right. All right. So listen.
We
So
see
now
things in our
we're on good.
perspective
We're on
in the
solid.
geodesic.
Listen, Jeff, we're on solid ground. We're on solid ground because now you and I made an agreement. We both agree that we observe the Earth, like I told you, as if it's a flat and stationary plane. We're on solid ground now. Now let's move to the next point. If we're gonna say that the Earth is something that it doesn't appear to be, right, from the place that we make in our observations, now we got to know how we got from making an observation and seeing the Earth that's flat and stationary to now then saying the logical leap of how it's a globe. How do we go from flat and stationary observations to knowing that the Earth is a globe? How did we get there?
I just told you it requires a lot of research throughout using methods of
Oh,
science, building blocks
okay.
of how things work and how phenomena works, and then you have to find you take all the evidence from what you see from
All right.
observation. If it's the stars, if it's the constellation of the stars, if it's the sun, if it's the moon, and you look at all of these parameters and you put them into and you factor them in to what gives you the most satisfying, compelling explanation to how things work, then you'd have to assume that it's a globe because I've yet
Oh,
to find.
all right. So
Yes,
let's get
if
to
you
this bit
provide
right here
me,
because
I'm not gonna argue with you. If you provide me with a substantiated, good, convincing, compelling reason to why you believe it's flat, I'll be a flat earther. Now,
yeah,
this instance, I'm willing
Jeff, I agree with you, man. But like, our job here is not to honestly, like, if you wake up tomorrow and you're not a flat earther, it's not going to bother any one of us. So what we're going to do is we're going to challenge you on your ideas of how you think that the Earth is a globe, right? Once you realize that the story, sir, let me just get to the point here, the crescendo. If you believe that the Earth is a globe just based on the information that they've given you, because that's the only thing that you've been told so far, I'm giving you another cosmological aspect, right? So based on observation, we can be both on firm footing that we observe the Earth as a flat and stationary plane. Now, when we're talking about geometry, that's something entirely different. So when they're telling you the information that you received is that you're standing on a geometric shape. Well, here's the most important part about that is that we know now in today, right, 2024, you can know how to measure things, right? So things that you can measure are you can use any type of measurement, right? We got units of measurement. We got different types of ways you can measure things: lasers, lidar. We got levels of all kinds, gyroscopes.
You say all this, but yet you can't provide me with a flat Earth map with actual scale, which I've
Yeah,
been
so
asking.
we know all of this so far, right? We can measure things. So if it's possible today that we could measure things, then we're going to use that method of measurement, any kind, pick one, right? And we're going to try to see if we can measure the Earth with the curvature drop rate, as it were, as a geometric shape. So if the Earth is dropping away from you, being that it's a geometric shape, right, an oblate spheroid, you're going to be able to measure the Earth. Now, how? I'm going to ask you the question. This is important. This is the most important question you can answer. How is it possible that anyone in history has ever measured the curvature of the Earth, Jeff? Anytime, as in the drop over the distance. Do you know what that means? If not, I can elaborate.
I understand what you mean.
Okay.
But,
How did they measure the drop over the distance, Jeff? Anytime in history, to know that you're standing on a curved surface.
Well, they conducted multiple experiments for this. And I'm not going to go into the whole thing because we already went over this when you were in the conversation. I don't want to start the whole thing in repetition and go over it
just
again.
Give me a
What
summary.
I did say was I was willing to look into the experiments that were done on this lake on your flat Earth Discord that people
No,
said.
no. And I'm not talking about that. What I mean is in academia, what has been presented to you as how anybody's measured the Earth's curved surface. I'm not talking about Lake Balaton or any of the other flat Earth laser tests. I'm not talking about those. What I mean to say is that how you've been convinced that the surface has been already measured. Now, I'm going to tell you that because when you type into Google, what is the radius of Earth? What is the circumference of Earth? You're going to get numeric values, right? Those numeric values give you a definite size of the Earth. So what I'm asking for is the numeric. And listen, I know that you probably may not know this, but public information right now on the internet tells us that the Earth is a certain size. So radius, that's a specific value. So type this in,
Why
Jeff.
do you
If you
trust
don't.
that information
Well,
if you don't trust the
just go with me. Just go with me for a second, okay? If you were to type in right now, what is the radius of Earth, in Google, What do you think the value would be? You can do it yourself right now, because I want you to actually walk the path if you're able to. Just type in what is the radius of Earth.
I understand this. I've done this calculation before, and
What is the radius of Earth, Jeff?
Again, I said before, I don't want to walk into these into this thing again. It's leading nowhere. Like
okay, do you know? Okay, so it's a simple question. Do you know the radius or not? It's public. You can
it's
actually
about
look it up.
6,000 and something kilometers. I'm not. I don't remember the exact measurement.
Okay, so it's important to note that if you're going to tell me that the Earth is of specific size, of dimensions, like an oblate spheroid, they've already told us what it is. Now, the information that you're receiving from the mainstream is telling you that the Earth is a specific size. So we know that now, right? It's public. We know that. It's got a definite size. We can apply that information to actually verifying if it is or not the case by measuring the surface. And what I'm going to do is give you a method by which you can do that. Remember, you told me that if there's some way that I can convince you, which I don't really want to do, it's not my job. I want you to actually challenge yourself. So I want you to think about how it's possible to measure the surface as if it's curving. Now, if there's any predicted amount of curvature, you're going to be able to find out if you go out into the field and test this for yourself. So the reason why I'm letting you walk the path is so that you can understand if you're going to measure over a specific amount of distance, and you can take a small sample set of the Earth. You can say, let me do at least 20 miles. See if I can find any predictable amount of curvature that should be there when I'm doing a long distance observation. So if we're doing, let's say, 20 miles, we're going to find out, is there any way to demarcate the distance of 20 miles? So if I'm going to say, I'm going to look over, like standing at a beach, looking over the horizon is going to be the limitation of my view. After the horizon, I can't see any farther. So that means that if something goes off into the distance to the horizon and then I can't see it anymore, that must mean that there's something happening at that point of horizon.
Yeah, of course. And it could be that it is actually the actual horizon, or it could be just interference of your eyesight or the air or whatever. It depends how clear the day is. Depending on that, how far you can see. It's not always because of the curvature of the Earth.
Well, see, you're at least in this aspect, you know a little bit about the extinction limit of the eye. So how far you can see is also dictated by the day, how it is, and so I mean you pretty much at least know that much. So I didn't have to go too far into to talk about it.
Not controversial.
Right. Well, it is in this arena. All right. So that's the reason why I had to lay the foundation for long distance observations.
You're saying globalists don't actually believe that interference of the air cannot obscure vision on a bright day or on a cloudy day?
No. They attribute everything to curvature. Everything.
I've yet to hear anybody on the Globers deny the fact that some days have better vision than others. But okay, continue.
Yeah, no, he's straight up lying. I've told him multiple times that refraction also plays into effect.
See, he says also, which means that it's still curvature. Also is attributing to the thing that it's actually
standing in relation to the curvature. That's what I'm saying. You could be looking very much over the horizon, but you actually could be thinking you're looking over the horizon, but your eyes are just confusing you because it depends on.
A confusion is happening. All right, so think about it like this: if there's no way to tell the distance to where the horizon is, because that would be the place where the boats are going behind and all kinds of stuff is happening behind the curvature of the Earth, then how, pray tell, can we know that the measurement has been done to solidify the size of the Earth if we can't tell? Because our eyes are being confused. See the problem here? The problem is we start to say that we can't know the distance to the horizon, which is a very difficult position to be in when you say that you know the definite size of the Earth. Here's the problem, guys.
So can I ask you something? So you're saying the only reason why we can't see you're saying that the only reason why we can't see to a certain distance is because the obscuration of like air particles or whatever due to the clarity of the atmosphere during a certain day, right? It has nothing to do with curve.
No, it has nothing to do with curve, but it also deals with the angular distance you have to the ground, so the elevation height, right? So we're saying that everything.
Yeah. Sorry.
Yeah. So So we're saying that everything coupled together with the ambient temperature of the air, the distortion, because there's air turbulence, which we both probably don't deny. You've agreed with me that you see things happening in the distance that could be a phenomena such as mirages, right? That natural phenomena that occurs is well established and understood by everybody. When it comes to these types of phenomena, right, that happen in the distance, like when you're seeing something in the far distance, you see natural phenomena like mirage happens. You know that's a phenomena that's occurring because the ambient temperature of the air, the hot and cold air are mixing and causing a turbulence in the air. And then there's phenomena that occur due to that fact. Inferior, superior mirages, it just depends. Towering, stooping, lowering, all these types of effects happen. They're visual phenomena.
Yeah. If we have really good binoculars or like a telescope, how far do you believe we can see then? If it's a flat Earth and we're standing on the same level, what's preventing me from looking from, let's say, Chicago to New York?
Right. So we're dealing with angular resolution. So the angle of view that we're seeing from the ground also depicts at the distance which we are going to see also. So as you increase your elevation
straight at an object like the Empire State Building, I should be able to see that from anywhere.
Jeff, no, I think that's a wrong think right there. The reason I'm saying that is because you know that angular distance also changes the view apparently of the thing that you're seeing. So let me put it in perspective to you. When you see a car drive away from you, right, or a person or anything else, the things that you're looking at, the objects appear to get smaller as they get farther in distance. Is this true or untrue, Jeff?
That's true.
Right. So basically, things appear to get smaller. Now, let's take it a step farther. If something gets,
why does the sun not appear to get smaller?
Hold on. We'll talk about that in a moment. Don't interject. All right. So if we're talking about things that appear to get smaller in the distance, what we're going to do is then increase that distance exponentially. Let's say that the car actually drives away for miles and miles, further as it gets smaller and smaller. What happens when it gets too small to see?
It's going to eventually disappear from our eyesight.
Right, but it's not. It didn't really disappear, right? Would you agree? Actually, it's not disappeared. It's just we can't resolve the image anymore.
Yeah, but what if you have a really good telescope, for example?
Right. We'll deal with that in a moment. Just with our eyesight, we can't see the car that moves away from us at an exponential rate. So once it's far enough, it's not resolvable with your eye. Would you agree or disagree?
I would agree.
Okay, so at least we're on firm footing with how our eyes work. Now let's talk about the telescope or the binoculars. Let's pull out some binoculars now. What do you think is going to happen when we can't see the car and now we pull out some binoculars?
Well, what you're saying is what I hear a lot of flat earthers say is that ships don't actually disappear over the horizon. If you bring out a telescope or a binoculars, you'll be able to pull them back in or whatever with a Nikon camera.
Yeah, well, no, we're not. It doesn't matter what optics, but what happens when you increase the resolution limit of the optic? You can see farther, right?
Distance. That's what I want to ask. How come you're not able
but
to take a telescope?
Listen, Jeff.
Wait, are you going to argue that the moon is closer than what?
Jeff, no, I haven't said any of the. I said nothing of the sort. The only thing I want you to think about right now is just what we're talking about, which means that you just focus, pun intended, on the thing that we're speaking of, because we're talking about optics and seeing farther in the distance. So now we just use some binoculars, and the car that we saw far away from us, where we couldn't see with our eyes, we're using binoculars now, or a telescope. It doesn't really matter. So now we can see the thing. Now we can see the thing that we couldn't see with our eyes. The binoculars or telescope brought it back into view. Would you agree or disagree with that?
I agree.
Okay, so now what we're going to talk about is the optical resolution limit of the optic itself. So at some point, do you think we're not going to be able to see the car with our binoculars? Or do you think that there's two things are going to happen here? Either you're going to continue to see the car with the binoculars, or the binoculars will have their own resolution limit where you couldn't see any farther with those optics. What do you think is going to happen? We could see either two things, Jeff. You could either see infinitely far with binoculars and you're going to keep seeing the car no matter the distance, or the optic that you're using is going to have a resolution limit in which you can't see the car any farther. Which one is it?
Well, then you'd have to this begs the question to how do we see objects that are way further than cities that are actually in proximity? Like, for instance, how do you use a telescope to see the moon, and you can actually see from so clearly in perfect
that's
vision?
a question. That's a question. You didn't answer mine. I gave you a dichotomy. I want you to think about it. With your binoculars, can you see infinitely far, or do the binoculars have a resolution limit, sir?
They probably have a resolution limit.
No, we can't go on a probable. We have to either know that they have a resolution limit or not.
Obviously, they have a resolution limit. Yes.
Okay. So now that we agree they have a resolution limit, that means that those binoculars or telescope are going to be able to resolve the image to a certain extent. After that extent, it's going to drop away from the optical view of the binoculars or telescope. Right?
Yes.
Okay. Now we're on a firm footing to know that everything has an optical limit, and we can't use any type of thing that we're going to say pulls something that's at a far distance back into view. Not only and just based on angular resolution, we're only using that because, of course, if we increase in elevation, we're going to be able to see a lot farther. But on the globe, if you're standing on a ball or you're standing on a flat plane, that's going to be the same for you anyways, right? It doesn't matter the thing that you think you're standing on. Going up in elevation, you'll still be able to see. It doesn't matter if the Earth is a ball in your mind or if you're standing on a flat plane. The idea.
Disagree. On a flat Earth, if you're standing at level and you're looking at an object that you see across that you do not see across the distance, right? And then you go further up, right? And then you won't be able to see the said thing that you didn't see before, right? Because you said it's optical resolution. If you can't see something at distance X, going further up in elevation won't help you see distance X, right?
Yeah, you actually could see farther. You could see farther.
We do know that on a globe model, there are some objects like the boat. If you're standing at sea level and you're looking at a boat sinking into horizon, if you go up the Empire State Building on that beach, you will be able to then see it with your own eyes. How do you explain that?
Jeff, you didn't let me respond. You just ran over my explanation of it's still possible on a globe or flat surface. Like if it's a curving surface or if the surface is a flat horizontal plane, you can see farther in both instances. There's nothing different about it. You're just the only thing that you're doing is increasing your elevation and you're seeing farther ahead.
Yeah, but I was saying on a flat Earth, increasing your elevation won't help you see the object, right? Because it's still at the same distance. If it disappeared from your eyes at level X, it will still be not in your vision at level Y.
That's untrue. That's untrue.
What do you mean it's untrue? If you go further up, you'll be willing to see further away. Is that what you're claiming?
Yeah. Yes.
What do you mean, yes?
You can see farther if you increase elevation, Jeff. That works. Listen, that works for both. I gave you the example. The dichotomy is you're thinking the Earth is a globe, right? So I'm telling you, as a curved surface or as a flat surface, you can see farther if you increase elevation. That's true in both cases.
1 second.
They've never been in a plane or something.
Well, something's happening. I don't know. Maybe Jeff has some background noise. What's up, One Deck?
I'm good, mate. You?
Yeah, good, man.
You're always good, mate.
Hey, you know what's funny while you're having this discussion? I'm on I highly recommend this website to every Glober here. It's called the Digital Coast Office for Coastal Management. It's a government agency who is doing LiDAR scans of the United States, of coastlines, of huge parts of the US inwards. And you can actually look with their 3D viewer, you can look at these huge LiDAR scans of miles of non-existing curvature. Have fun.
I apologize. I'm back. My kids just came back from school.
No, actually, Jeff, you should probably tend to your kids because you can be on here for days. Listen, we are not going anywhere, Jeff. Okay, we're gonna be here. So just do your thing. Come back in and have a conversation with us. It's been real nice talking to you. It's a little bit heated. I get it because of the arena. But
I apologize if it seemed heated at some moments. I'm really not here to argue and be in your face gotcha, get some clickbait moments. I'm really here for the sake of the conversation and the ideas.
Yeah, it's the nature of the conversation, bro. So it is.
Yeah.
You know what gets me though?
I will say though, I did enjoy the debate, and I definitely be back to listen to more because I
Yeah,
mean
we look forward to it. Yeah,
yeah.
have a great day, Jeff. You know.
Likewise, bro. Cheers. Thanks for
Cheers.
the discussion.
Later, bro.
I didn't hear any of that, but
What was
I
that?
mean, I'm saying like what gets me is that I mean, no, I didn't hear Jeff's people coming in for a conversation and not if they are coming in like that. Once they hear the the evidence and the facts that we can present them with, there should be no doubt in the mind that they don't live on a globe. Once they realise what we're putting to them, we should be able to realistically, you know, fucking is it 10, not I don't know, 7 out of 10 people you tell should be able to understand what you're saying and understand that they don't live on a globe. I mean, 10 out of 10 people should, but
Yeah,
it doesn't seem to happen like that, does it?
the position, and here's something I could probably agree with. The position that somebody's coming off listening to all their life that the Earth is a globe. It's the information is kind of ingrained in all of us, right? So it takes a lot of, I guess you could say, self perspective, right? You have to maybe take some time out to reconsider your thoughts and kind of work through things. So for some people, it takes a while to actually undo that. That information that they put in their head that is like in their minds it exists as true and it's only an assumption. And Jeff, at least to the point where he admitted all this is an assumption, has something for him to think about, whether it is or not the case that he's going to come back and say, like, you know what, you guys made some sense, or I made sense, or you're wrong, or whatever it is. That's not even what we're looking for here. We're only looking to challenge him on what he thinks. Now if he looks into it and finds out that it's not what he's been told, then good on him. But that's not the heart of our aim. We're not going to be going for that.
Yeah,
not here to convince people. That's what the globe is doing. We don't need to convince. We need just to show them that this isn't always the case and what you think it is. We got to consider too, man, like this, everybody's level of like what they've adopted as far as the Earth being a globe. For some it's a lot stronger than others, as we can see with the guys who come in here and just they're really clinging to the Earth as a globe. I don't know why, but to them it means something. So that's fine. They can
I
believe.
found that. Do you think? I mean, I don't know why that is. I was a glober, but I wasn't really emotionally attached to that globe. Whereas, even when I was a glober, if somebody would have mentioned flat Earth, I would have just had a chat with him and listened to it. I possibly could have laughed in the face or just laughed, but I wouldn't have got angry or really emotional about it. You know. So I don't know how these people are differing in that way. Some have got it stronger than others. I mean, the education system is probably more or less the same throughout the world, as in being taught we live on a globe and everything. So it's not. I can't see these different levels of intensity of the learning of that. Possibly could be to do with people who are heavily into science fiction, space programs and stuff like that. Maybe don't know.
Well, that's it, because they identify their worldview as something one of being like a part of the cosmos, and so they put themselves in a position where they see themselves as that. Hold on. Oh yeah, sorry about that, Darth. Let me unmute you. Go ahead, and if you have something to add, go ahead, Duncan.
Yeah, so you were saying, as objects go further away, they appear smaller, right?
Of course.
And because we have seasons, it's because the sun is further or closer away than us?
Well, it not because of seasons. It's every day the sun appears to come from the east and go to the west. So it's appearing to us across the sky.
I'm not talking about day and night. I'm talking about the seasons. And the reason.
The sun is also to deal with seasons as well. As it moves away from your proximity, depending on where you are from the north or the south, it's gonna cause the seasons. So the reason why you have temperature variances and the hot or cold from the season is going to happen because of the proximity of the sun is going to cause the weather patterns to be differently, depending on where you're at geographically. In respect,
yeah, right. So if I stay in the same location like New York, and it's spring right now, but in the winter the sun's further away than say compared to the summer, I would expect the sun to appear bigger to me during the summer than I would in the winter.
No, that's not necessarily the case.
If it's further away and objects get smaller as they go further away, why is that not the case?
Because light going through a medium causes the intensive magnification. So light magnifies through the medium, right? Or it.
So
it can,
so
listen,
hang on. All right, you stated one thing. Like, let's have a little back and forth.
You're not letting me tell you the rest. You're cutting me off, Duncan.
I know, because you just stated one thing, and I want to go back and forth.
You're not letting me finish. So how can I tell you the rest if you cut me off? You go ahead, cut me off, and then give me an explanation of what I told you.
Okay,
and you're gonna miss some information. Go ahead.
Right. So the medium is magnifying the light, which is why it appears closer or further away. Right. That's what you're saying.
No, didn't say that. You didn't let me finish. So go ahead and make up your own mind of what I was gonna say.
You said the sun doesn't change size when it's closer or further away because the medium magnifies it.
Yeah, that's part of it. But I was going to finish the rest, which you didn't let me. So go ahead and finish the conclusion.
All right, so then finish the rest.
Well, thank you. Maybe next time you'll understand. Do not cut me off. All right. So when we see the magnification happening, that's due to the fact that the temperature and the humidity in the air causes such that the magnification of the sun happens to the medium of air. Now, if we apply or use something like that decreases the intensity of the light, like a solar filter, we can start to see that it reduces that perspective of how the sun looks. The sun appearing to us, what it looks like in its luminance, has to deal with how we're using light refracting or diffracting through the air that we're seeing. And it causes magnification at some instances when we see the air, like the humidity, when it's real thick, the humidity, it causes a magnification with the sun looking like a different, size. Now, that's not to say that the sun actually it's in and of itself, perhaps it is changing in size, but we only see it optically, which is an apparent visualization of the sun. We don't see an actual, we can't go to the actual sun and say, I know the sun size in the sky visually. So I'll give you an example of what I'm saying. In some cases, in a dry climate, you'd see the sun as it moves away from east to west as going down to a tiny pinprick. And in some cases, in humidity where it's really humid, you see the sun looking like a giant orange ball in the sunset. So in different cases, the sun, the way it appears to look, is that it looks like it changes sizes, apparently. But in every case, we would say that the sun visually, or you use a solar filter, it would still change optically. So the sun that we see is always optically changing in size. So it's never the actual.
But you're talking about like a day-to-day thing, like sunrise, sunset thing. I'm not talking about that. I'm talking about a seasonal thing. So in the winter in New York, in the winter, the sun is further away from us, right? That's what your claim is?
No, it's not a claim.
Can I add something? I don't know if it makes any sense, but it just pops into my head. So and on a day basis, say sunrise, the angle of the sun is low, and as it moves overhead and closer, it's higher, and then lower as it moves away. It's the same with the yearly cycle. So the sun in winter, from what you're saying, would be lower. Yeah. In the
no,
sky.
That's not what I'm saying. That's not what I'm saying. So
No.
I'm not
saying that's what I'm saying. I'm not saying that. I'm saying that's what happens. So it's lower. It appears to be lower.
Yep.
The angle
Again, I'm just talking about the actual size of the sun, not whether it appears to be lower or this or that. I'm talking about the size of the sun. Alpha was saying as objects move further away from you, they shrink in size. They shrink in size.
No,
Physical objects, do you?
Yeah, listen,
like they appear. Okay, so, I'm sorry. They appear to shrink in size.
Yeah, physical objects. Yes.
Right. Okay. So if the sun is further away from me, it should appear to shrink in size. So it should be smaller in the sky, say at noon in winter in New York, than say it should be, say, noon in summer in New York. It should be a different size.
That's great.
But they're not. It's not.
A physical object.
We don't know what it is.
It's not.
Is it a physical object?
If it's not a physical object, then why are you talking about?
No. Is it a physical object? Yes or no?
Yes.
That's a claim. Now provide evidence how it's a physical object.
Oh my God.
You made
Can light come from a non-physical object?
You don't know what it is, do you?
Can light come from a non-physical object?
Answer the question.
Can light come from a non-physical object?
That's not my burden. It's yours. You have the burden of proof. Now provide evidence that it is a physical object.
All right, so you're just going to bail and run. It's all right. It's okay. You want to bail and run, that's fine.
I'm not bailing. I'm actually having you answer the question that you don't want to answer. How do you know it's a physical object? You made the claim. You said it is.
We have a problem here because it can be a parent object, and we don't know what it is. That you think you are seeing is as a parent view. Therefore, you can not give an answer.
Well, Duncan has an answer. He said it is an object.
All right. So, Alpha, when you said that the sun is further away from us in the winter, is it a physical object that you're talking about that's further away from us, or what is it? When you say it is further away from us, what are you talking about? What is it?
Duncan, we're hyper focused on you're explaining how it's a physical object now.
No. You said during the winter the sun is further away from us. You said in the winter the sun is further away from us.
It is.
So what? So okay. So is the sun a physical object?
It's not my burden. It's yours. You're gonna tell us that it's one, right?
When you say it is further away from us, what is it?
I didn't make a claim to the sun. You did.
But I can answer it.
If it's further away from us, it must be an object, or
I can answer
right?
it. Are you able to listen? It's a natural phenomenon. A natural phenomenon that is absolutely that you can calculate and you can see above you. That is absolutely going above you. And in the north, it's getting very, very small. Then it's getting a bigger circle and bigger circle. Then you get the angular momentum, and it's going slower, but have the same angular.
We don't actually
okay,
know.
So Johnny, when you say it is going slower, is it an object?
No,
it's going faster.
But we don't actually
it's going
know
faster and going slower inside the.
Johnny B. Here's what happened, dude.
The ring. That's what I'm saying.
Johnny B, he's shifting the burden of proof onto your shoulders. He didn't want to answer the question whether or not he can provide evidence that the sun is a physical object. So now he's trying to use you and tell you that if it's physical or not. So now he's got you on the burden of proof. But he doesn't want to answer the question. He doesn't want to answer the question. So he needs to.
No, he is not able to do it. He's not able to do it. But
he doesn't say that, sir. He's not saying that he's not able to do it or not. You're saying that he's not.
What makes me laugh, though, in this, I mean, all I'm saying, it makes me laugh because if you look at the globe model and how that explains it with the Earth spinning and tilting away, that is telling you that the sun is further away because the Earth is spinning back. But you don't have a problem with that.
Well, if it's a physical object, Duncan's going to have to provide evidence of that. We don't have the evidence, so then basically his theory about it being bigger or smaller can just go away in a puff of smoke. Until he's able to provide evidence that is physical, then we can't. He doesn't have his answer that he was looking for. Whether or not it's bigger or smaller,
I understood
know what it is.
What you were saying, Alpha. I understood what you were saying, Alpha.
As far as I know, light can't be reflected or come from non-physical objects unless you can prove me wrong.
Well, that's the part that you're going to have to detail how it's possible that it is physical. So tell us how.
Yeah, it can. If it's reflecting, then it's not coming from the physical location. Therefore, you're wrong.
Of course it is.
So
Of
if
course
it's
it
not
is.
from the, but it can reflect from other direction. That's absolutely known phenomenon. Therefore,
Everything
you
you
are wrong
see
about
is
that.
light bouncing off a physical object. Everything you see is light bouncing off a physical object.
Okay,
Yeah, it can be, but we have to understand, we have to know all the details then about it. And if you're talking about some specific things then that we can know of, then maybe you're talking about direction of a light is always going in a straight line. But if you're going from some long distance and so on, then we are talking about fractions from angle, and then we are not talking about the same thing. Then we are not talking about direction of light like that we are using in technology and so on and so on. So then
I
we
mean,
are
like
talking.
Johnny, the sun. You know, you've got the Tropic of Capricorn and the Tropic of Cancer. They're places, standard areas that the sun does go to them two places.
I lost that. I'm sorry for that. I didn't understand what you said.
The sun traverses through the Tropic of Cancer and the Tropic of Capricorn yearly.
Yeah,
Wait,
if that's happening, what's that? Tell me what that proves for you. What's your
I'm just
resolution for it?
Well, you know, sometimes it's in the Tropic of Cancer and sometimes it's in the Tropic of Capricorn.
Yeah, but I told you about, for example, the sun, the behavior.
But I mean, I think we've lost track of what the original conversation was.
This is the thing that happens when we don't hold somebody to the point. So Duncan has the burden of proof of telling us how the sun is an object.
Yeah, go on, Duncan. Tell us, please.
So if we move off of that, he's going to escape out the back door. So right now he has the burden of proof, which he hasn't resolved yet.
Yeah, I did hear him say the sun was physical. So how do you know that, Duncan?
Because we can see it.
Yeah, we have observation, and we have also measurement.
Just a minute, Johnny.
And then if you're living in the north, then you can see the sun go in a pattern. You can see what's happening. That's observation.
Johnny, just listen.
These are self-evident.
Johnny. Hello, Johnny.
Yeah, I'm listening.
So anything you can see is physical, is what you're saying, Duncan?
Okay. Now maybe we're not talking about.
Your name's not Duncan, Johnny.
We are talking about
Johnny. Johnny, your name's not Duncan.
Go on.
Yes. Name me one thing that you can see that's not an object.
Oh, you just stepped in
Rainbow.
it. Yeah, this is a good example.
Rainbow.
You're done. Sorry, Duncan.
Yes. You're looking at the light. When you see a rainbow, you're looking at the light.
Yeah.
Is a rainbow physical? Is a rainbow physical?
But the rainbow,
Johnny,
the rainbow
Johnny,
from a different
Johnny, you're not called Duncan.
location.
Your name isn't Duncan.
Direct the location. You cannot know where
You're seeing the light being refracted and how it interacts with the air particles. Yes, it's physical.
So can you go and touch a rainbow?
Can you not?
No.
Can you measure where?
Can you go touch the rainbow?
No,
what are you talking about?
Have you ever tried?
Oh
when
my
have you got
God,
into a rainbow?
Oh my God.
Oh my God.
So a rainbow's physical. You can go touch it.
Yeah.
Prove to me you can't.
It's just interaction with light with the particle.
What did it feel like?
It.
Hey, what did it feel like when you touched that rainbow?
I didn't say I touched it. I said what a rainbow is light refracting through the air, and what you're seeing is the air particles and how it interacts. That's what I said. It's air particles. So the same way I can touch air is the same way I can touch a rainbow.
Have you been over the rainbow, mate?
Touch the rainbow. Yeah, you're the man.
Yeah, but I can feel. I mean, like I can feel air passing between my fingers. You know, as I move my hand. But what did that rainbow feel like?
Yeah, what did it feel like, Duncan? What did rainbow feel like?
Feels like air. Feels like air.
How did you get there? How did you get to it, Duncan? What did you travel to get to it?
My point is, you're still seeing light.
No,
being
you
refracted.
said rainbows are physical.
And you're seeing the air
Another
particles.
reflected light in the water particles. That's all it is.
Yeah, but he said rainbows. Listen, Johnny, he said rainbows are physical, and you could actually, it's a physical thing. It's an object, right? Rainbows are a physical object.
So you can move them about.
What you're seeing is the light being refracted by air particles.
Yeah, but are rainbows physical?
You're seeing the physical air.
You're seeing the physical air? Well, that's another claim, isn't it?
No. Yeah, that's not the right term. We call that interaction over time. There's not nothing that is whole.
You're gonna wait, Johnny. You said you can see? You're making claim after claim. You're getting farther into the hole, aren't you, Duncan? Can you see physical?
You're going over the rainbow, Duncan.
Can you see physical air?
Can I see physical air? Yeah, the sky's blue.
The sky's blue. Is that air?
That's a color.
Is that air?
Right, due to refraction of the air particles.
Okay, so if you can see physical air, what does physical air feel like? Does it feel like a cat? Does it feel like
feels like wind? Feels like wind.
Okay, so a rainbow is physical, and you can go ahead and pet the rainbow, right? You can taste the rainbow. You can do anything.
The rainbow is a physical interaction between the light and the air particles that are in the sky.
So how is it a physical object?
Where does
You're seeing the air particles.
The Earth is the physical object in that case.
You're seeing the air particles.
Not the rainbow, then.
Rainbow is part of the air particles. Yes.
So how can have you ever touched an air particle?
The same way you see a blue sky.
Yeah.
It's the same way you see a rainbow. You're seeing the air.
You can't smell a rainbow. You can't taste a rainbow. You can't hear a rainbow. You cannot put your senses on a rainbow. The only thing you can see the rainbow. You can see it, but that's not a physical object.
What's physical? Tell us what physical is. Something that's physical. What's the definition?
Has mass. As well.
How much mass
does part of it? That's one part of it.
All right. Well, how much mass does a rainbow have? How much mass does a rainbow have? Go on.
Don't know. I never measured it.
Oh, then how do you know it has mass? Well, so looks like you got yourself in a pickle there, Duncan. Oopsie. That's okay, Duncan. I'll let you go. I won't hold you back anymore.
No, it's cool, man. You said the sun's not a physical object. I want you to back that up.
No, you said it was. You said it was. Now I need the evidence. How is the sun? Okay, we can go back to that one then. I'll let you go from the rainbow position, but we'll talk about how you're saying the sun's physical. How do you know it's a physical object?
Are you saying it's not physical?
I'm not saying anything. I want you to describe to me how it's physical.
That's very clear. I know you're not saying much. That's very clear.
Yeah, and you are. So now let's get to the bit where you're saying how it's physical. Let's go. How's it physical?
Prove me wrong.
No, you said it's physical. The claim is yours.
I'll tell you what. You know what? The sun appears physical the same way to you the earth appears flat. The same way the earth appears flat to you, the sun appears like an object to me. And you know what? It doesn't get smaller in the winter, and it doesn't get bigger in the summer. Yeah. It doesn't change size.
How do we know that the sun and the moon are solid objects, though? Like, how do we know that the sun and the moon are solid objects? We don't.
Oh, Jenna, he just conceded that he doesn't.
We've physically been to the moon. We planted plants.
Oh, relax. I will unmute you in just a moment, Duncan. I just want to explain to Jenna. He did concede that the sun appears to be physical. So that's his concession of saying that it's not physical now. So it appears to be.
He changed his claim, Alpha.
Yeah, he changed. All right, I'm gonna unleash him so that he can tell you how the sun and the moon are physical objects. Go ahead.
Mm-hmm.
So because something appears physical doesn't mean it necessarily is, and doesn't mean it's necessarily not. So because I say the sun appears physical, that doesn't mean I'm saying the sun is not physical.
It doesn't. You're not saying anything. You're not telling me if it is or not. You're just saying it appears that way. Well, good for you.
I said it is.
Oh, you're switching back to it is? Come on, Duncan. Is it physical or does it appear physical?
Just let us know which one.
I want you to settle the claim, Duncan. So that's all.
It can't be both of them. It can't be a physical but only appear physical. It either is physical or it's not.
Yeah. Choose one, Duncan. Well, think about it. Maybe you can come back and tell us.
An object can appear physical and also be physical at the same time.
Yeah,
but okay, but is a rainbow a solid object? No. It's light.
When you say solid, are you talking about like the state of matter, like solid, like liquid, solids, and gas?
Dude, why are you getting redundant, man? You know what she means. Come on, Duncan.
No, I don't know what she means, actually. That's why I'm asking for clarification.
A solid, man. I like it's solid. It's got mass. It's got density.
Straight,
you
so,
know.
hang on. Let me just get this straight, man. Duncan said something physical has got mass, but he's also saying something can appear to have mass but hasn't got mass.
What's the mass of a rainbow, Duncan?
That's what I asked him.
I've got a question. What heat producing thing doesn't originate from a physical object? Does anyone know?
No, tell us what it is.
No, because it doesn't exist. Could you demonstrate something that produces heat that isn't from a physical object?
Yeah,
or thing?
hey, Jekyll, I don't know why you're coming in with a different account. Job seeker. Hey, listen, dude. Like, we're asking him to provide the positive claim that it is physical. Can you do that, Jekyll?
Well, he brings up a very good point.
You could do that, right?
I want to let Jekyll take over. If anybody comes in and jumps in for White Knights for this guy, they're gonna take over the point.
Yeah.
Which is job now.
All right, I'm fine with that. Job seeker, you take over.
In the same vein,
you got it.
In the same. Is it Duncan or me?
No, we're now focused on you. It's your.
Okay.
You've taken over the burden of proof of providing the evidence that the sun is a physical object. Go.
I'm going to put it forward that nothing that produces heat, or nothing that heats things, originates from a non-physical thing, right? I can't, and that is based on every observation you and I could point to, unless you point out an exception.
Well, let me just get it straight before I forget. So, it comes from a physical thing or is physical?
Well, if the heat is coming from that object, then it's an object.
But we need to be clear what you're claiming. That you're saying that heat.
When you look at the sun, when you point your face at the sun, one deck. I'm sure you've been outside before. Point your face at. I'm explaining it to you, one deck. You point your face at the sun. You want to get a tan that day, and you can feel that when you face the sun, when you face it, it's exceptionally hotter. You can feel the heat from just facing the sun directly, and so you could strongly, infer that heat is coming from that thing, and that thing would have to be physical.
There you go. That's your answer. That's our answer, guys. It's an inference.
Well, an inference. All deductions are inferences, by the way. Just so you know.
But when we're deducing whether or not the thing that we're saying is an empirical, something that's tangible that we can work with it, the cause of an effect, we're going to be able to ascertain the information whether or not it is. So if you're saying that it is, if the claim is on the table right now that the sun is a physical object, that's a positive claim. Now we're going to have to figure out whether it is or not by being able to discover if it is. And inferences are going to get us there. We need to know whether the constituent parts of the thing that we're describing is indeed something that's... It exists in physical form. If it doesn't... If it doesn't exist in physical form, then we don't know that if it is or not. We're just using our best guess.
We could do some deduction, right? So when the sun's not there, it's colder. When the sun's there, it's warmer. When you face the sun, it's warmer. When you look away from the sun, it's colder. When you stand in the shade, out of the sun, it's colder. When you stand in front of the sun, it's warmer. We know that the sun is producing heat, heating up the world, right? Heating up our faces, our bodies, everything, right? So if that's the case, then by the rule of what I've just said, that all heat-producing things are physical, then the sun is physical. And that's just basic deduction.
So how do we prove if something's physical or not, then?
I've just deduced it for you on deck.
So if something's hot, it's physical.
Look, that is a stronger deduction, if not better, a better deduction than your gas pressure argument. So I don't know why you're
we're not
querying
talking about
it.
gas pressure. No,
It's a better deduction than your gas pressure argument one deck.
Can you not have a
couldn't do better.
conversation? Jekyll, stop getting on the defensive. It's a conversation. How does somebody prove if something's physical? In reality.
I've just done a deduction for you. I've taken observations, right? Taken evidence, observations in their everyday life, and I've made a deduction with them. Deduction. I've used an inference rule to get from what you've experienced in the world to the conclusion. You don't have to go and touch the sun to know that. You don't have to touch the sun to know that. In the same way, you don't have to touch the container to know it's there.
The rainbow doesn't put heat on your face. Is it physical?
The rainbow's just light.
So how do you know it's physical?
I mean, some might say light's physical. I mean, so what? What of it? What's that got to do with the heat of the sun? I'm not talking about light. I'm talking about the heat of the sun. The rainbow thing is someone else's problem.
Yeah, you're saying a light in the sky that gives heat is physical. Is the rainbow physical?
Well, does a rainbow heat you up? Do you look at the rainbow and feel warmer? Maybe inside you do. No. So what's that? How's that relevant?
You've just said a light in the sky that gives off heat.
Yeah, you missed it then one day. You weren't paying attention. Maybe if you weren't shouting my name while I was speaking, you would have understood the deduction, right? But you were just shouting my name in the background, weren't you? You didn't pay attention.
Yeah, so is a rainbow... You're saying the sun's physical, yeah?
So the sun is physical. I deduced that, yeah.
Right. And what now?
I don't know. It was Duncan's thing. I just wanted to make a deduction, that's all.
The rainbow, it doesn't give you heat, but it makes you feel warm inside. So, yeah.
Yeah, based.
That's what I'm taking away from this conversation. All right, anybody else?
The Earth scans flat. LiDAR 100% shows water always being flat. Earth is flat. There's no globe. It's a joke.
Well, that's not on topic, but okay, that's a different topic.
Was the answer to Jekyll's objection about rainbows not heating things up, which would be the rebuttal to the argument that everything you see, that when you see something, it still can be not physical. He made an extra requirement for that. He added the property that something has to be heating things up, and then based on that, you can infer that something is physical. But your response to that was an example of something that still doesn't hit things, so it would be a non sequitur to his argument.
So, yeah, you guys are. You can infer whatever you like, but if you get near a campfire, is fire itself physical?
Is a fire physical? Yeah, I'd say so.
Yeah. Okay, so it causes heat, doesn't it?
Yeah, it gives off heat, and you can touch the fire.
What state of matter is fire?
I don't know what term we'd use to describe a fire. Does anyone know?
Is it a solid?
Plasma?
Yeah.
I don't know. Is it plasma?
Well, I'll let you guys look it up. Go ahead, look it up.
Okay.
Either way, it's a physical thing, right?
Well, if it's a solid, because we're getting from a solid object here, well, which was Duncan.
I would say it's superheated gas. I would say it's superheated gas fire. It's in a gas state and it's superheated.
I just googled it and it's indeed plasma, so I was right.
Yeah.
Okay. Either way, it doesn't matter what state of matter it's in. I mean, like the song, you could say it's gas, plasma, liquid, solid. It's physical, right? Is the main thing, right?
Is it physical?
Yeah. Like, doesn't matter what state of matter it's in.
Well, what we see also doesn't always correlate to, like, correlation is not causation. So you don't know. We're using a best inference as to what we think it is, our best guess. That doesn't mean that it's something that you say that it is. Just because you say it's a best inference, that's not going to detail how you know something is true.
Yeah, if you commit to the idea that based on everything we know, every bit of matter that produces heat that you know of, you yourself would know that there's nothing out there that's non-physical that heats things up, as far as you can tell, right? Based on like just this basic, sort of what we're looking around and seeing on Earth. So, using sort of your own reasoning for like why you think the container exists, I think there's an even stronger case to be made that the sun is actually, in fact, physical. In fact, probably more so than the container.
Yeah, but we're not talking about the container at the moment. We're only hyper-focused on the fact that people are saying that something that is claimed to be something physical is not able to be obtained or as a tangible object that they can go and reach and discover whether or not it's the case. So being that that's the case, it lies within a realm that we can't actually know for sure what it is. So an inference is the best we got. But I would agree with you that if we're standing from a point of inferencing what we could say the sun is, we could deduce that it probably is something physical. But that much I can give you. I cannot say farther. Listen, hold on. Yeah. I cannot say farther than that if I know with a positive claim that affirming that it actually is something physical. That's the difference. I can tell you the truth. I can tell you the truth that I can infer that, yeah, I can agree with you. At the same hand, I can't tell you and affirm that it's an actual physical object. Now, can you affirm that it's physical? Because I can use inference just like you can and deduce the same thing you can. But I cannot know.
I'm going to put it forward to you that there's two options, right? Either you would say that it's basically a rule that heat comes from physical things based on everything you can see, everything that you've observed in the world, and there's not an exception to that based on what you've seen, right? Or you can, and that will be your certainty sort of claim if you want to stick to that one. Or you can say, well, okay, maybe there's a chance there's something in the universe or some force that's non-physical that can generate heat without matter, without physical matter. And then in that case, you would then say it would be beyond reasonable doubt that the sun is in fact physical, but you could leave some room for something we don't know about yet, right?
Yeah,
in which case, in both cases, you'd be silly to disagree, right? At that stage.
No, in one case, you're silly to agree that it is because of the fact that you're affirming the positive claim. So you can't affirm something that you don't know what it is. That's the issue. A positive claim would have to be understood as such. So you're going to say that if the sun is something physical and you know that it is, then you're going to have to tell me how it is. If you're saying that it's deduced that it is, that is not saying that you're affirming that it is. That's just saying the best information that we got so far is to say that it is. So for
I'm satisfied with my certainty claim. Fine. I'll say it certainly.
If you're satisfied, Jekyll, that doesn't mean that it actually is. So your satisfaction is regardless to the point that we're saying that the sun is a physical object. Now, if somebody's saying that it is, their burden of proof was going to rest on their shoulders to provide the positive claim evidence that it actually is a physical object. Now, you're saying that your deduction is being such that you're going to make the claim that it would be based on everything that you know now. But you don't know where the sun where the sun resides. Nobody knows that area where it is.
Yeah, so let me put it to you then. I'll ask you a question. I'll ask you a question so we're on the same page. Sure. Could you tell me what you think? Because there's that area which you're trying to say exists, the area for uncertainty. What would you say as an example of a falsifiable idea that is non-material, non-physical, that generates heat? What would it be? Any idea?
Yeah, that. I'm not going to leave it up to speculation. That's not up to me.
It doesn't exist. Yeah, but it would be silly, right? To even posit it.
Yeah, but the speculation shouldn't be on me to tell you what I'm thinking it could be. The only thing that I need to tell you is how it is something. If I'm making the claim that it's physical, then it's my burden to actually demonstrate to you that it is. So if I can't do that, I don't need to speculate on what it can't be or what it's not. I don't have to go into that realm. The only thing I got to tell you is how it's physical. And if I can't do that, then I'm failing to give you the information, which is what everybody in this room is failing to do right now.
Okay.
Simple. It really is.
I think I've demonstrated certainty, but I don't know. I don't know, like what the exception would be.
Would you say 100% that you know that the sun is physical? 100%.
I would put it 100%. Yeah.
Okay, so then now the demonstration is gonna be yours to
I'm
tell
gonna
us
be bold. I'm giving you the deduction. I need the exception now, right? I need the exception.
100% is absolutely certain. So now you're on the main stage once again.
Yeah, I've done it. I've done it.
Oh yeah, what atmosphere? What atmosphere is the sun in right now? Give us, describe to us the atmosphere.
I don't know if it matters.
Yeah, it does.
The Earth.
Why would it matter?
You know knowledge about the sun that nobody has. You have the secret knowledge. So now you're going to detail to
talking about whether or not a heating object can be immaterial and non-physical.
What atmosphere is it in, Jekyll?
Doesn't matter. We're talking about heating objects.
If it doesn't matter, you're failing to give us the positive claim result that we know where the sun is. And what?
Well, can you give me an idea of what you're talking about? Like why it would refute the idea that a heating object has to be material and physical?
It's not refuting. This is your inference. You're not going to use an inference. You're not going to use an inference to refute that the positive claim is that it's physical. You're going to have to detail how you know where the sun is and how you know it's physical.
I don't know if I have to do that. I don't know if that's part of the claim.
Yeah, it's 100% knowledge on your part. So now it's 100% going to have to be described how it's detailed to us that it's a physical object. If the burden of proof is,
I know where the location is, then that would be fair. But I don't think I'm asking. I'm not even talking about how far away it is or where it's located.
You could recant from saying it's 100% knowledge because I will relent if you say that it's only 99%.
Well, I'm not talking about where it is. So why would I have to recant that?
You have secret knowledge that it's 100% true that it's a physical object. So now you're going to have to
physical
how it is.
I don't think it's secret either. I think everyone in this room knows that, right? I just think we're playing fool's game.
Do you think anybody else is going to detail to us the atmosphere the sun's in right now to know that it's a physical object? Because we're going to now discover secret knowledge that nobody knows.
Well, what does this atmosphere thing have to do with anything?
Because it exists in an environment that you know what environment it is so that it can be a physical object. If it's a physical object that's giving off heat, we're going to know the environment that it's in, right?
No.
Yes or no? So we don't know so now we don't know 100% sure it's a physical object without knowing the environment that it's in. We're missing information, aren't we? Well, we're missing information. Because if the sun is a ball of burning gas, then we're going to know that the environment that it's in is such that it's
something else. We're not talking about what it's made up of, what its constituent parts are, where it is, what it's in, where it's around, what it exists around. We're talking about one thing: is it material and physical?
Yeah. Is it material?
Guys, I'm not. I'm only.
Listen, if it is,
I'm only. I'm a bit lost. I'm a bit lost.
Yeah. If it is physical and material, we're going to know what environment it actually exists in, because now we know that it's a physical object in free space. So if that's true, then we know.
I don't care if it's in free space or in an atmosphere or whatever.
I'm trying to. Guys,
of the people, one deck.
I'm just trying to follow a little bit.
Hold on, bro.
Yeah.
Hold on. So the physical.
Keep up that go.
Yeah, but you're cutting in and out. It's like we can't understand you.
Sorry.
All right, so
sorry.
The physical object that exists in free space, we don't need to be bothered by what atmosphere it's in. We don't need to be bothered by what the constituent parts are made of the physical object. We just need to know that heat is being caused on our bodies, and then therefore saying that it's a physical object.
I think the only way you're going to be able to enter some sort of realm of uncertainty is if you posited an idea, right? And I'll posit the idea for you. That when the sun comes up every morning, and as it goes across the sky, and it always does this every day, there's something
because it's moving.
There's something there that just happens to follow the sun perfectly every day, and its trajectory every day, and it only follows the sun, and it just follows this perfect image of a projected object, and that thing is material. But in which case, it doesn't matter because we've still got the material heat-producing object.
Okay, how do you know that? Is it an
And all
inference?
of them
That would be the best I could do is positing an idea for why what I've said is wrong.
Well, we
I
don't need
don't even
best
know if that would even work.
Yeah, but we don't need best ideas or some half-hearted attempt at
But
describing
I'm
how
doing
something.
I'm doing it for you, right? Not for me. I'm doing like what you could
Right.
say. I don't know like what else you could really come up with.
Well, that's the thing, though. We are trying to figure this out together. And if somebody makes, or at least affirms, that the claim that the Earth is, or excuse me, that the sun is a positive physical object, then we're going to have to know and detail how it is. So if nobody can give us that, then we're all in the same area. We're all making inferences. We're all making assumptions. We're all saying that the sun is something that we don't know if it is or not. We're all in the same boat.
Then,
so
how do you know how do you know the container is there if you've never physically seen it?
We're not going to go to your little diversion there. We're going to stick to this topic. So we're going to find out if the sun is physical 100% or not. And if you can't give that to us, then it's just an inference, and you can only say, just like everybody else can, that I think that it's something that it could be physical.
Well, since I've given the deduction, I kind of need that exception to where it might be something else. That confounding variable.
Yeah. As in, do you know the atmosphere that it resides in? And if you don't, then how do you know it's not something that you can't describe in physical form?
Could you articulate why the space it's within has anything to do with whether or not the sun is material or physical?
Because you'd be able to detail that it's a physical thing that exists as an element that you can describe here on Earth. So if heat producing things here on Earth, like as you said, that you're using as an inference, can produce heat, and you say that they're physical, then how do you know that thing exists in an atmosphere that can produce something like heat that exists here on Earth, right? Then that's what I'm saying. If it exists in an environment that you can tell me resembles this one, then that information, that secret knowledge that you have, will then detail to us how we know that that can exist in an environment such as the one we have here on Earth.
Yeah, I think I get what you're saying, but the issue is that it's not taking away from my deduction; it's just going to add to it. So if I know what the environment is, I'll be able to add to my deduction, right? But not knowing what it is doesn't stop my deduction from holding, right?
Yeah, you haven't provided that the claim would then hold that it stands to reason that it is something like we experience here on Earth. So then it would be something outside of that, which means because you don't have that knowledge, then it doesn't support the claim that it is something that you think it is physical. Simple. But here's the thing, though. When you do come up with the information, or you're able to support that case, then you're going to detail to us how it's possible that that thing that you claim is physical exists in an environment that is exactly how you detailed it. And then we're going to figure out how you know that information. So everything is a logical step, closer to saying that you're affirming the positive claim that it's physical.
Even if I granted you, which I don't think I have to, but let's say I grant you that there's that realm of something, the unknown, or whatever. At that stage, I'm going to just say that to disagree, you'd have to be unreasonable, right? It's so certain, so sure that like this is the case. That even that fraction of a chance that it isn't, to latch onto the fraction would be an unreasonable thing to do.
Yeah, but we don't say that things are in the realm of the unknown to be 100%. Nobody can say that. I think you've made the positive claim of saying that 100% it is. Without having
I think so. I think so. Yeah, I think 100%. I don't know about you guys, but I do.
In your mind, your 100% exists in a realm of uncertainty. So I don't know how that's 100%. To be honest,
I don't think that's the case.
Well, that's the way you feel. That doesn't. It doesn't matter.
I know all of married men are bachelors. I know all of them are.
Yeah.
I don't need any doubt for that.
That's a different subject.
So,
yeah.
Am I all right now? Yeah, just for 2 seconds.
Yeah, we're actually good because we're not going to take somebody's certainty in their mind.
Just to put it into short term. But, yeah. What Jekyll's sort of saying is like the sun is physical because it can feel the heat using his senses. Yeah? In the physical world that we live in.
I'm saying one deck.
Heat isn't a
tell me one deck that produces heat, right? Something that gives off heat that is not physical. One thing.
In the physical world.
In the world here
world.
on Earth, on the ground here on Earth, one thing.
Here on Earth.
In the physical world.
That's the
I'm
world.
using what we like to call the container rhetoric, right?
Yeah,
On
no,
Earth,
this is
what
physical.
thing produces heat that isn't physical?
Yeah,
One
this is
deck.
only talking about here on Earth, not what's outside.
I
Somewhere
need
you
to clip
not
this
outside.
because this is going to be used for the container, right? When we get to that problem later on down the line.
We will. But at this point
Holy
right now,
shit, all of the responses to Jekyll's argument in that case could be literally used to obliterate the container. You're literally digging your own grave right now, because later we will be using these arguments and these quotes against you. Are you aware of that?
yeah, you could try, but like it still doesn't stand to reason that the gas laws remain. So you're gonna have to defeat gas laws before you get to that point. PV equals nRT. We'll talk about that later. Well, that's a separate discussion. But we're gonna get to this right now as how you know, or positive claim, that something on Earth is exactly like something is a place that you've never been to, you've never experienced, you've never gone there, and yet you want to tell us how that thing that's in a place you've never been to is exactly what you're saying it is like here on Earth. Good job, fellas. What else can you tell us that?
Perfect. I would use that rhetoric some other time, but today I'm going to use the rhetoric of, look, there's the only thing I know is what I can see and do here on Earth, right? And what I can see and do and test here on Earth is know that anything that produces heat comes from something physical, some object or matter, right?
What about
and
the
because
sun
of
then?
that,
What
and
about the
because
sun?
of that, the sun, given that it, when all the reasons for why we know that the sun is the thing that's creating heat, will also be made of matter or be physical, right? And one deck, if you disagree with that, then you will have to throw away your container.
So the sun is on physical Earth, then, is what you're saying?
Is the container on physical Earth?
I'm not talking about a container. We're talking about the
What
sun.
is that? Oh, see, now we're slippery, slidey all over the place. No, I'm going off
I
what
didn't
I
mention
know.
container.
What I know, one deck
Is
is that anything that produces heat comes from something physical.
Is the sun on physical Earth?
No, it's not on the ground.
Where is it?
Doesn't matter. It's relevant to me.
So you can't.
Or
You
it
don't,
is.
you don't know anything about. You don't know where it is.
Or anywhere.
So you're making claims about it, but you don't know anything about it.
Oh, yeah, but I do know it's physical, right? That's what I'm saying. I know, right?
No. You know
one deck, you're
things
struggling.
on
You're struggling. One deck. Come on,
No,
give me something. Just tell me one thing that produces heat that isn't material or physical.
Yeah, on physics.
One.
Are you talking about on the physical Earth?
What would it be? One deck.
Well, you're saying the sun's physical. Where is it?
All right, I'll take that as a concession.
You take it as however you want. Where's the sun?
I don't think it matters.
Yeah,
Is
what
it
I
on
would
physical
ask
Earth?
is,
Yes or no?
what I would
Illustrate to
ask
me
is,
why
in
or
what
how.
way is the position of the sun relevant to the argument about it being physical? What's the correlation between these two
all right,
variables?
Embo, do you want to take the challenge
the
now?
second one.
The burden's going to be on your shoulders now, Embo. It shifted off to Jekyll's. Now it's on your. Now it's on you. Do you want to hold to the positive claim that you know that the sun's physical?
I can do that. Yeah, I can do that.
All right, you're next.
If Jekyll
Go ahead, one deck.
doesn't
One
want
deck.
to argue
One deck.
anymore.
Embo's saying the positive claim now is the sun's physical. Now it's his turn.
Okay, so from my point of view, I would use the same logical argument as Jekyll, which would be the deduction based on the every other example that we can observe. But additionally, besides this emitting heat, I would also add other types of deduction, and combining them together, that would give even greater certainty that the sun is a physical object, because you combine all of these properties that the sun has that we observe only in the physical objects on the Earth. And the more you add, the more certain you are. So the second property I would add is the fact that the sun obstructs the view of other things behind it. So, for example, when you're watching a solar eclipse, you see the moon getting in the way of the sun and obstructing it. There's also phenomenon.
Yeah, we're not talking about that. So, Embo, stay on top.
I want to do.
Eclipses aren't telling us anything. They're not telling us anything about the sun's physicality.
That's a claim. That's a claim.
Yeah, we're not worried, Embo. We're not concerned with the eclipses. We're concerned of how you're going to tell to us how the sun is a physical object. That's the only
I
thing we're
just
worried
did
about right
using
now.
the eclipses. You just dismissed
The
the argument
eclipses
without any basis.
is a natural phenomena that occurs that we're looking at something and an observation.
Yeah.
We don't know that something physical is interacting with something else physical. We only see something happening.
Yes, you see
Where is the
the sun getting
Where is
obstructed by the moon. So my argument
Where
would
are
be the fact that the only way we can achieve the same effect on the Earth is by obstructing one physical object with another.
Real.
That's the way I would connect this example
It
of
doesn't
the
matter how
eclipse
real you
to
think
my
it is.
argument.
He's
You.
not dispelling the fact that he knows that the sun's a physical object. He's just giving us another inference. That's it.
Hold
It's
on.
another.
Can I just jump
what's
in
the
very
problem?
quickly with one comment
Inference
before you
is one
carry
of the
on? And I
logical
won't,
ways
go ahead,
in order to
I won't be on it. I won't be on it for long.
Yeah,
I'm
go
just
ahead.
jumping in with this one point. So, in order to die on this hill that you believe the sun is physical, however fair or unfair that assumption is, you've adopted the logic of, and Jekyll said it, I can only know what I can see and experience. So he's then conceding that he doesn't know that the Earth is a globe and that he only knows that the Earth is flat and motionless. And for Embo to again adopt the position of, well, we can only go with what we can observe and experience and test, then same issue again, you agree. You don't know that the Earth is a ball, you only know it's flat and motionless. And to link it to the container argument, yeah, if you can only demonstrate that gas pressure requires a container and can't exist next to a vacuum, then you're also agreeing our point. So in your effort
So
to take
sorry,
this
go on.
logical position, you're conceding the globe.
Wrong.
In
So
replacement for claiming
there's a
that
few
the sun is
assumptions.
physical, you
Yes, there are
sacrificed your knowledge
assumptions
of the globe.
There are the
There's a few
assumptions that you
assumptions in
just
there.
make that we could list. So firstly, in order to correlate that argument with the Earth being flat to these examples I just gave, the Earth would have to express properties of a flat surface.
Yeah, because
Then,
Jekyll
by
said he can
comparing...
only know what he experiences and observes, which would be a flat, motionless Earth. So that's all he can know. So all Jekyll can
That's an
know
assumption you've made.
is
I don't know if I
all
experienced that.
Jekyll can know is the horizontal horizon and the motionless surface that he lives on. That's all he can know.
There's
And that's
many
not a
other
globe.
observations I know that
These
would
are just the
not be
claims.
flat Earth, right?
Right,
So
right.
it's
But you're just
so
going by
it's
what you experience to know.
yes, what the world
And what
presents
you
itself is
experience
not
is the
flat,
horizontal
right?
horizon, motionless
Yeah.
surface. Yeah.
So there's a few things. The first thing I want to just take two different assumptions you made. The first one was, does the world present itself flat and motionless? I want to say no. And the second thing is the gas pressure argument. The gas
Another
pressure
Discord
argument.
glober.
The funny thing about the gas pressure argument, the container argument, is it's not meant to be a gotcha to me. It's the idea that you're the
But
one
yeah,
who
but it
will
is a
put that
gotcha to
argument
you.
forward. But when it comes to the sun, which is a very relatable matter, you're going to
You
use
just
our
gotcha
argument against the
yourselves.
container against the sun, and not just that, but also there's more information we have about the gas pressure argument that we don't have with the sun in your favor
Yeah,
to make the
yeah.
gas pressure argument.
We can
is still
manipulate and play with air pressure on the Earth. You cannot manipulate, test, or play with the sun on the Earth. So they're different things anyway. But you're correct that you finally adopted the logic of I'm going to actually go with what I can experience in reality as the basis of my argument. But sadly, in exchange for you thinking you have knowledge of the physicality of the sun, you've then abandoned the globe and gas pressure without a container.
Well, again, like you said,
Good point.
like I said,
Good point,
assumptions are
Cyclops.
unfounded based on what I just said. I don't think the world presents itself that way, and the gas pressure argument is debunked.
Well, the globe
based
side
on the
says that it
principle
presents
of
itself
going
that
up
way,
in
but I
altitude.
understand the
Which we can
Discord
do. We can go
globies
up in altitude.
have a different. I mean, the Discord globies, they're not even globies because the globies say you don't see curve because it's too big. But the Discord globie says, no, I can see the curve.
This is a very
Anyway,
smooth
I
way
wasn't
of
gonna,
getting
I
away
wasn't
from
gonna
the
get back
physical
into
sun
the long
argument.
thing. I'll let you guys pick it up. But I was just pointing out that, yeah, by that logic, you only know that the Earth is flat.
Yeah, cheers,
Well,
Cyclone.
But that was a nice attempt to try and get away from the hill, the dying hill of the sun's not physical.
I I don't know. One deck. I think we're solid over here, man.
Cyclone. Cyclone. Jekyll doesn't observe a horizontal horizon, do you, Jekyll?
Look, talk about horizontal horizons. When I put up a photo frame, I can't tell if it's horizontal. I don't know about you with your horizontal horizons.
Let's get Elder Bear in here to clarify. Oh shit!
I think it would be useful to define the terms you're going to use in the first place, because we can disagree on them.
From what we can gather,
we can use different meanings for the same word. So what I would do right now is to define horizontal before you want to try to argue about that.
To put it in simple, Jekyll Bear. What we can gather is we can test things down here in physical reality and know what things are, but we can only presume things that aren't on the physical earth. We can't actually prove anything about that, the sun or the moon or the stars, because we're not able to get there.
I'll put something forward to you one day.
It's all presumptions.
I can't touch a horizon. I can't measure a horizon. I can only just look at it and eyeball it and say what it roughly looks like, right? It roughly looks horizontal. I wouldn't actually know because I can't put a ruler to it and I can't tell if a photo frame's horizontal. And at least with my idea, I'm using it more than one sense. The feeling of heat, what I've observed about heat, what it looks like, how it moves. Very interesting stuff that you can look at with the sun.
It's not physical.
You can't do with a horizontal horizon.
Heat isn't physical. Heat isn't physical.
It's a property of something that would be physical, giving off heat.
In the physical world, yes.
Yes. Is that a concession?
Where's the sun?
You think it's outside of physical reality?
Where's the sun? I don't know where it is or what it is.
It doesn't matter if it is or not, because regardless,
you're claiming something about it. What is it?
All the reasons for why you know the sun's giving off heat were presented about 15 or 20 minutes ago.
I love how people ask questions to answers they themselves not only don't know the answer to.
Quiet, you.
Oh my god, that guy's insane.
Yeah, I'll let him talk. He needs to come in with I don't know. He's not coming in the right way. We don't need to hear sidebar chirps. Just
put him on the hot seat. Put him on the hot seat.
I don't know. We don't want to hear a concave earther right now. That's the wrong way to go. He doesn't answer any questions. He actually drops off the call. He'll leave the call before he answers anything. I don't want this. I don't know. Not unless you want to hear it. Like an hell. Let me see. Go ahead, All Glory.
So, can we just say
one deck? Yeah.
Have we got an outcome to the sun situation? Have we got an outcome to this conversation about the sun? What's the outcome?
There's nothing new I can say to you. So if you haven't picked up what I've put down so far, I don't think you're going to.
Well, you've spoke a lot about what happens in the physical world.
Yeah, I thought they were gonna pick up on saying that the rainbows are physical, like the other guy, Duncan Darth.
Yeah, I mean, I don't know what did he mean by the rainbows are physical.
Well, maybe he can explain.
Because the definition of the word physical itself is also pretty vague and can mean multiple things. And depending on the definition, the rainbow could be physical or not.
Light is physical, right? So.
Oh, okay. So are rainbows physical?
Yes, if you want to consider physical every single phenomenon that has some interaction with the matter and energy, then rainbow indeed could be physical.
So how can you interact with the rainbow? Can you go to a rainbow and hold it?
Water interacts with the light.
You don't interacting with the rainbow. The water is. It's creating.
So you don't interact with the rainbow. Nice concession.
No.
Thank you for saying you don't interact with the rainbow. That's the question we're asking.
Technically, be physical in that sense, right? The water interacting with the light, right?
Oh, everybody now saying that rainbows are physical, huh?
Well,
we got everybody saying
How do you create a rainbow without water and light?
Well, I need to know how you can go and can you tell me
anything that
how
bends like
heavy?
glass. You can use glass,
All right,
obviously.
all right. Tell me how heavy the color yellow is or purple when you see a rainbow.
I didn't
Tell me how
say
heavy that is.
okay, I think there's a confusion here. He said it was mass, right? I don't think being physical just means mass, right? I think
so. It doesn't have mass.
I think
Rainbows
you
don't
can
have
create
mass.
a rainbow when you create a rainbow here on Earth. You need light, and you need some matter that can split light into its
Jackal,
different.
Do rainbows have mass?
The rainbows have mass. I mean, the water will have mass. So
You just said rainbows don't have a mass. You said that.
Well, I said no. I said the idea that the
Yeah, you
definition
did.
of physical is having mass would be
Yeah,
silly.
and do rainbows have mass?
I mean, the water has mass.
So then rainbows have
If you
mass.
want to, well, if you want to say the
No
rainbow
is the answer. No is the answer. No. No. Just say no.
I'm gonna stop. I'm gonna stop. Jackal. You're off the
if you want
You're
to
off the
say a rainbow is just water,
You're fine.
then in that sense, it's just the water that makes up a rainbow.
We're good. We're good. All right.
If the rainbow was water, it'd be called water.
Yeah. No. We'll go to a different point. We don't. Geeks,
When
is a rainbow
alpha-
physical?
Sorry.
Depends.
Is a rainbow physical?
What's your definition of physical?
Physical. Yeah, physical. What do you mean?
Is a
You need a
rainbow?
definition
Is
of a
a
word
hold
in the
on?
first place
Oh,
in order to compare things to it.
All right,
MBO, hang on, MBO. Let me answer this guy.
Yeah, let him answer.
What do you mean physical? I don't know what physical. You mean does it exist? It does exist. Does a rainbow
Is it
exist? Yeah, it
physical?
does exist.
I'm answering my question. Is a rainbow physical?
I don't know what physical means. I don't know what physical means, brother.
We're at a loss then. So maybe
are you not gonna clarify? Is that it?
No, because do you know what when we speak? Do you know what words mean? Hello?
Oh, I thought that was a good question, brother. I thought that was a great question. Actually, there's a rainbow. Talking about rainbows.
I know, but at the same time, I know that the same word can have multiple meanings depending on the context. So in that case,
no, it's not. No, it's not physical. No, alpha is not physical. No, it's not physical.
Thank you. All right. So now let's
It's
see.
related to things perceived as opposed to the mind, tangible or concrete to the physical world.
Yeah, we want to ask people in this call. See, here's the thing, man.
Was that it? AB, was that it?
Oh no, I mean the conversation actually was a little bit farther than that. We were talking about.
Keep going. Keep going. Give me the question.
Well, yeah, I'm about to tell you. We were talking about the sun, whether the sun's physical or not.
The sun is physical.
And how? Say again.
The sun is physical. Yes.
Okay, now that's a positive claim. So go ahead and tell us how the sun. So go ahead and tell us how the sun's physical.
It has mass.
How do you know?
I don't.
Then you don't know if the sun's physical. Thank you, sir.
No, I do know.
No, you just said I don't know.
No, I said I don't. You said
what? What?
How do you know that? How can you prove? Right? You want me to prove it?
Yeah.
I can't prove it. I can't
there you
prove
go.
it.
Then you don't know.
But
thank you.
No. There's a difference between knowing something and being able to prove it. Would you not agree, AV?
Well, how can you? Okay, that's weird. How can you prove something that you know if you don't know?
If you know something, that's different to if you can prove it. Wouldn't you say that's correct?
No, because if you say you have knowledge, you have experience with the thing, sir. If you don't have experience with it, how can you know something that you haven't had experience? You haven't had experience with the thing that you're claiming has physicality.
With the sun, I have had experience with the sun.
Okay. Then tell me what environment the sun's in right now.
Environment. No environment.
No environment.
Do you know what that means?
Tell me.
Environment is something we have on Earth. The sun is not on Earth. Therefore,
where's the sun? Where's the sun?
Where's the sun? Outside of Earth.
How far?
Not sure.
Okay. You're not really sure about anything, are you?
I answered all the other questions. How far do you think it is?
You answered correctly. I don't know, which is the thing that we need to hear.
No, I said not sure. How far do you think it is?
I don't need to tell you a speculation. It's not my claim. So the claim was.
Would you say you don't know as well?
Of course, the sun right now exists. The sun exists right now. I know the sun exists right now in a realm where we can't know where it is or what it is.
A realm.
Yeah,
I didn't say realm.
I did. I'm saying that the
I know you did.
I'm saying that the place where the sun is, you don't know the environment it exists in right now, and you don't know what.
No, I do. I said no environment.
I know. Then tell me what that means. What does no environment mean?
Outside of Earth.
Okay, how do you know that?
Hey, isn't that the guy that didn't want to debate flat Earth on a flat Earth server?
That's probably him, Jenna. Did you have an? Anyway,
we were interrupted.
So back to the place where I'm telling you where this all originated from.
What was this whole rainbows thing? I like those questions. Can't you give me those questions?
It's the same thing, right? So if we're saying that we're seeing light emitted from some, how do we know it has physicality? If in the case of the rainbow, people are saying that the rainbow is physical, then what is the evidence?
No, it's not. It's not physical. No.
I know that, but we see something, right? We see a phenomena occurring, and then we give it physical form. How does it have physical form just by observing it? Well, it doesn't. In the case of the rainbow, we see something. It's a phenomenon, right? But that's the thing that we're saying is that if you're making the positive claim that it is physical, then you're going to have to give us how it actually is, and then we're going to go down.
I'm not making that claim. So deal with me.
Listen, it wasn't your claim. It was Duncan Dart's claim. All right, so we asked him.
Wrong. He's wrong. So.
He hasn't yielded yet, but that's what his claim was.
Well, he's muted, so we can't even yield. But give me more questions about the rainbows. I like.
Hang on, let me unmute him so you can hear his wisdom.
Yeah, so the water particles that are refracting the light are the physical thing that we see in the rainbow.
Okay, but we're talking about the rainbow. We're not talking about water particles, are we?
Did you not hear what I said?
Yeah, but we're not talking about that. All right,
so what did I say?
Water particles.
That's it?
Yeah.
That's it, yeah.
Can you repeat the full sentence I said?
Can you weigh the color yellow or purple?
Can you repeat the full sentence that I said? I just want to know if you're able.
Yeah, our rainbow's physical.
Can you repeat the full sentence I just said?
Yeah, you said water molecules or particles. They're the thing that make up the rainbow, right? That's what you said.
And that's the physical thing that we see.
Okay, we see a rainbow, the colors of a rainbow, don't we?
Yes.
Okay, how does color have weight?
Again, what we're seeing is
that's almost poetic. That's poetic.
Listen, how heavy is the color
that
purple?
are refracting the light. So yes, water particles have.
How heavy is the color purple?
Water particles have weight.
All right, how heavy is the color green?
Again, water particles have weight.
Yeah, we're not seeing that. We're seeing color. We're seeing color. 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 We're seeing color. Does color have weight?
Wait, what are we seeing?
Color.
Oh, yeah. Okay. Sorry, I didn't hear you.
Does color have weight? Oh, silence. Thank you.
That should be, that's like almost poetic. Yeah.
That'll be all.
How, what does the color purple weigh? My heart beats threepence until the mass of the rainbow descends upon. Anyway,
I'm not saying the actual light
has
the weight. I'm saying the particles that are refracting the light have the weight.
So not the light, which is what rainbows are. Yeah? Have a nice day.
Rainbows are light being refracted by particles in the air.
Yeah, but the
particles have the weight.
No, the color is what we're looking at. We're not looking at what you're saying. We're looking at the color. So rainbow, the color is what we see displayed.
All right, so you're making a claim that what we're looking at are colors. Can you can you back that up?
Yeah, I can tell you the different colors.
It's not the
green.
It's not the water particles. It's the color. So
yeah,
back that up.
We're seeing color.
The color is the actual thing that we're seeing, not the water particles.
Yeah, we're seeing a rainbow. When we see a rainbow, hey, when we see a rainbow, we see colors. We don't see water molecules, dude.
That's a claim. Back it up,
water, dude.
What do you mean that's a claim?
That's a claim. You just made a claim. Back it up.
So okay, you're telling me we don't see
elementary school.
We don't see colors when we see a rainbow. Is that what you're saying? Because all I see is colors. It's a demonstration. Whenever you see a rainbow, that colors are all you see.
I'm claiming.
He said he sees water. What colour's water?
Yeah.
What colour's the water?
He got the burden of proof, because when we say that there is nothing there and color is not something that you can hold or measure or verify, so you got to prove the contrary of what we said. There is nothing such a physical color.
Well, he doesn't
We've
get
been
that.
into this non sequitur for like 2 hours now, and they're still no closer to being able to even put forward an attempt to argue for the globe. They're just stuck on the sun. They can't even get past the sun.
They like
That was the current
they like
topic,
being here.
wasn't it?
It takes them away from the actual physical reality that there is no measurement of a globe Earth when they start talking about rainbows being physical.
Yeah.
Exactly. It's scanned flat, by the way.
But it's amusing to listen to. It's amusing to listen to these people.
Yeah, imagine.
So did we establish if colours physical yet?
Imagine you live.
What do you mean? What do you mean? What do you mean, you people? What do you mean, you people?
How much does the color purple weigh, guys? We want to know right now. Go ahead, Duncan.
Purple heavier than blue.
Since when is the definition of physical that it has to have weight? Is that something that Jesus made up?
Embo, how much?
These people. What does that mean?
How much? We're not interested in that, geeks. Embo, how much does a color red weigh?
0 pounds.
Okay. How come Duncan can't tell me that?
I have no idea. Maybe he sees that your argument is based on an assumption that he disagrees with, so he doesn't see it as something valuable enough to even respond to. That's what I could also do, but I'm not dishonest enough to do that.
Hey, can you divine what Jedi's thinking of right now, since you divined his thoughts? What is Jedi thinking of right now?
Tits.
Yeah, pretty much tits, I'd say. As well.
Was Jedi even speaking here before?
Oh, I painted myself in that corner. All right, carry on.
But I was talking to you right now, not Jedi. Jedi is muted.
So can we get an answer? Can we get an answer from Jedi?
So yes, that is absolutely 100% true.
No, I painted myself in that corner. My bad. I'll take the L on that one.
Hey, can the Globers explain why the Earth scans to be flat? So not only does it measure flat, not only is it being observed flat, used flat, but it's also scanned flat with lasers. Why is it scanned flat?
This is all great. Can we go back to the tits, though, please?
Guys, that seems to be something new. I want to discuss that.
So I'm gonna post a pic of a state, how it's supposed to look like, and how the raw scanned data of the LiDAR actually looks like. It's kind of a huge difference, you know. It's kind of like the curvature is missing. It's very weird.
You think you live on a 2D flat surface?
No, you don't understand that there's a zoomed out image. With LiDAR scans, you still get topography, my friend. But this is a very zoomed out
physical
image.
sun, physical rainbow.
Thinks he lives on a straight line.
Horizon.
Is that your best code, man? That's very weak.
What is the source of both these images? From where did you get the globe image and the flood image?
The data is provided by Digital Coast, Office for Coastal Management. It's a government agency.
Sorry.
So
Can I just
both of these
clarify what
images
we're
came
looking
from
at? Can I just clarify what we're looking at here? So the first image is, I don't know what that is, but there's a bunch of red stuff. The second image is
It's both the
a
same
purple
One is
line.
Well, poster rainbow.
Hold
Is
on,
that
we
what
got
I'm
a bunch.
looking at? A purple line? Is that it?
Hold on. We got a bunch of conversations happening. What point are we talking about right now?
Well, I think Clay's saying he lives on a purple 2D line. Don't I?
Oh, dude. Is that your best cope?
Explain it to us.
The-
All
the
I see is a
purple-
line and then a picture
the
of
purple line is this. The purple line is
CGI
this.
picture of Earth.
The
Right,
purple line is
guys,
this. It's a
guys.
LiDAR scan of topography of the Earth. And the first
see.
picture shows how it actually should look like in your model, right?
Do you want to post it?
Yeah, I already
There's in the
posted.
source from where you got it from.
Yeah, I posted the source. There you go.
Is the horizon physical or non-physical?
Well, hold on. Let's let Clay present his thing and talk through it before everyone spazzes out. Yeah.
Yeah, my question is, if we can use LiDAR scanners to make all these unique little points that scan the whole elevation of our topographical plane, why do they turn out to be a topographical plane, just like expected to be on a 2D surface?
The fuck is this guy talking about?
Let him finish, geeks.
I'm not talking about breasts in this case, man.
Right. Maybe they don't know what LiDAR is, Clay, so maybe you should explain to them what this system is and what it's doing.
Tell us what LiDAR is. Yeah.
Okay, so if I'm gonna make it very simple and short, it's like laser beams that are being shot out and they scan whatever it's being shot at, and when the beams come back, it's I don't know how to explain it.
It's radar, but using lasers is basically it.
It's like it collects a lot of little dots that are created by the laser being shot at the oh, you know what? Let's just read it, because I'm very bad at explaining things from my own remembrance. Okay,
I think
so
I just said it, didn't I?
Okay, LiDAR work and how does it? Okay, LiDAR is a ranging device which measures the distance to a target. The distance is measured by sending a short laser pulse and recording the time lapse between outgoing light pulses and the detection of the reflected backscattered light pulse. I can also do that with my phone.
Whoa! Wait! Whoa! Hang on.
Yeah,
This
I have a LiDAR scanner in my phone.
This requires the knowledge of what the speed of light is, though, right?
Bro,
Careful.
I don't understand what you want to say with that.
I don't know if they deny the speed of light, but if yes, that would be a huge blow.
Yeah, it would be. Like, hang on, guys, before we start going down this,
what?
The speed of light thing, is that a contentious issue here?
I don't understand, dude. My question is,
No,
if
we're not gonna get
scan-
distracted onto the speed of light. Clay's gonna finish.
Yeah. Okay, my question is this: if I use I can use my LiDAR scanner here on my phone, right? I can scan the bottle, I can scan my whole room, whatnot. It looks exactly like it is in reality. I can scan my table; it will be exactly the.
That's not LiDAR. That's not LiDAR.
Dude, let me finish. It is LiDAR. I have an iPhone 15 Pro. It has a LiDAR scanner. Go, look it up, man. Anyways, I can scan my table. Oh, golly, man.
Let him finish.
I can scan my room. I can scan my table. It will be represented with the same measurements as I would measure it physically. Then I have it in a digital form. So what they do, they have way sophisticated things they put on airplanes, and then they scan a whole topographic area, such as the state that I posted. Okay, and all these LiDAR scans, all of them, when you look at them in these 3D programs, they all are flat topographical planes, just like expected when we are not on a spinning, wobbling tilted spaceball.
Can geeks ask questions now?
Yeah, you can ask questions now. Yes. I want to hear why it's flat.
No. What is LiDAR? What did you say LiDAR was?
We've already talked about what it is, man.
Okay, I'll repeat it.
It's
LiDAR,
a scanning technique. You don't need to repeat it. My question is not what LiDAR is. It's not my question.
What?
Golly, this guy is really trying to obfuscate as much as possible, right? Why are the outcomes of the LiDAR scans showing a flat Earth?
Does LiDAR use lasers?
This is pointless, man. Why would I even... Again, let's just rejoice with the people who get it.
I
Guys,
also have
not
a
only
question.
does it measure flat, but it also scans flat. So
Answer the
another
question.
checkmate for the globe. No, I'm not gonna
Answer the
entertain your
question.
silliness.
Got caught in a trap there, didn't you?
You can call it whatever you want, man. I absolutely 100% do not care at all.
I know you don't care.
Yeah,
It's clear. It's clear.
yeah. I don't care about obfuscations and coping tactics, man. This
Sorry,
is what we
how much
experience
curvature
every
were
day.
you supposed to see? I don't understand.
I've posted a reference picture that shows the same data applied on your model of a spherical surface.
Can geeks have 1 minute?
And you can clearly,
No.
oh, golly, my head, man. This guy. And you can clearly see the applied data of the LiDAR scan is conforming to your spherical surface, and it's obviously curving. But if you look at the raw data itself, it's actually a topographical flat plane that is being scanned. So once again, it doesn't adhere to your model. That's what I'm talking about. So the
Guys,
reality
why can't I
shows the Earth
speak?
is not
Why
a
can't
ball.
I speak? Why can't I speak and disprove what he's saying?
Yeah, disprove it. Go on.
Right. LiDAR uses pulsed lasers. It's like radar, but using light. He doesn't have LiDAR on his phone because his phone doesn't have a laser. My question for the room still stands. Is there an issue still in contention about the speed of light being consistent? If it is, I'll stop. But I'm asking the question.
Okay, one more time, okay? First of all, I have an iPhone 15 Pro. It has a built-in device, LiDAR scanner. It emits a laser. It emits a laser to measure accurately distances of surrounding objects. It has a laser. That's how LiDAR works. It's in my iPhone. Second of all, your obfuscation tactics with light speed is not going to answer the question why the topographical surface of Earth is being measured flat. The plane that is flying over a state, scanning it, is scanning it flat. Deal with it and don't start creating coping tactics.
Yeah, this is an interesting point, Clay. So I'm glad you brought this up. I haven't seen the data, but what are the distances that they're talking about in these scans, for example?
What?
Guys, you're going to ignore this.
The data, but it's interesting. I have thought about LiDAR before, but I haven't really looked into the data of it. So with some of the ones that you've looked at, what size of area are we talking about that they're displaying as flat?
Second, I can tell you what the size is. Give me 1 minute.
Guys, you're not just going to ignore this, are you?
Ignore what exactly?
No, we're actually trying to discuss it.
Elijah posted something in the chat room with regards to LiDAR scanners within iPhones, iPhone 12, I believe.
What? I have an iPhone 15 Pro.
Cool. We're backing you up.
Sorry if I need
backing you up, dude.
Yeah, he's supporting you. He's posting something that says the iPhone has LiDAR. Right.
Yeah, but it says 12 Pro and 13 Pro.
Who cares if it's a fucking 15, mate? What the fuck? We're trying to help you.
No, oh, golly, man. I'm just saying it has advanced.
You're also in a bad
Yeah, that's
mood.
good. So what area are we talking about that they've done these scans over? Because it would be good to look into the biggest areas that they've done that with.
Well, can we have the link first for the LiDAR iPhone?
It is Minnesota. Minnesota fully scanned.
Remember what I said, Clayshus? If you remember what I said right at the beginning in the chat, Elijah's posted something relative. It's in the chat. Elijah posted it.
So the length of Minnesota is 406 miles. But I've already posted a picture where the LiDAR scan is applied on a globe model, and it obviously shows visible curvature. But in the when you look at the raw data, it is not curved. It is like every other LiDAR scan, just a plane. Same with over water LiDAR scans. Just like we expect with what water does.
Okay, so they're presenting information of a LiDAR scan of at least 400 miles, and they're not showing any curvature of the surface. That's a fair argument. Globers, any response?
Yes. So I want to know what is the source of the image that shows the curve. So the first one in the chat.
Oh, yeah, sure, I can post it too. I forgot about that. That is Hobu. Here you go.
Okay.
They actually have a program where they use the scanned surfaces, and you can look it up in that viewer. Can you open that link? I don't know why it's so big.
Yes, I opened it.
Okay.
So is this the same website as the one where the data was posted, the original data?
No. This is another website where they use that data and apply it to a spherical model. And I just
It does have a laser. I apologize, sir. I apologize very much. I apologize. I'm very sorry.
It's okay. I didn't even. I just. In your face.
Yeah, get wrecked.
Yeah, I got wrecked there.
It's okay, man. That's not.
No, it's not okay. No, because I was ragging on you, and I apologize. I shouldn't have done that. I should have checked it out. I'm very sorry.
It's okay.
Sir. I'm very sorry.
It's okay. That's no problem, man.
Okay, so
you're very gracious. I appreciate it. Thank you.
So we have two images mapping the same data over different baseline. So what I want to ask now is, how do you know which of these pictures is a projection and which is the original raw data, considering the fact that both can't be true at the same time, yet both are presented? Why couldn't I say the same exact thing but in reverse, that the raw data is the one with the globe, but you projected it on the flat surface? I mean, the people who made that website did.
1 second, I give you the raw data.
Well, no, the raw data is in this Hobu thing, right? Is it?
Just 1 second. The thing is, it's like a collective, a collective of so many sources, because it's all private companies coming together and making these scans, right? So it's kind of like not an easy task to always find the original main source of all things. So I'm on
but
it.
FlatScan, just for me, I'm a bit slow. So while you're looking, this kind of orthographical purple image that you've posted, not the one that's just just a purple line. What is this to represent exactly?
Wait, are you talking to me?
Yes. So the latest picture that you put, specifically the orthographical, the not the purple line, the slightly elevated image that shows the purple
Talking about
map.
this one.
What is that to represent
there you go.
precisely?
Oh, that is Minnesota. Just a view from. I first posted a view from the side, side view, and now just to clarify what we're talking about. I posted the main source was a bit of a search, but I posted it. So it's a you can download the ESRI file geodatabase and the full metadata record. This is the full metadata record. I also posted that source.
Thank you.
So the organizer is U.S. Forest Service. Sorry.
No, that's fine. That's fine. Forest Service. Okay, fine. Available. Oh, it's NAD83. No, it's the coordinate scheme NAD83. This is an old methodology that's used in geospatial mapping. I'd be surprised if we can make sense of this. I've dealt with NAD83 stuff before. It's a nightmare to get it into anything visual. Do we even have the data?
But the question here is still, right, Embo, since you gotta kind of refuse my claim, because my claim is easy to prove. No matter when I use Digital Course, for example, because they have a very organized list of a collection of this data. No matter which data map I look at regarding these scans, or maybe this is even a better one. This is like a complete map. Then you can click on the specific scan region.
So, Mr.
One second. Sorry. No matter which region or scan I look at, every scan is a topographical plane. That's my positive claim to
May I, Mr. Flatscan?
Sure.
May I? Okay. What you're dealing with here are projections. So I mentioned NAD83 as one type of projection. When you're dealing with geospatial data, there are a number of different methods that you can use to essentially codify the data, right? One of them, the most common, you've probably heard of this, is WGS84. You ever come across that? Does that ring a bell? WGS84?
No.
Does it not? So Esri, what's their main one? It's I used to deal with this all the time. Projection method. So there are two of them. Maybe these will ring a bell. Choose my projection. ArcGIS. To see if these two things ring a bell at all. Coordinate system. Bloody hell. 3, 8. Map projections. That's what we want. I'm not trying to catch you out, by the way. I just want to see if any of these ring
No
a
problem, man.
bell with you. Yeah. Honestly,
I'm not an
it's in good
expert
faith.
on this. I'm not an expert. I'm talking out of pure observation regarding looking
Sure,
at
I
a
understand.
couple of
I understand. I
things.
understand. So, I used one of my prior jobs in data science. I was responsible for doing exactly this, which was mapping out projections from what was effectively a spheroid onto a flat map. So
What kind of
trying to.
projections? Like how were these projections made?
So what I was responsible for was, or one of the things I was responsible for anyway, was dividing up areas of the UK that were served by, let's just call them points, right? And the important thing about that is that the points were fixed, right? They were fixed, and my model, what it did was it divided the areas up in the UK in the most efficient way. So point 1 served this area, point 2 served this area, and obviously there was overlap, and it was important that the overlapping parts, there was a logic behind which parts go to which point. Does that make sense?
Yeah, I understand. You know, like a puzzle.
Yes, exactly
Question,
that. Exactly that.
the question for me would be where
Why is this all
where's
flat? Right?
where's the source coming from? Like the data. What data did you puzzle together? Was it made with aircrafts? Was it made with from stationary from the ground?
Good question. Very good question. Very good question. So what I used was a method that was. So I used to work for Uber. I was in the operations team in Uber, and one of the things that Uber did in the engineering department was they split the world up into hexagons, and they made that entire thing. They made the entire concept open source so that anyone could use it. And so the data that I was using as a base map were these hexagons. But the reason why it's important, the reason why it was important to go from a globe to a flat transformation is because the hexagons on a globe look different and cover a different area when put onto a flat plane, especially in the UK, where we're very close to the north and things start to. You've probably seen, transformations where things get skewed, areas get skewed. Does that make sense? Am I making sense, or am I? Let me know. I'd be happy to.
Well, question is for me how what devices they use to get this data. Was it also LiDAR scan or?
It's not that they got the data per se. You have to assume that the globe is round, of course. Sorry, the Earth is round, and then a model creates the hexagons and tessellates all of them so that everything is covered, basically. So there is no data per se. It's just a method of splitting the entire Earth up into tessellating shapes.
Mm-hmm.
Does that make sense? I mean, does it make sense?
But
I'm
are
not
these
expecting you to.
shapes are these shapes, these puzzles, or however you want to call them, are they a curved circle, or are they actually flat?
Well, that's exactly the thing. So they are the shapes are based on a spheroid, right? So the hexagons, they are kind of spread across a spheroid, the surface. But then when you translate that to a 2D map for visualization purposes, the hexagons, they're still hexagons, but they get skewed a little bit. They get kind of what's the word? Deformed a little bit. Maybe I'm not explaining myself very well. Let me ask you. Have you ever come up?
I don't know if it really, with all due respect to whatever you did, I don't know if it really helps me with my whole.
I'm about to tell you. I'm about to. I'm about to answer your question. So, the reason why I was doing some searching is because have you heard of the coordinate system 4326, 3857, or 54008? Do any of these numbers did you see any of those as part of what you were doing?
I don't know what, like,
what it refers to.
What the coordinate system refers to? I think
these are
different.
These are coordinate
as far
systems,
as far as I've seen with the London Underground Metro, there's different kinds of coordinate systems that would use, for example, for mapping out topography that has been collected through land surveying. So they use a different kind of grid system. But in a sense, it's all a grid system, no matter what, like no matter which puzzle you use. I think you have also worked with a grid system, right? I don't know which specific one you use, but
sure.
I guess that's what your point is that you're trying to make, right? That there's a different kind of grid system, therefore different types of coordinate. You know what I mean? System.
Yes, exactly. So actually on the London Underground, I know exactly what you're talking about. When they're doing those measurements, it's actually to make sure that the tunnels at certain areas aren't shifting. I know exactly what you're talking about.
However, I've seen the papers. The Globers have brought forth the papers. I have read the papers. The thing is, my conclusion is, like with many other huge projects, and I'll be finished real quick, is that it's always that they mention, yes, we have detected through topographical observations or through land surveying, we have detected curvature, but the curvature regarding the grid system we will apply is so minute that it will be treated as if it's a topographical plane. That's what the conclusion of most papers I have read regarding land surveying for major building projects such as the London Underground has come to for my conclusion, which is obvious because I would not write into the paper, no, there is no measurable curvature, the earth is actually flat, ha ha ha. That's not how the whole thing would work.
No, of course, that's not how it works. We're all scientists, and we want to, it's the pursuit of truth. To wrap it up, effectively, what I'm trying to say is that these flat plane projections that you've kindly provided us with,
but they are scans. The thing I provide you, or the whole thing we're talking about, are scans. Sorry if I'm interrupting you, but I just want to make sure you clarify that it's a scan. It's a direct scan with a scanner, with a LiDAR scanner.
Sure, I understand. But the projection that you provided us, the purple one, is after translation to flat plane.
But why would they do that?
Because when you put it onto a diagram, for example, and you're looking at it as a diagram, because I did this all the time, I had to, because I couldn't show a 3D model every time I was, showing the output. When you put it onto a 2D plane, it is a transformation. It's something called the McCarter transformation, specifically. And effectively, what it does is it takes the coordinate system in 3D space and it translates it into something that can be represented in 2D. Now, for some reason, I can't. My computer's running really slow, so I can't actually pull up the data that's on this map. But I bet you, if you play around with the data that's there will be an option. There will be an option to translate it into a curved equivalent. What you're looking at, sir, is you're looking at what the 2D equivalent would be, not what the data actually shows. Does that make sense?
That doesn't make much sense to me, because if I use my LiDAR scanner on my phone and I directly scan an object, it will have the curvature and the proportions adhering to the scan I did. And if I use the scans they did for these topographical planes, you get mountains, valleys, rivers, and so forth. So it is obviously covering curvature within the whole frame of it being still a topographical plane at the end of the day. Like, you can literally, I can screen share and I can show you.
Yeah. That'd be great. That'd be great if you could.
Maybe easier for you to understand what I'm talking about.
That'd be wonderful, because if I'm looking, if indeed there are mountains and all of that stuff, right, and I'm looking at this purple map that you provided us, there are no elevations, are there? There are no elevations. It's all.
There are elevations. It's all elevation. It's you need to understand what LiDAR is. I can actually get on my phone, a Discord, and give you also a screen recording of the app I use for scanning stuff. It is literally, it creates all these little dots and makes a real 3D scan of whatever you're scanning. So if you look at my screen real quick, you can see.
Yep.
Yeah, you can see all these dots, right? Okay, let me show you. I can make this go to like just 100,000 dots. And then you just add more dots. The more dots you add, the more you get the real thing they collected, right? And as you can see, it is collecting curvature.
No, I get it. Bring the dots down a little bit so that it's just quicker in general.
I mean, if I bring them down, you just lose details.
Yeah. Just temporarily. Just temporarily.
How down should I put them?
Just 3/4 the way.
Okay.
3/4. Yeah, that's fine.
Like
that's fine. Right, now let's have a look here. What do you have? Point size, attributes. Can you scroll down on the menu there?
Yeah.
Right. Okay.
Well, the thing is this, right? My question is, and this is the very important thing, if this LiDAR scan, just like I can use with my phone, scanning objects and get the real deal, like what it is physically when it comes to its curve. Like, I'm scanning my mouse, for example. It has all kinds of shapes. And I get a real 3D representation of what I just scanned. And that's exactly what they do with the topographical plane right here. You see it's curving up because there's a mountain, it's curving down. But when I zoom out now, and I get the full scale of it, do you see how there's literally no curvature?
I understand. What I'm saying is it's not mapped correctly. That's what I'm trying to.
Can you prove that? I want to see. So, because the sources I have looked into say the reason why LiDAR scanners show you all the things that they scan flat is it's just too big. The Earth, every time, even if I use ChatGPT, it just says basically the scanned object is too small.
What is the length? What kind of length are we talking about here?
Well, this is how it would look like in your model, man. This is directly imported onto your model.
Okay.
And this is the raw data.
Some curve there. Okay, fine. What are you actually looking at? Because I don't have this. The same. I'm looking at COPC viewer. I'm trying to. Am I looking at something that's? Are you on Hobu or are you on something else now?
I use both. I use Hobu, which projects the scan onto your model, onto a heliocentric spherical Earth model, to visualize that it should, adhering to your model, is contradicting the claim that it's too big and therefore just looks black, but actually, the scan is scanning the real deal, the curvature of Earth.
Okay, all right.
But
I'm going to try and
as you can see, it isn't doing that. There is no curve.
No, I understand. No, I get you. I just want to look at the data to see if indeed it is being translated correctly. What's the second thing that you have there, the viewer?
This is a Pottery Viewer. Here you go. I show you, man. It's a pretty cool tool. It's a website that has collected all the scans of the United States.
But how did you get that data in there? How did you do that?
I don't know how they did get. I think it's a collective that is collectively using all the free source or official or public data of these LiDAR scans.
Sure. Okay. Fine. So it's separate to this COPC thing, then,
right? No, they actually have. You can either choose Pottery or this thing, this representation. They give you the spherical representation.
Could you send me a link to that other tool that you have there? What's it called?
You mean this?
Whatever the viewer thing that you're using.
Yeah, it is the same tool. It's the same tool, but I'm gonna post a link.
Oh, is it the same? Entwine.
Yeah.
Okay. By the way, I'll give you something that you'll also like if you like this sort of stuff. I'll post it in the chat as well. You'll like this.
Wait, what I like about it is that
no.
Earth is scanned flat, bro.
Go to I sent you a link here as well.
You can't tell me. One second. What would be logically more reasonable, to just scan it and paste it in this program like it is, and have the curvature shown, or to flatten it out? What is more reasonable? Because you have all these little curves. Look, all these micro curves made by the topographical, by the topography of mountain hills and valleys, right? This is all in there, right? But when it comes to the full scale of Texas, they just flatten it out, or what? That doesn't make sense to me.
Well,
I think it is.
Have you looked at any other groups of data by any chance?
Bro, I have looked at now at least 100 no matter which data set you look at. Can
you show me another one?
You pick. You pick. What should I pick? Look at all these states.
Hang on, I'm on it now. We'll go to Texas, just anywhere in Texas, but
okay, then let's use Texas itself, or West Texas, or sorry, I think that I'm not good.
Do the orange one. I'm on the site now.
Okay, the orange one.
Yeah, the orange one. How do I go to America? I'm stuck in Amsterdam.
Stuck in Amsterdam. Do they actually have scans? Unfortunately, I think that maybe there's actually a separate website for European scans.
No, it's fine. It's fine. It doesn't matter. I just want to see why.
Do they have anything in Europe? Oh, it's all.
Yeah, I'm looking at Europe now. I just want to see now if indeed there is a way to translate this into what you'd effectively call round.
It would be actually cool if they could make them all come to one big thing. Like one big scan. That would be funny.
Say that again, sorry.
But I think there would be so many dots to load that you can't load so many dots in a browser. I think the size of these scans are also limited by the sheer processing.
Of course, that's what I wanted you. That's why I wanted you to bring it down, to bring it down. But what do you actually? Because I'm looking at. I think I'm looking at. What have you got? Skybox. We've got gradient.
I don't understand why no one is really interested in this whole combo. We're the only two people talking about this.
Yeah, I know. It's very, very deep stuff. They're like simple stuff. So.
They're like rainbows.
That's true.
But let's ask ChatGPT. Okay. So I'm gonna even give it the link. I have ChatGPT 4, so it can look at it itself.
Okay.
I have here a LiDAR scan of Texas. Why is it that it shows topography as in mountain, hills, valleys?
Dude, just tip on ChatGPT. So the best way to do things is not to give it like a full thing. It's to do it in bullet points.
And the whole thing is represented flat when viewed in full spectrum. Why is it flat? Please be precise.
Can you zoom in? Let me read it. That was visual cues. No, that's not good enough. Measure distance to photo. Fucking ChatGPT is such bullshit. Doesn't give it. Sum it up. I'm gonna do it.
Okay.
I think I need to restart anyway.
So
bullshit. Bullshit.
Okay, it literally claims they flat it out. That makes absolutely no sense to me.
Ask it what transformation it uses to flatten it out.
What?
What transformation is used to flatten it out? I'm not expecting you to believe.
Yeah, I'm asking.
I can't see it. Can you zoom in?
One second.
Can you zoom in? Because I can't see anything.
Yeah.
Thank you. Yeah, see the Mercator projection. You see how the choice of protection, yeah, that's exactly to flatten a 3D into 2D process.
Auto rectification.
That I've never heard of. Process of removing image distortion into place. Okay.
But that doesn't. Well,
it does explain it. No, it doesn't explain it. It doesn't explain it. Go back to ChatGPT. 2D plane, finally representing elevation.
That does explain why they
that doesn't really explain it properly.
The curve.
So
it says it itself. Awful rectification does not actually delete the curve. Well, it does not actually delete the curvature, the detail elevation data from the image. Instead, it corrects for the distortion that occurs. But yeah. The reason might seem like offensive.
So, dude. So I would, yeah. I mean, you seem like you're a lot more technically capable than a lot of. That sounds really, really bad, doesn't it? When I say it like that, you know a lot of stuff. So be happy to. I'm going to add you as a friend first of all, but I'd be happy to take you through what McCarter transformation is. But I think that's where you should start, not this obfuscation bullshit. McCarter transformation is the key thing. I'm not expecting you to
Yeah, but one second. But that's a whole nother spectrum. That's about mapping and create maps or models.
No. It's the transfer. It's the transformation from 3D to 2D, or the other way around, specifically.
But bro, you would agree we're talking about a scan, full-on scan of a part of the Earth.
Perhaps. I don't. But like I said, I don't think that data is being properly translated into effectively it's not being represented in a spherical way. Now, you certainly have me in an interesting position because of the dips and peaks of the valleys and mountains, absolutely, and that is kind of puzzling to me, absolutely. But let me ask you this: when you use LiDAR on your iPhone, right? Yes. And you scan a 3D environment, which is what you are in.
Yes.
What do you see on your screen?
Yeah, I can show you that. One
Please.
second.
Of course.
Let me just quickly go into Discord with my phone. I can show you.
By the way, you have to add me. You have to add me as a friend, apparently, because I tried to add you, but it said I couldn't. Did you hear me?
Oh wait, sorry, my mic was. Dude, I was talking to myself. I think you can hear me now, right?
Yes, yeah. I said you'll have to add me as a friend because I tried to add you, but it didn't work. So.
Okay. You should be able to see my. You should be able to see. Yeah. Do you see it?
Yep.
Okay. So let's go into the app. And I haven't scanned a lot, but let's take this for example.
Mm-hmm.
So this is a 3D scan of a stone I scanned, and it's essentially the same.
This would represent the peaks and the valleys. Right?
Yeah, I can show you the thing in real time, man. I can do actually a scan. Let's do a median object. Let's scan my. Do you see that?
I do.
Okay.
Careful. Don't scan anything that you don't want on the internet.
No, it's no problem, man. Maybe the lighting is a bit bad.
No. Yeah, nice screen, by the way. Nice curve. Is that curved screen?
Yeah, that's curved. Let's scan the microphone,
Samsung
even
one.
that.
All right, so showing off all this cool shit. Yeah, I've got one of those screens
Okay.
turned 90 degrees.
So this is the raw data, right? So it's
Beautiful, beautiful.
It's essentially the same thing. Now what we can do is we can go to detail, and it's gonna process the scan, make it more detailed. But I should actually give it more light. But anyways, this is just a
No,
rough.
it's fine. It's fine. This is just to demonstrate. I got it. This does make me think. All of these LiDAR scans that were done, let's say, across the US, right?
Yeah.
How do you know how any/all of that was done? Does it explain what the methodology
Oh yeah.
was?
It's basically the same thing. So one second, I changed the light. Now I should be able to make a better.
No, I got it, brother. I got it. I understand.
Do you see all these red things? There's all the stuff that the light didn't hit yet.
So let me ask you a question. Well, actually, this is why I wonder about the method of how this LiDAR scan was done.
Yeah.
Because you couldn't do it across. It's not like that entire piece of data across one part of the state was done all at once, right? It must have been done kind of in sections as, I don't know, a plane flew across.
Oh yeah.
Right?
I can show you that. 1 second.
Please, that'd be wonderful.
I'm gonna switch to PC. Now I'm back at PC.
Do you think? Do you think maybe we should let the room go, and then you and I can talk separately? Because I feel like we've taken up, the entire thing. What do you think? I don't mind.
I don't know. I don't know if the room is like annoyed by it.
We've killed it. You and I have killed it. You and I have.
I don't know.
I find
Maybe
it
it's
very
just...
interesting. For me, you can stay.
Okay. See, there's someone who's finding it interesting. I wish people would just give a response. Like, maybe they find something interesting about. But let me show you what. Okay, I'm gonna back to the screen. How it works. So
the method of how they did this. Yeah, that'd be great.
Yeah. So for that, I'm gonna use this island, for example. When you go to the LiDAR report, they actually give you.
Well, this is the data, right? I'm talking about the methodology.
Yeah. 1 second. Did I download it? I think I posted it. 1 second. There was so many I was looking at. Just wanna quickly see if it's still there.
Well, I don't want the data. No, the data is irrelevant. You know that, right?
Yeah, I know. Not the data here. Okay, I got it. The LiDAR report.
Okay.
1 second. In this report, they actually show you which device they used and how it was. Beautiful. Also. Okay, this is the airplane. So this is the airplane. It has a hex sensor. It was installed on a RAM Cessna 406 with the 10 number.
Can you just link that in the chat? Just I can scan through that.
Sure. 1 second.
Great.
I want to show you the camera system.
Well, the camera system is kind of irrelevant. What I'd be interested in is like the slicing, almost like.
Yeah, here you can see it. Flight trajectories. The flight trajectories for the surveying collectors are provided in a shapefile ESRI
Yeah,
shapefile format.
So Esri are basically the custodians of geospatial data.
So this is a trajectory they did over this island, underwater island or whatever.
Understood. Atoll. It's an atoll. Yeah.
And you can even see it in the scan.
Sure.
You can see the that's why I wanted to use this scan. You can see the trajectory.
No. I understand. Yeah.
I don't know why it's not giving me the full resolution. That's weird. Normally. Oh, now okay. Now it's
there you go.
Okay, the orange stuff is water. You see?
Yeah.
That's you can even see the flight path like it's described in the PDF here.
Yeah.
And it's like I think they made that's even crazier that the LiDAR stuff goes underwater. That means that you see the stuff that's sticking out of the water, right here, and then they have the whole thing that is underwater scanned. The whole sand dune island, whatever it's called.
It's an atoll. Yeah.
Yeah.
Okay. Can you link that? Can you link that? Just put the no, not that.
You mean this?
Specifically
the report.
The report. Yeah. Just.
Oh yeah, sure.
That'd be great. Thank you.
Sure, man.
Because again, doesn't quite answer my question. The thing that I'm thank you, sir.
No problem.
The thing I'm most interested in is what if it's an ongoing capture. Physical measurement, combination manual measurement, iterative processing, manual measurement, detail. I mean, I'll read this and come back to you. Like, I don't want to.
Sure, man. It's a lot of stuff. But as far as I know, it's one second. As far as I know, it's the same with photogrammetry data collection, where you have like Google Street View and whatnot, right? What they do is they have predetermined flight paths. And they just scan the area, right? And then they probably have a software that just puts the patches together, right? Otherwise, it would be impossible. Like you can't cover a huge area with just flying over at one time. That's just optically not resolvable. So
I agree. So how? Wait. Can you just give me the link just above it, if you wouldn't mind?
I posted it already. But it says here, LiDAR processing was conducted using the LiDAR Surveying Studio LLS software. Calibration information along with proceed trajectory information were combined with the raw laser data to create an accurately georeferenced LiDAR point cloud. That's an interesting word. Accurately georeferenced LiDAR point cloud for the entire survey in this format. All points from the topographic and bathymetric laser include 16-bit intensity values. During this LLS processing stage, an automatic land-water discrimination was made for the bathymetric waveforms. This allowed the bathymetric green pulses over water to be automatically refracted for the pulse hitting the water surface and traveling through the water column, producing the correct path. Another advantage of the automated land-water discrimination was that it permitted calculation of an accurate water surface over small areas, allowing simple bathymetric processing of smaller narrow streams and drainage canals. Sloping water surfaces were also handled correctly. So, well, I mean, you can read it for yourself, but it's very detailed, I would say. Let's see, does it say anything about curve?
No. What I'm going to suggest is that you and I, we're going to email. We're going to email together this the organization that did this, and we're going to ask the exact question that
Well,
we both can't answer.
Bro, it's the same. For example, I have literally had flight trajectories which were very unusual. I can give you an example that is not, the same for this, but there's a hotline in Germany where you can ask the military if there's military operations going on. Then I literally call them and ask them what about this plane that is doing all these weird patterns and is emitting weird trails that form into white clouds, and then I can't sit in the sun anymore and can't enjoy sunlight. And I was talking to this major whatever, German general, and then I asked, okay, what is this plane? What is it doing? And he said, because it is military, I can't tell you what they're actually doing. So I'm wondering, what is this hotline for? Why is there a hotline I can ask if the military is doing anything? And then I asked the military guy, and the military guy is, actually, I can't tell you. Amazing. So, anyways,
So
why I'm saying
you didn't
this
find
is
anything out.
no. What I'm saying is they will give you a standard answer, right? When you ask them why does their stuff turn out flat, it will be not very much different than the answer regarding ChatGPT. They're just gonna say that it's such a manure scale that it really doesn't matter, or that. Because the thing is, there will be some kind of excuse or program or script they go by. It's the same with all the other documents you can look into, right? For topography and so forth being measured. They always, for major projects, for example, they say, "Oh, we have measured curvature," but indeed, it's so little that it's almost like as if there's none. So we can just use it as it being actually flat,
Well, I'm glad we got to the bottom of
that. Okay, cool. If you don't want me to email them, I won't do it.
Well, you can email them, man. I would be, even if you want to take the time, I would be actually interested if you can email these people. I mean, I could also do it by, I'm just honest. I'm lazy.
I'll keep you in CC. I'll keep you in CC. That's fine. But if you don't, I'll contact you on private.
Just
message.
use Discord. Just use Discord. Whatever you write as an email and you get a response, just send it out.
What is the email address?
I don't know yet.
Of the guys who did the scan? You mean the email address of the guys who did the scan?
Yeah, sure. The guys who know about this.
Probably in their report. 1 second.
Yeah, exactly. I'm looking through the report.
Contract task order, National Auction Esmafik Administration. It's a government agency as far as I know. Maybe at the.
I'll figure it out. Don't worry, I'll figure it out. But there are
I would also give them, the reference numbers and the contract number and so forth, so they know which thing you're talking about.
It's okay. We can. You and I can.
Woolpert.
You and I can do it together. But there already is something that references the datum conversions.
Can I ask a question?
Mm-hmm.
What's the point of all your research that you're doing right now? I mean, you're trying to prove that the Earth is flat because when they scan the stuff, there is no curvature.
Exactly.
I can explain it to you in 2 seconds, just with the drawing.
Oh yeah, sure, man. Go ahead.
Okay.
Yeah, I want to see this as well.
Okay. Imagine you have a ball in your hand, okay?
Mm-hmm.
Okay, that's the Earth. I think how you imagine is that it's like you would be going in a straight line above the ball. That's why you think there should be a curvature. But the problem is that when you are on the Earth, when you move, you are not higher or lower than another point. You understand? Even if there's a relief, you're still the same distance from the center of the planet. So the curvature will be the same everywhere where you are. So when the plane is moving, it stays at the same distance from the ground. He's not going on a straight line, because if you imagine it that way, it would mean that if the plane would go in a straight line, he would go straight into space. Can you imagine it in your head?
What are you refuting?
Well, the thing is this. Wow.
That you cannot scan it. Because when the plane is moving and scanning, he stays at the same height.
Yeah, but why
does it get you to your conclusion?
Why is it that it then can scan the topographical areas such as mountain valleys and rivers? I mean, you get curvature,
but because he follows the curve.
Wait, what do you say? He can't? He can't, or that he can? Because I can see topography.
It's not possible to scan the curvature. That's why I'm saying.
Yeah, but why can we have very, very small curvature scanned, which is caused by
That's not the same as the curvature.
The curvature isn't the same as the curvature.
Okay. I need to make a drawing. Wait, I'm gonna send you a drawing. Wait.
So far, you haven't said a valid logic sequence, just a non sequitur that doesn't connect to the concluding premise.
I'm gonna give you an image. Wait.
Yeah, I understand what he's talking about. He thinks that no matter what you do, as long as you fly the aircraft horizontal and flat over a sphere, you are not able to scan the sphere because the aircraft is orbiting with the sphere. So
I think that this is the case, but I don't want to assume that. That's why I'm saying that we should email the guys who did the study and ask if in fact this is the case.
True,
just a scientist.
True. Because even ChatGPT didn't give me that as an answer. ChatGPT just talked about but
shit suck.
Well, if you use ChatGPT 4, it can search the internet, at least. So it can go through all the possibilities of answer that have already been answered.
Yeah,
but yeah, if you maybe let's do this. Maybe you can email him or the guy who just made the claim with the aircraft and imagine this.
I am almost sure it will answer the same way. Okay. I know how to explain it in a better way. Okay, take a string and put it around.
I already understand it.
And if you take that string and make it flat,
because we're in this room with the label that is on this room, people all of a sudden try to separate perspective, or curve, all these other things but that's not our fault. That's their shortcoming. So could we explain to them in the way that I explained? Yeah, we could. Like, well, this is a description, and when they say, "But is that actually happening?" No.
Yeah, that's
So what do you? So
that's
what do
what
you
I was
mean?
saying when I
Exactly what
agree
I
with
said.
you.
It's like,
Yeah, I agree with you on the waves. Like these anti-flat earthers, they turn everybody like bitter to and I'm sometimes I give the benefit of the doubt that they're just ingrained in that now. Just because they took a stance and they now are holding that line, but really maybe they haven't heard the argument or the explanation. I mean, why look into the original measurements of the angles from the tropics, etc., when you can just talk about gravity all day, every day? I mean. Like I often say, like in here, you can talk to the same person for years, right? They'll never like budge an inch, right? I can go out and meet somebody on the streets, and they're on board in like fucking hour and a half. They're like, yeah, nah, dude, I'm on board. Yeah, doesn't make any sense.
Elijah, is that you coughing?
mm-hmm. Hello.
Nice work, dude.
We all sitting here in here quietly, or what?
I guess so, man.
Yeah. The trolls tried to
Everyone's
get
a-
good hypothetical
Everybody's
games
a-
going, but
Everybody's afraid to be the first person to speak, huh?
no, I was just speaking that how the
How do you
trolls try
laugh
to
like
get
that?
steam by talking about things that aren't important. I just I killed the conversation, dog.
Oh, you did it again, huh, Eli?
Yeah.
Yeah, you're known for that. You're a conversation killer, man.
I did it with the quiet mic and everything.
You've become somewhat of a smooth operator. I get it. No, that's cool.
I mean, seriously, when people say out of all of the teachers and the scientists and the this and the that, like, what do you think they're getting wrong? That's what he said. I said, well, there's a mainstream understanding that the horizon is 1.2 times the square root of the observer's height in feet, and any anyone can basically just validate that statement is true based on the geometry of the sphere we live on. And I
Bro.
said, except
You're
it's not
glazing the
true.
horizon, bro. You're glazing that horizon, bro.
I'm gonna
Like,
glaze it
you gotta
till
chill
I
out.
can't glaze it anymore. It's my honey bun.
You've been glazing it, like
It's my honey
just like
bun.
you've been glazing your planet's shape. Like,
Yeah,
come
it's
on,
my
dude.
honey bun.
Why
Yeah.
are you beefing with your own planet's shape? Like,
It's my honey bun. There's no beef. Or like I explained earlier, there's a claim on the table, and I'm just wondering why all the teachers, scientists, doctors, lawyers, whoever else you think is more significant than flat earthers, why they're not addressing the same question that we're addressing, because the question has to do
because it's
with,
already probably been debunked.
oh, okay, so where is it?
For what? What do you mean? Where is it for what?
The debunk to the
What one of the
point,
many lies you have to tell?
the debunk to the point being
I mean,
raised, where the
Go
teachers,
look up flat
scientists.
Earth debunkers, and they probably already debunked it.
Well, no, they haven't, because there's nothing to
Well, you
debunk.
probably haven't researched enough, then.
Well, there's only one thing to know, was that 1.2 times the square root of the observer's height in feet is the claimed distance to the horizon based on the size of the Earth. And that claim is false. There's nothing to debunk there. It's just the truth.
Okay.
Yep.
Then what? From now what?
Oh, nothing. Unless till someone else comes in and wants to know the same thing.
That's it. That's all you have to say.
What else is there?
Well, you see,
Hold on.
prior to a
Hold
few
on.
years ago. Oh, go ahead. Sorry
Hold
about that.
on. What else is there to say?
I don't know. You don't wanna mention anything else? Just the observer's height in feet, and the horizon being wrong or something.
Well, I mean, I'm not in the mood to make anything up. The question was, why do you guys think that these people are wrong? And I'm like, well, actually, they've never thought about it. 1.2 times the square root of the observer's height gives you the distance to the horizon, except that that's a lie. More people think about it, the farther along we'll be.
Into the break always has a lot to say in the chat. Why don't you talk?
I look at Matt trying to provoke a argument. Settle down, Matt.
He's always yapping in the chat, bro.
You see, NASA, not until that long ago, it was disprove the globe, therefore flat Earth, automatic flat Earth. But recently, there's another model that's stepped into the horizon. It's called concave Earth. You ever heard of that before?
Oh my God!
Heard about it a little bit.
Yeah.
Hey, I don't know why you're saying, "Oh my God, Alpha." I mean, there's a better chance that the Earth is flat than the Earth is that the Earth is a concave and the Earth is flat. So
Nah, you guys are like, you guys are brothers from another mother, man. You and him. One of them thinks it's convex, the other one's concave. Y'all need to, have lunch or something somewhere and figure it out, because it's neither of those. You dig?
I don't know why, but the thought of the Earth being concave just makes me feel uneasy. Like, just doesn't feel right, bro. Anyone else get the same feeling? I don't know, man.
Yeah, he'll probably he can convince you though, right? All Glory. Just talk to Matt Nuclear. He'll listen to you.
That's not the intention, bro. It's just to let people be aware of it, and then that's it.
Well, you haven't made Matt aware of it. He's not aware of it. It's the first time he's hearing of it, probably.
Well, I'm aware of the concave Earth conspiracy.
All right, Steelman, All Glory then. Steelman him.
Steelman him. I mean, his Earth is curving, so I mean,
my dick is curving.
Yeah, you're a putz.
Same. TMI.
Guy left instantly.
Still haven't heard you, Steelman. All Glory's position for a concave Earth, Matt. Thought you said you knew.
He doesn't need to. It's just the idea that you're inside of a sphere and it's curving up at the just base minimum. That's it.
Yeah. I mean, it's still curving.
Go ahead.
I mean, I don't know what to say. It's still curving, yeah.
I don't know. Well, how does it make sense?
Doesn't have to, bro. It's just that's
really.
the model. Be aware of it.
Yeah,
I'm asking. True.
I'm asking Matt because he thinks that you got something going.
You're asking me.
You think saying concave or convex lets you have the pass to say that it can be, right?
And he can say that he thinks the Earth is concave. It's not the consensus.
The Earth is penis.
You can say it makes. I'm gonna say this though. It makes more sense than a flat Earth. Because a flat Earth isn't curving. So makes more sense than that. Why don't you look at his evidence though? He's posting some stuff in the chat.
No.
Yeah, I'll let you guys talk amongst yourselves about the assumptions you make. We don't make assumptions on flat Earth. We know things. So there's that.
You don't seem to know a whole lot, Troglodyte.
Yeah, is that the best you got, Putz? Jaws, is that the best you got? You come in here and drop little stupid comments and then leave? You're not an intellectual debater, dude, so get the fuck out of here.
Yeah, I know.
Just enough time so that I could dog him. Nice. Hey man, you mess with the bull, you get the horns.
Oh, good.
What are your thoughts on the concave Earth, Alpha?
That's some bullshit.
Why?
It's the same thing like globe Earth. All speculation, man. All day long. Nothing you can provide as evidence of the Earth curving in any direction, up or down. Nothing. You guys are completely bankrupt, and you're grasping at straws. And if you want to prove me wrong, go ahead and provide your best evidence. I don't care what it is. Let's hear it.
I like the idea
Go
of
ahead.
flat Earth, though. I really do. I mean, I like the idea.
Nobody can prove you wrong because the proof part, we would need some kind of a confirmation from your end, and that'll never happen. So it's pointless.
Well, I'm not the one that makes the claim. Everybody on Earth observes the Earth flat and stationary. And if somebody doesn't, then I'd like to hear how they're observing it as a globe or a concave Earth.
No one can prove it to you because you reify flat Earth when you observe reality, and that tells you the Earth is flat, and no one can undo that for you.
Yeah, but how do you reify something that's self-evident, dude? Think about it. It's self-evident. I don't have to reify it. It automatically is self-evident. Duh. So I have the winning hand and you don't. There's that, right?
There's no point. There's no point for me to engage you. Like I would do it out of love, but I seriously don't think there'd be any point. It's because your being actively rejects the material, like to the core of your being. You don't want anything to do with it. You don't even. I don't think you're even willing to put your beliefs to the side and just say fuck it. Let me just get a trash understanding of this trash model. You just want nothing to do with it, and so there's no point.
Well, you got one thing right.
It is what it is, bro.
I only deal with people that are able to articulate their point to the fact of being empirical. If they can't do that, then I don't want to deal with them.
Hey,
you guys don't have what it
takes. Information you're willing to entertain. That's your parameters, bro. Like I can't do anything about it.
Yep. Yeah, you got to be able to produce it in a direct measurement. That's my filter. And if you can't pass the standard, then you just got ideas. That's all you got. I don't care about ideas. I care about providing evidence. Prove it to me. Show me. You got demonstration?
That's an impossible task. So I don't know why you keep asking that. No one can show you something you refuse to see.
Well, if you can't provide the evidence of a flying spaghetti monster, then you don't got any evidence of it.
Correct. To you and others like you, which I don't mean that in a negative way. That is an impossible feat. It'll never happen.
Good. I like it that way. That means that you're wrong and I'm right.
To be honest, dude. Well, to be honest, dude, Alpha, if you've been a flat earther for like 10 years or whatever you said, how long, then you're probably not going to be convinced.
No, it's not about being convinced, bro. It's about bringing the evidence. Can you do that?
Yeah, but will you be convinced by anyone's evidence?
You don't. No, yeah, but you don't have to ask me what I will accept as evidence. All you got to do is provide the evidence. That's it.
Hold on.
You've been a flat for 10 years. There's no accepting evidence for you.
Wait a minute. So 6 years ago, the standard of evidence was globe earthers bringing us to the beach and telling us to look out into the distance at things that were being blocked by the geometric horizon. Here we are today.
It's still evidence till today.
This is what I'm saying. Like, obviously, he's ignorant. Obviously,
100%.
I mean, where do you think that boat's going? What's obstructing the boat? Angular resolution or some bullshit?
Concave Earth has answers for all of that.
All right, no, hold on. So, are you aware that the horizon is dictated by the?
You guys always do this thing where you dick ride the horizon. I'm not worried about the horizon. I'm just worried about the geometric curve. Either there's a geometric curve or there isn't. Fuck the horizon.
Oh, I was asking you your level of awareness. So okay, so let me get this straight. So there are people that claim to use the horizon as an argument, the globe earthers. And I'm pointing out how they no longer use that because it's been debunked.
What do they no longer use?
Not withholding laser tests. And you're saying that it's us that won't accept any, like, no, like the opposition has been thoroughly
I'm saying if you know what I said, right? That if you've been a flat earther for like 10 years, there's probably no convincing you.
Convincing us of what?
Well, go talk to the scientists.
Yeah.
Do that. Right?
Yeah, you're doing it wrong. You're doing it wrong, Matt. You're doing it wrong. You're not supposed to convince the person you're talking to. You're supposed to challenge them, and you're not doing even that.
Well, we've already challenged each other a while ago, dude.
No, you haven't challenged, dude. You couldn't challenge fucking a wet paper bag, dude. There's nothing you can do to provide evidence for what you're talking about. It's all fairy tales for you. It's everything. It's made up fairy tales, fiction. You love it. I don't care, but there's no evidence. provide to me one thing that the globe Earth is showing us in real life.
You know,
Anything. I don't care what it is.
Boats
One thing. Just
going
one.
over curvature. Boats going over curvature. That's real time, real life. You can do it any day you want.
yo, you know NASA's son. You know,
You can't solve for me where that boat goes. You can never do it. You're always like making up some random angular bullshit thing. I know what's going over a geometric curve. We already established that it's going over a geometric curve. It makes it's impossible on a flat horizontal surface.
Keep that energy, Matt. You're gonna need it.
And the fact that you've been a flat earther for so long and you think that's like reasonable in your mind, like do you not question your own belief at all, Alpha? Do you not do
it's
that?
an A or
You're like,
B situation, bro.
why the
If it's
fuck is
not
this
curving
boat?
down, it's flat. If it's not curving down,
Exactly.
it's flat.
So why don't you ask yourself, Alpha? Why does this boat being obstructed like this? What's going on? Is that not Earth curve? How does that make sense for a horizontal flat body of water to be doing that to a boat? Why don't you ask yourself that, man?
Yo, don't do a guy like this, bro. He's the one that normally asks all the questions.
Yeah, I forgot.
If it's not curving down, it doesn't. If there's no deviation measured from the datum, then there's no deviation measured.
Yeah, I go easy on Matt. He's
Not
young.
necessarily.
He can
It's
believe
not
that it's a
necessarily
globe.
like that it's curving down. It's just curving away from you, really.
No, he just gave this dichotomy just wasn't true. If there's no measured deviation,
I
there's no
know.
measured deviation.
I know. Well, we
Measured
gotta.
deviation,
Yeah,
measured
I don't know.
Goddamn.
Yeah, they want me to mute you, man. I'm just you bring the conversation. Yeah, but if we mute him, dude, he's not. There's
Into
not
the
gonna be any
break is a
conversation.
clown, dude. I don't think you should listen to what anything he says, dude. He's a clown. He
No,
never
all I'm
wants to
saying-
speak. He's always just
Listen.
yapping the chat.
Yeah, you know, despite him being a hard-nosed glober, I don't know. Everybody has their opinions. I think Matt's all right. Everyone's gonna hate me for that, but it's true. He's just a hard-headed glober. That's all. He's young. He's I don't know. Just give him some time.
We love NASA son.
Who said that shit?
All glory to the Most High.
Oh.
I mean, I would love to invite Into the Break to speak, dude. Like, honestly, he should just speak.
You wanna get your knuckles dirty, dude. He's not gonna want to do that with you.
I know he isn't.
Me or Eli, like some of us have been doing this for a while, dude. We know what we're dealing with.
Hey, man, you're a flat Earth defender. You're one of the high-ranking ones, right?
Well, I'll let you judge. I'm really just kind of relaxing right now. I'm actually gonna go watch some Netflix, to be honest. I just stopped in between intermission breaks.
That's right.
What are you watching on Netflix? You're dealing with a child. That this is taking a break from Fortnite raids. Okay, sure.
You're Fortnite. You're rating in Fortnite.
No, I don't play Fortnite.
He's a Roblox.
Oh, what do
kind
you
of
play?
guy.
Your Roblox?
I don't play Roblox, dude. No.
Yeah, you still watch SpongeBob, don't you? Oh, gotcha.
I mean, I would rewatch an episode, dude. SpongeBob is
I know.
iconic, you know.
I know.
I mean, who wouldn't
You like
rewatch
him.
an episode of SpongeBob?
Yeah, you're actually calling out the room. I dare you to say you don't like SpongeBob right now.
Hey,
Who doesn't like SpongeBob though? I mean, I don't watch it. I've not probably watched it in years, but like,
You
who
fucking
doesn't
do.
like SpongeBob, dude?
You fucking do. Yeah, as soon as you're off of here, that's what you're doing.
No, that's not what I'm doing. It's funny you
Fucking
said
liar.
that, but no.
Eli, this guy's capping, dude. I know he rushes to his big bowl of cereal with that mother spoon, and he's fucking just watching SpongeBob. Fucking her, fuck out of here, dude.
Hey,
you might convince me to watch an episode of SpongeBob, dude.
Hey, NASA's son. I think
I
I
don't
figured
think
out a way to help these guys. Like, truly figure out that.
All right, settle down, Elvis.
Do you know what circles of latitude is, NASA's son? Circles of latitude on the globe.
Sure. Probably like a brief understanding of it. Yeah.
Yeah.
Okay, so like
do you know
no, or
do you know how you get latitude?
look, a circle of latitude. Imagine like a horizontal belt on the globe. So the equator would be a circle of latitude. Okay, just a perfect or like horizontal, and
That's not a contradiction at all.
the equator. This is for NASA Sun. The equator on the
Bro,
globe is the
bro, the
biggest
guy
circle.
tuned you out. He tuned you out, bro. I know, Matt. He just tuned your ass out. Like he's not listening.
No, I'm listening to him. What do you mean I tuned
Nah,
him out?
bullshit. What did he? What did he just say?
No, let me.
How far you just?
I'll make
How
it
far you
quick.
just rated what he has to say?
Okay,
What did he
since
just
I know
say?
you're not dumb, bro, I'm just gonna make it
He's
quick.
talking about circles of latitude on the equator. What are you talking
And
about?
where are they at? Where are they at? What did he say after that?
He's talking
That's
about
as
horizontal
far as I
circles of
went.
latitude on the equator.
You don't know
That's
shit,
that's
dude.
literally
You
what he
tuned
said.
out.
That's
Yeah, you
exactly
tuned
what he
out, bro.
said. Did he not say that? All glory. Did you not say that?
Yeah, I gotta let you hear the rest though.
Go ahead.
Okay,
Go ahead,
let
Algo.
him go, man.
So look, on the equator, you could imagine a circle around the equator as a true distance, a true length, okay? And that around the globe would be the biggest one. And when you go north and south of the equator, they get progressively smaller and smaller and smaller and smaller. Does that make sense so far? For NASA Sun?
Of course, yeah.
Okay, well, on the AE model, it gets bigger south of the equator. This
Does,
true
and it makes no sense.
Oh yeah, bro. This breaks the whole model badly. It's fucked. And
It does,
it's not.
indeed destroy it.
Hold on. You mean the AE map that the
Bro,
British
anything
royalty? Hold on,
That
I'm
you
sorry.
don't claim.
I'm sorry.
That you
I
don't
was in
claim
the
because you're
middle.
so afraid of
I'm
it.
sorry.
But
I'm
it's really
Let him
a
sorry.
say it.
flat
Let him
Earth
say it.
I'm sorry. I was
Let
in
him
the
say
middle.
it. Sorry, bro.
I'm sorry.
Sorry.
I
Go
was in the
ahead.
middle. The AE map. You mean the globe Earth projection?
Whatever.
That's the thing that doesn't. It's not. No, hold on. It's not whatever because you're critiquing
That
it
wasn't
like
my
as
response. I have more words to say than one for you to want to continue.
Well, I'm
Is it a
just talking
conversation
about.
or not?
I'm just talking about latitude on that
dude.
model, which
Why is
is
he
in
talking in
Florida.
slow mo, bro?
Just calm down. No, he does
I'm
talk in slow
sorry.
mo.
So yeah, I mean, and I'm gonna
He's
start
like a
over
sloth
every
when he talks.
time, and I'm
Okay,
gonna
well,
start
let me
over every
grab a
single
chair.
time, and I'm gonna start over every single time. So you said that on a globe the latitude lines get smaller, but on the AE globe Earth projection it gets bigger. So I don't. What?
All right. Can I explain now? So
Yes.
any combination of words you want to use to describe the idea of there being a pole in the center and lands outwards from there. Any words, any model, non-model, that idea with a pole in the center and land spread out from there runs into the issue of eventually you have the pole in the center, the land spread out. Eventually you're going to hit to the equator. And beyond the equator, it's still spreading out and it's getting bigger and bigger and bigger and bigger. And that doesn't match NASA Sun's model, at least. So that's all I wanted to point out.
Could I use
Yeah,
this
man.
word?
Doesn't match the model.
Could I use like if you were to take that idea, if you were to take that idea and wrap it around NASA Sun's model, you would probably get a pear-shaped model.
Pear-shaped.
Well, I mean, latitude and then the sun.
You guys have a
positioning
flashlight
is
sun
kind
that
of.
lights help half of
You
the
see
world, but doesn't
how I was
like
talking,
NASA,
and then this guy just
NASA, someone's
started.
talking, bro. Settle down, yo.
Does it every time.
Up.
Oh my God, Gregory! Oh no.
Yeah, you don't want none of that smoke. Let Eli finish, eh?
Oh, Gregory's the really dumb flat earther. He just yaps his mouth.
Yeah.
Big words for a little man.
So the other guy said all of that to say what? Because we're talking about a coordinate system. In your what is your criticism of the I guess you're moving away from the coordinate system to just say that the argument that
Bro, let me respond to your question, bro. Don't assume you just. What is my criticism? Can I respond to that?
Well, your criticism doesn't
That's
follow
a no.
your
Okay,
premise
go
because
ahead.
because you dropped the premise when I clarified that a projection is the same. And you said, well, regardless of that, we're just talking about how you visualize from the point of north all the way outward. And obviously, there would be an increase in the circle. Yeah, I get that. But what's your argument?
So NASA Sun, about those circles of latitude, bro. Our models match in circles of latitude. We understand that these circles actually get smaller south and south and south of the equator.
Do you mean longitude?
We actually understand Antarctica is a small continent and not an ice wall encompassing the entire fucking world. So
Do you mean longitude? Not latitude?
Oh, was that Gregory? Oh, I
gentlemen.
thought it was for I'll answer Gregory. No, I actually specifically meant latitude because of the discrepancy that I pointed out earlier. I could point it out again if you want.
Yeah, I'm gonna be back after a while, guys. I'll catch you in a minute. Gonna go watch some TV.
All right, see ya.
So the sun rotates around the earth, or the earth spins north to south?
No, okay. So the idea is on the globe model, okay? The globe model, which is not we're not making a claim. On the globe model, the biggest circle of latitude is on the equator. That's like the biggest circle distance-wise. To go and make a circle, come back, that's the biggest circle of latitude. And north or south of the equator on the globe, it gets smaller and smaller the more you go north or south compared to the equator. Okay. On the on flat Earth, the circles of latitude get bigger south of the equator. This is opposite of the globe.
Well, that's because it's not because your example is sun centric, but when you're talking about AE, it's north centric. So it's like you're talking about two different things.
No, bro. We're talking about real distances here.
No, I get what you're saying, but my critique still stands.
Sure.
I mean, you're talking about the circles of latitude based on the sun, and then you're like, well,
No,
what
no,
about this one particular projection that specifically deals with the star being the center? Like, there's two different things.
Yeah, just keep ignoring the real distance discrepancy in my example. Just disregard everything I said and delude yourself a diluted explanation to continue deluding yourself another day. Just disregard the actual real distance, the real line in the sand. One model says this, the other model says that.
Yeah, you keep conflating categories.
Disregard that. That's not my problem.
Yeah,
Thank
you
you
keep
very much.
conflating categories.
Well, there's two. There's the projection, supposedly, of the globe, number one, that you keep saying is inaccurate for some reason. And then there's longitude and where the sun is. And I mean,
yeah, so you conflate categories.
And I say longitude because when you use the sun, it's typically to find your longitude or to use it knowing it's how you know your longitude to then derive the latitude. Maybe I don't know. I get this confused. I don't know everything about this, but there's a difference between how latitude was built based off of Polaris and time and date and how that works in relation to the sun's movement. Two different things. You comparing both of them and saying why is one in contradiction with the other doesn't make sense.
Well, it's a moot point. Why do the different paradigms contradict one another? Obviously, because they're not the same paradigm. It's a truism. So he conflated the two different categories of longitude and latitude. And then he's really arguing belligerently to a truism as to why the two different paradigms contradict each other in principle, because obviously they're not the same paradigm. What's your point?
Did you pick that up because of the what is that the PZT triangle, a PZX triangle?
Asking me or him?
Yeah, like when we were talking about the meridian passage and using the sun's like uh 90 degrees overhead to get your longitude, something like that. Is that how you pointed that out? Like how did you?
Well, I heard him talking about, obviously he was talking about the circles in principle that are wrapping around the ball, right? Going down from the south. So he's referring to the east-west coordinate, right?
Listen. You guys aren't. You're not very good at this. Let me help you out here. Truly, let me help you out.
Oh my God! Condescension and pretension is not
Look at the side chat.
a sufficient
Look at the
substitute
side
for
chat.
sound argumentation.
Listen, I know that the presence of the globe really like fucks the mind up. So we're only gonna have in consideration flat on flat. Okay. Look at the side chat. I posted 2 maps. What's the difference between these 2 maps?
It's not a map, stupid.
What's the difference between these 2 maps?
It's not a map.
Pay attention to circles of latitude specifically.
That's not a map. You didn't post a map.
So another category error.
This secondary map that I posted, which is not the AE, this matches decreasing circles of latitude.
It's not a map. Where's the legend? Where's the key? Where's
It is a
anything
map.
that a map has?
No, it's not a map.
You see this image? These are decreasing circles of latitude. You see that those 2 green circles? You would have another smaller green circle within that green circle, and then so on and so on and so on. Both poles.
So what?
This is real distance. So what? It's more accurate.
Well,
It
you
reflects.
don't have
What do you mean real distance? It's just a mathematical
reality better.
category.
you don't
haven't
have
made a point.
accurate dis.
Hey,
You don't
both
have
of you guys.
accurate distance. You don't have accurate distances in the south like that. Like
Hey,
what are you
listen.
talking
Like
about?
what accurate distances? It's just lines around
This
the
is the
ball. It's
best you're
just
gonna get.
represented
You
in
guys,
mathematical
both of you,
concept. As you
both of
continue
you.
to talk through my reply because you don't actually want to engage in a discourse, so I'm going to finish what I was saying. You don't have the right to dominate the voice channel. So what you presented is not an instance of accurate distances.
Hey,
It's just an
flat
illustration of a
earthers in the
mathematical
room.
concept.
Flat earthers in the room. His behavior and his handling of
So
this
it's
situation
still
and this
just
topic
an
should
illustration
really
of a
make you
mathematical
go,
concept. That's the refutation to your appeal to this illustration. So
Gregory, you're out.
persevering to
You're
distract from
out.
what I'm saying. So
I'm
persevering to
done speaking
distract
to
what
you,
I'm
bud.
saying and persevering to try and boot me out of the conversation cannot refute the refutation that was just said to you by me and Eli.
You're out. You're beyond hope, bud.
Yeah,
You're
this
beyond
is a
hope.
map of the world that he posted.
It's not a map. It's a
Hey, listen,
category error.
these guys have a traumatic, a vicious traumatic response to any map, to the
So
word
you don't have
model,
any
to the
rebuttal
word
to
map.
the
They have a
refutation that
vicious
Eli just
traumatic
said to
response, and
expose
this is
your
why you
appeal to
can't
this
help them.
illustration
You cannot
as
help
a
them,
map. So now I'm going to keep talking
especially
to
this
you
one right here.
until there's moderation in this voice channel because you think every time you want to open
Buddy,
your mouth,
you're muted
Okay,
on my end.
Gregory.
You know when he's
dominate
done.
the
He's
voice
muted on my
channel.
end.
Gregory,
I'm not
listen.
hearing this anymore.
There we go.
Okay, Gregory, you're the one engaging with him. Okay, it doesn't make sense.
I'm aware.
It's not. Okay, it's not logical for you to say that you also
Crit,
want.
why do you Crit? We're engaging them. Like they keep saying that we're not engaging them. We don't have a problem with engaging them.
Yeah, because okay, you know, Glory's a concave earther.
Yes, but we
Okay.
still decided to engage them. I've
Yeah.
engaged them. I'm speaking to them. He's just being disruptive, and no one's doing anything about it.
Until now.
I'm not sure what you want me to do.
Nothing.
Okay, well, there.
I didn't ask for you.
Yeah, Gregory did.
Well,
Yeah, so I'm going to keep interrupting him. I'm going to keep disrupting his disruption until there's moderation.
All you've got is lip service, but I'm not interested. You're gate kept.
Yeah, so that's not an argument, and he didn't refute anything that Eli said to him, nor what I said to him. He just disrupted the room because he can't engage the refutation.
You're utterly gate kept. All you've got is lip service. I'm not interested in it anymore.
Again, it's just canards. It's not an argument.
50% volume on my end. Just so
More
I don't
canards and not an argument.
So because he wouldn't stop interrupting Gregory's response to the questions he was asking, Gregory said, well, I'm just going to have my reply through you until the moderators feel it makes sense to stop you from interrupting the responses to you. And then you came in, Crit, doing whatever the fuck it is.
Yeah, blame Crit now. What a guy. Blame Crit now. It's over. Both of you are already out. I'm not interested in talking to you anymore.
So more canards and no argument again.
Okay, how about let me see if this. Look at the GIF that Glory posted 8 minutes after the hour. It takes the AE projection and
my
keeps.
response was it wasn't a map because he said, "Look at the map," and I said, "That's not a map."
Oh yeah, that's not a map, right, Glory, or is that a map?
Define map.
Scale is on it.
Yeah, scale, direction, card. It has a legend. A compass rose.
So you would say this is just merely a projection, not a map, an actual map.
Yeah, it'd be like a conceptual idea based on some point that is centered, which looks like here, the Middle East, which is kind of interesting that this is a start of creation for humanity.
Glory, do you think this is a map that you posted? As
I'm not getting in. I'm not engaging myself in retard level conversations. I already said I'm out with
and
those
pretension
two.
is a futile substitution for sound argumentation. He said several times, I posted a map. He was wrong.
50% volume.
Well, is great or Gregory, Glory. Do you think the GIF here is this a map? And there's no right or wrong answer. What do you think it is?
I'm not interested in entering a discussion where I have to explain what that is. That explains to me it is retard levels of.
Okay, so we don't need to ask him the question again.
Crit, sorry.
No, it's just a clarifying question.
That was my response to Crit. I'm still out.
He doesn't want to answer, so we don't need to ask him again.
That's the answer you got. It doesn't matter what if you ask a question, any answer you get, it's kind of on you. Because you're the one that I know that never to ask Glory anything. I got feedback where there isn't any reason to ask him questions. Because I won't ever get an answer that propels the conversation forward. Any answer I get always would be the end of the conversation.
That's why I keep saying he joins the VC not to engage in discourse, but just to run his mouth.
Hey, feel free. All of you get together, vote ban me. I won't cry about it. Do what you got to do.
As he cries about
Until then, I'm going to be me, respect the rules and you
cry
guys as much as possible. Do what you got to do.
And he's still continuing to cry about it.
Glory is the only problem here is you're not breaking any rules either. If you want to get banned, just start yelling the N-word. Or something just as bad as that. I mean, I don't know what you think was going to happen.
No. I'm here to help those who are ready, and these two aren't ready, so I'm disengaging with them. That's it. It is what it is.
There's nothing wrong with that. That's
pretension.
Perfectly normal.
So I'll try to explain what's going down simply from what I've heard. It's like you bring up the FE map, okay? They tell you that that's based off a globe longitude and latitude system, and you just keep on going and wanting to bring up that as proof of what they think. So you're like misrepresenting. That's a straw man, and then you bring up illustrations that aren't maps at all and claim that those are maps. So this is just not. It's not. The conversation can't go forward if you're not making any sense.
You're not going to say, another reply besides what you just initially said. Okay, so that's refuted.
When I hear concave stuff, I'm not really interested in. I mean, just from my point of view, their observations of the surface. It's kind of interesting to hear their observations of the sky because it has some things in it that directly sort of refute heliocentric. And then that sort of a downward push that Michio Kaku had talked about. Space-time pushing you down from above.
Ontological idiocy. Now I know why so many pseudo-intellectual trolls like talking down here with this volume. Imagine talking the way Glory does in the classroom. You know, just answering the professor's question. What's a map? Just start shouting.
Keep running your mouth, boy. I shine like 10 times brighter than you. Literally anything you could do, I could do better. Okay, just
People
keep
like
my
him
name in your
exist. I
mouth.
cannot-
You're gonna need it.
Can't believe this.
You're gonna need it, bud. Keep doing your little sissy girl laughs. You're gonna need it. Yeah, you got it. Yeah, you guys are having a little too much fun. You guys have a great day. I'll be back later.
Can you imagine being that prideful and fragile simultaneously?
I don't think it's mostly because concavers are kind of like really hard. It's hard for them to get space to talk. So they're used to sort of like everything being just a shouting match.
That's a part of it, yeah. You know, wisdom would say, the person I'm talking to, I'm a concave earther. The person I'm talking to doesn't want to critically consider what I have to say, doesn't want to scrutinize themselves. So perhaps I should just disengage, attempting to engage them in discourse, not just continue to shout my voice at them, and then wonder why I keep getting frustrated that I'm not attaining the goal that I want with them. But fools don't say wisdom after all, so. The floor is open anyway. Who wants to present an argument that they know the Earth is a ball?
Did you see the news for today?
What you posted in Greatest Minds on Discord?
Yeah, what'd you think?
Yeah, that is, hold on, let me look at it again. Hold on.
It's a whopper, ain't it? Like you never know what type of like. It's one of those things where if you were to tell globalists, is this a factual story or something I made up? They would have called that like you made that shit up.
You can't make this stuff up.
Mars is the reason why it's been record-breaking temperatures all year. Wow.
Go past it. Where is it? You put it in Flat Earth, did you not?
Yeah, it's in Flat Earth.
I guess it was before your latest one. Because your latest one is debris from burning satellites.
That was yesterday. Or maybe I did post in the wrong channel. Let me see.
Yeah, maybe you did post it in the wrong channel. Is it in the wrong channel? I don't think it's in the wrong channel. I think it's in a different server. Because you usually post those posts.
Yeah, no, hear this. 4:50 a.m. my time, and then Surreal responded with like the record, the temperature from ice core samples for going back 1,000 years.
There you are. Oh, okay. Yeah, it looks different. I was expecting a white background with the screenshot, but it was
A black, yeah, black this time.
wow. Every 2.4 million years, Mars's orbit comes close enough to Earth that its gravity can affect it, tilting Earth's usual path and orientation. This orbital shift causes Earth to be exposed to more sunlight, warming the climate, which in turn stirs up ocean currents, makes them stronger. And it's just a snippet.
Yeah, there's a few stories that kind of capture it's the same. That's why I like when Global say, "Hey, give me the link." I'm like, well, I really don't want to do that because I want all these stories kind of say the same thing, but slightly different too. Like if you go to another news story it's talking about it, they'll spin it. I get a lot of these articles, except for this one. I can't remember who sent it to me. I think it was. I can't remember. I have to look. Okay. Well, normally I go to a program I got called Ground News, and it tells you which stories are being observed by the right and left wing, and also which stories are being ignored by one side or both sides. So, but for this one here, it seems like it's really like everyone kind of ignored it. Even Ground News themselves didn't really cover it.
It's so annoying seeing professing disciples believe a chronology, a cosmogony that is contradicting the scriptures.
I mean, even if you give them the heliocentric model and say, you're right, it's a globe, it's heliocentric, how are they using that to post-stick 2.4 million years ago? They have no idea what flew through the universe, through the cosmos at that time, what giant asteroid or meteor or whatever. They have no idea how things could have slowly changed and moved slightly a little, Is that just a ballpark figure, or do they really mean 2.4 million years? It could have been 1.5 million years or something like that, like plus or minus.
I assume that it's supposed to be precise, given that it's a decimal.
Oh yeah, that's a significant figure. Plus or minus 100,000 years,
give or take. There's nothing that we can empirically detect, even with our instruments, that informs us that anything in creation is tens of thousands and more years old. Nothing. It's just a uniformitarian. It's just a controlling premise that various things are that old, right? Tens of thousands and above years old, with the controlling metaphysical presupposition of uniformitarianism. That there's so-called radiometric dating methods is tracking the motion of this or that niche arcane atom or whatever molecule, and its rate of motion never changed, ever at all. Which is also inconsistent with their evolutionism. Everything changes. So in breath number one, everything changes, evolution, but except this, because we need it to not change logically so that we can justify our alternative chronology and cosmology and cosmogeny.
Huh. You hear about this aborted launch Thursday? So this morning, Soyuz
A warning, is it?
liftoff. What's that?
I said, oh, a warning, is it?
Oh, I missed it. A warning, is it?
Did you say warning? Did I mishear you?
This morning.
Oh, morning.
Morning, yeah. So this morning, Russian time, the crew had to do abort launch, and they safely returned to Earth. You hardly ever hear about that.
They made that up too, didn't they?
If they do abort and they survive, you know what that means by abort? Not abort launch. Mean they canceled the launch. They didn't. It started to lift off. They knew it was going to explode, and it's like ejection. They ejected the capsule
It's
out.
not ejection. It's prematurely canceling it.
No, but they eject the crew out, and then the rocket still explodes.
Yeah. What?
That's what I mean. Like, you guys in the globe model, like, you don't even know what they're talking
about.
The Soyuz launched this today.
Before they launch, they eject.
You mean like to make this into a verbal brawling match? They're just letting people finish their replies.
It goes up into the air. They realize it's going to crash and burn. It's not going to make it. So they're able to eject the crew out of the rocket, and they're safely returned back to Earth.
Okay, then explain it better next time.
That's what I'm saying. You should know.
Or you could just stop verbally brawling with people.
Oh, you just didn't explain it. You just didn't explain.
Or you could stop verbally brawling with people and disrupting their attempt to complete.
Gregory,
complete the
please don't speak to me, dude. Please don't speak.
Please
to me
stop interrupting others when they're trying to complete their sentences. It's no good.
I'm not talking to you, dude.
I'm talking to you right now.
I have a clip of you melting down in the Christian chat, dude. You're insane.
What are you talking about?
Do you want to see it? Or?
See what?
No, it's off topic. It was in their channel. I don't care.
All right.
Yeah, people like you make the world worse. You just start polls for no reason.
People
you
like you
prevent
make
knowledge
the
from actually
world
being conveyed. You prevent knowledge from actually being
worse.
attained. You
just spread
disengage with no good
misinformation as a grown
faith.
adult.
You're
You're saying that
dishonest.
the Earth is flat. Like, what the hell's wrong with you?
So you still don't have an argument to prove
Or
that you know
what's
the
wrong
Earth
with
is
the
a
world?
ball.
Because you don't want to improve in science
You
and
still
medicine and all
don't
this other
know.
stuff because you just deny everything.
You still don't know. You still don't have an argument.
You mean have an argument? We're not arguing.
So present your argument if you have an argument.
I don't have an argument to present to you.
Exactly. So you don't know the Earth is a ball.
First that I did. I don't know that the Earth is a ball. No, I do know that the Earth is a ball. I'm not gonna
Okay, now you're
go in circles
contradicting
because you don't
yourself.
know.
Because if you don't have an argument, if you don't have an argument, then you don't know. If you do know, then you have an argument. So make up your mind.
That does not follow. I don't need
Of
to
course
argue
it is.
something
That's
to know
what
it.
it means to
Okay,
know
how does
something.
that make sense?
It's exactly what it
I
means
need
to know
to
something.
know something to be. Wait, what are you talking
Yeah, so
about?
when you know something, you have a
I have to argue
logically sound
something to be
argument.
able to know what
Yeah,
I'm
so
talking
when,
about?
when you
What are
know
you talking
something, right? So when you
So
know
someone can
something,
just not want to argue
yeah. So
something very obvious,
when you know something,
and that
right?
makes
Because
it
you actually don't
that
want to
makes them not
listen.
knowing about
I
that.
would have
Like,
to say because you
what's
know
your
you can't
logic?
debate this epistemological subject. So when you know
No, I
something
can.
and you're still
I
doing it,
remember when I was asking you questions before. You
and you're
just said
still
something
interrupting
and you
the
didn't want to
answer
back
because
it
you
up.
don't actually want to engage in good faith. You're dishonest. You make the world worse.
You don't engage in good faith, dude. Like,
Yeah. So
insane.
keep
You
making the
lose
world
your
worse
voice
and see what happens to you.
Yeah,
You
dude.
think you're not
You
going to
keep
suffer
making the
any
world worse.
repercussions for your
The
actions,
Earth
but
is
you
flat.
will.
You think NASA's lying to you about everything else?
Yeah, you
you're
will.
doing.
You're going to suffer
Telling
repercussions
me
for your
that,
actions.
oh,
Make the world worse.
Like, shut the
You
hell
don't
up,
want to
dude.
engage in good faith. You disrupt
Think that
every
we live
time
in
someone
an
tries to
affirmative,
answer
dude.
you. You
You're
disrupt every
insane.
time someone tries to refute you. You don't know what you're talking about.
What are you gonna
You
refute?
don't know the Earth is a ball. You don't have an argument to demonstrate that you know this premise to be true. It's very simple. If you did know,
You can
then you'd
say I
give a
don't
logically
have an
sound
argument.
argument to justify your concluding premise which you believe to be true. But you don't have a logically sound argument to justify your concluding premise which you believe to be true. Therefore, you don't know the premise that you
Or I
believe to
don't
be
feel,
true.
or I don't feel like it right now. Or I don't feel like it right now.
Yeah,
Or
because
that.
you don't have one.
Okay, so
You're making that assumption.
here's a better articulation here. Russian Soyuz launched to space station aborted last minute in rare delay. 3 crew members, 1 Russian, 2 Americans, were not in danger, says NASA. Russian Soyuz suffers last minute abort during launch. 3 astronauts safely returned to Earth. Or I guess 3 astronauts, 1 cosmonaut. in a rare abort state on the launch pad on the today, 21st of March. Russian agency successfully does abort launch, saving 3 astronauts. All return safely back to the Earth. Because normally that's a one-way trip. Either you make it to the ISS or you die. There's no like in between. So this rare successful abort is I guess something to look into. I mean, if you really think the Earth is a globe and manned spaceflight is possible, or that they're going to outer space, check out like why was this one successful where all the other ones failed. This is
Not even an
something.
argument, dude.
Yeah, it should be enough entertainment here. This is like big brain shit. How did the split second decisions by the shot callers save these 3 people's lives? I don't know if they're men or women. Looks like from the photo, 1 man, 2 women.
I don't know, man. We don't know the specifics of it.
A dark comet is supposed to be visible. It won't swing by Earth again for several decades.
Boy, Spheroid pilot says they never left the ground. Exclamation mark.
Who's hot micing?
So besides insolent disruptions and non-arguments and condescension and pretension, does anyone want to present an argument to demonstrate that they know the Earth is a ball? Anyone? The floor is open.
Who's hot mic? Is it me?
Yeah, you got some like piano music in the background.
There we go. I think I fixed it.
New study suggests that planets are chomped by stars instead of being swallowed, as previously talked or whatever. As previously thought, they take bites at a time. That'd be good with a Pac-Man meme or Pac-Man GIF.
Elijah. Oh, there you are.
Oh, I'm sorry. I'm sorry. What?
What you doing?
Just hanging out with my friends, watching passively watching this. You heard about the Nickelodeon Disney whole thing show?
A particular show or a show about the companies?
Oh yeah, Gregory, you gotta, especially because I mean we've done the real in-depth stuff, like the predatory stuff. But so the show is like, what is it called? Uh, Quiet on the Set, and it's basically about like Dan Schneider, like doing all of this sexual, yeah.
Mm-hmm.
Yeah. Mm-hmm. So, yeah.
Yeah, at your house.
Yeah. Yeah.
you know, yeah, we could watch that. We could watch that sometime today even. I would have to have a strong battery, not a low battery, because Discord is very battery consuming.
This is yeah, for sure. Yeah, it's still early. It's still early. Yeah. Plus the weekend is coming up. I know we missed last weekend, but definitely this weekend for sure we catch up.
Y'all willing? Yep, indeed. I don't think we sound similar. I mean, I can I can conceive why someone would think that if they're not listening, intently. But we don't sound unless we both talking at the same volume like this.
Yeah, no, there's a super distinct difference.
I think my voice is deeper.
Uh-huh.
All right, so it looks like
it's more graham crackery.
it looks like it was an auto for the launch today. There was like a system in place that will auto abort if a fault is detected. The last time this happened was 2018, where the rocket failed 2 minutes after blastoff, sending the crew capsule into a steep ride back, but a safe landing. It's always funny to look at the comments. The Devil Comet will be visible for 10 days in the Northern Hemisphere.
Graham crackery. My voice sounds graham crackery.
More graham crackery.
Is it the sweetness? Is it the roughness? Is it the cracking?
That is what a graham cracker is. Yeah, that makes sense.
Is it all the above that I said, and etc.?
Yeah, with mixed with a little bourbon.
That's crazy. I like that. I like that. That's in the record of history. You get to paradise. Like, remember what you said on Discord? That was crazy.
Wasn't a graham cracker one of the things that NASA had claimed to invent?
Don't stop.
There's no
Are
way.
you serious?
There's no way.
No, they didn't. No.
You know, it's funny because people attribute like NASA to creating Velcro, and that's messed up because the Russians did. The Americans always try to steal stuff.
If you go through the list on the Wikipedia page of all the things NASA invented and actually look up who really invented it, you're like, holy fuck, that's evil. Can you imagine inventing something? Like you got a great idea. You do all the steps, one step after another, and you finally bring a product to market, engineer something, and just NASA yoinks that shit.
I can, and it's infuriating me.
Like your name will just never be like someone looks up Velcro and you're just like the dude who really invented it, and it says NASA. You're like, fuck.
Yeah, you're not even like Eli. Listen, right? You're not even like Thomas Althouse, who can be on record, setting the record straight. Who is the mind behind the script for what became the Matrix? You're not even that person. Just not aware. No one is aware of who you are.
It's pretty sad. The biggest like movie in comic, the biggest movie in history, and like no one knows what we know about that Tom Althouse character. Like at the bare minimum, you should know about it. Like whether you look into it, whether you know.
I had no idea, and I thought I knew the truth, because what people usually, what some folks who look into this with whatever greater or lesser degree of depth, is it's this I forget her name, but this brown skinned woman supposedly is the true author of the script what became the Matrix, but it's not her. And brown skinned U.S. Americans, they just gobbled that up. Pseudo exposés. That's evil. I'm exposing evil. That's also a lie. Well, yeah, Eli. Oh yeah, crit also. This should have been happened. Okay. Yeah, call me up whenever you want. Yep. And crit, finally.
Yeah, I'm here.
Should have been did this for you. Look in your DMs. In my little server.
Yeah, I got it.
You can definitely repeatedly, however often you want. However often, seriously, however often you want. Post all them articles. Post whatever.
Okay.
You know. I mean, you see the title of the server, of course. You know what the server is about, so of course not anything, but you know.
Yeah, I hear you. Yeah, I was a couple, I don't know, like a month ago. It's about a while back. I was gonna say, like, dude, can I get an invite? But I thought maybe there's a reason why you weren't. You didn't send me one.
Yeah, sometimes it just doesn't cross my mind. Gregory should have been sent crit or whoever else an invite. Yeah.
the thermal blanket is kind of tricky. Like if you say like thermal blanket, who invented it? And it's like NASA. But then you say, what's a thermal blanket made out of? And it's like it's made of mylar. Well, who invented mylar? And then you find out who really invented it.
And it was not an employee of NASA.
No. It was, invented by Techstar Fundamentals in 1952.
So now, $64,000 question. What did NASA distinctly invent?
They just took the mylar and cut it into blanket size and then say, mylar blanket.
Is that the only thing they invented? Did they invent anything else, supposedly?
Well, no, they got the cordless drill, rechargeable batteries, like Velcro, but all kinds of stuff they take credit for.
Right, so what did they really invent?
Weapons. I'll give them credit for that. They invented some of the most destructive weapons that humanity has ever seen.
I think I know the answer to this question. Correct me if I'm wrong. Jack Parsons was a high-level member of NASA, correct?
Yeah, he was one of those, those guys kind of behind the scenes type thing, contractor, having to do with, astro engineering at the very beginning, the ground level. He was kind of like the mad scientist of America. Like they have, that, oh crap, I'm drawing a blank all of a sudden. Oh, von Braun. Like von Braun was like the mad scientist for the Russians or the Germans. That Jack Parsons was like the American version of him, of von Braun. This is like one of their very first shows when Brandon was still around. I just tuned in. I was like, hey, what's this other flat Earth guy? I tuned in, and he had the whole episode, like the whole night was all about Jack Parsons in a cult, in kind of like old god, Call of Cthulhu type crap,
To be honest, I did drop out for like a couple seconds, but I can tell what you were saying. You were talking about the occult that he was involved with.
Yeah, I was saying he was like the sort of in the mad scientist of America. So you had von Braun was like that mad scientist for Germany. Jack Parsons was like the American version of the mad scientist.
So when you open up the when you search up his name, of course, the knowledge panel, right there, May 8, 2023, from JSTOR, Sex Cult Rocket Man.
Yeah, I didn't know this part. So he died at like 37.
He was young.
The FBI was following him and spying on him.
Cause of death, explosion.
He fled to Mexico and set up some sort of explosives factory for the Mexican government. And there was he had a home laboratory that caused an explosion, which he was mortally wounded. His arm, leg, and half his face was blown off. Despite the critical injuries, he was able to survive to the hospital, but then died there of wounds.
I'm surprised that his occult involvement is not buried. It's like front and center, even on a Google search. It's just too well known.
His mother took once she found her son had died, her mother took a lethal dose of barbiturates. It turned out they found the cause of the explosion was he was mixing fulminated mercury in a coffee can and he dropped it.
SMH.
Colleagues said this is not true, that he was always exceptionally neat and practiced safety protocols. This is from Wikipedia. I'm paraphrasing it. They believe that he was found dead because someone gave him a lethal dose of morphine. Police closed the case anyway.
Wait, he was a part of a group. He the suicide. He was a part of a group called the Suicide Squad, a trio of young rocket boy founders.
Yeah, this is like a rabbit hole you can go down deep.
Like, because you recognize that fictitious group of so-called anti-heroes, the Suicide Squad, from Marvel comic. No, is it Marvel? No, it. Oh my God. Yeah, it's DC. Never mind. Yeah, DC.
He's got a moon crater named after him. Parsons is credited for inventing the space shuttle. Maybe that's why it involves blood magic, sacrifice magic. They have to detonate them and stuff. Like,
Yeah, well, Crit, anytime. Message me, DM me, interact in the server. It's all good.
all right, take care. See you next time.
See you later. God bless you.
God bless you too.
spinning, wobbling, tilted space ball flowing through a never expanded void of total darkness.
What Americans on the top? Just even pool. I mean, the we compete with Europe because I watch a lot of pool and stuff. I play pool, whatever. Even the pros and stuff like Shane Van Bommel. He traveled around the world. He went to Asia, Europe, everywhere, bro. And the guy's a fucking beast. He won like 5, world champ, and he got so many titles on his belt. And he's from South Dakota. Beast. He's a little deaf, but he's a fucking beast, man. And that's one of American top player in pool.
No, yeah, but if you look at everything, like America is on top in like every aspect of competition all over the world, and except soccer. Like even hockey, right? Like they're always like in the top 3, top 5, but like when it comes to soccer, it's like they're always in the middle, right?
Right.
Oh well. Such is life.
Hey Sheepdog, it would be crazy if you try out for the UFC and you get to meet what's that guy's name? He's also a flat earther. Bright Mitchell. That's his name, right?
Yeah, Bryce Mitchell is one of them. Yeah.
Yep.
I met Eddie Bravo.
Oh, okay. How was he like, Eddie Bravo?
Bro. So Eddie Bravo is a normal ass dude. Like he is so fucking cool in person. Like he's humble. Like he's like, he doesn't want all the energy on him, but he takes control of what he knows he has to do. Right.
Right.
Like so he came like so I train at 10th Planet in Dallas.
Oh wow.
And he visits all of his schools, right? He tries to make it a plan to visit every school at least once a year. And so he goes there and he teaches, right? And like even if he doesn't make it to the school, he tries to make it to the region. And then he encourages the other schools to come visit. So like I think 2 other local schools came to the Dallas school when he came to visit us. And so there was like 50 people there, 60 people there. And he basically just went over philosophy of jiu-jitsu and everything like that. And he made a joke. He's like, man, like sometimes you got those dudes and they're just like really good with their guard and they get all inverted like they're in outer space. And I was like, is that even a real thing? He's like, if it were real, then yeah, they would be inverted like they were in outer space.
That sounds like Edward Bravo, bro. Hey, but you remember he did one podcast with Eric Dubay, and the topic is about flat Earth, right? And the shirt is say 10 Planet.
Oh yeah.
You remember that one?
Cool. I'm cool with him doing 10th Planet because like really if you think about it, his jiu-jitsu is out of this world, right? So I'm like, okay, let's play Fantasyland. 10th Planet is a cool name. Yeah, it just hits hard, just like with Mike Tyson, baddest man on the planet. Like that's just a badass sounding name, right?
Right.
So I don't give him shit for I don't sit there and talk shit because of he's like, oh, 10th Planet Jiu-Jitsu. Like, dude, 10th Planet Jiu-Jitsu
It's just
is
a
like
name.
the most
Yeah.
gangster, but it's the
it's
most
just a
gangster
name,
jiu-jitsu I can think of. Like there's other schools, but like he's got like 30,000 students and they're all fucking fighters, bro. Like every single one of them in their own right would go and fuck somebody up.
Right.
So kudos to Eddie Bravo for developing a system of fighters that makes people
Right.
want to be fighters.
And you know one thing too. I know he's not everybody cup of tea, but Eddie, like, people like Eddie Bravo is also the reason why people look into flat Earth, right? He might doesn't has the best way of explaining flat Earth, right? Like, I mean, in a term of like, scientific and all that stuff, but he just have this way to reel people in, at least look into it. You know what I'm saying? Like he always say, "Oh, just look into it. Just look into it." So
Right.
I gotta give him that. Yep.
No, and I tell them the other way around, right? Like a lot of people say, "Oh, you're the reason why I got into flat Earth." I tell them, "You're the reason why I got into jujitsu." I got to
That's
tell him that
amazing.
too. I was like, "Dude, I'm a flat earther," and I told him that. I was like, "I'm a flat earther," and I always wanted to do jujitsu, but I always made up excuses, and it was always for money, right? And then one day I was
Right.
like, you know what? I just need to do it. And I was like, I wonder if there's a 10th planet in Dallas. And he just started busting up laughing.
Right. See, like I've been trying to get contact with him